All right, let's take a look at the quiz. For the first question, we're given to evaluate negative 2x minus 1 for an x value that's equal to negative 2. So the idea, if you get this type of problem, let's just write the algebraic expression we're given. So negative 2. In the place of x, let me just put some parentheses here because we're going to be plugging in. And then I'll put minus 1 here. And the idea is that we're given an x value of a negative 2. So you're just going to plug that in for x and then go through and simplify and see what you get. So again, in the parentheses here, I'm just going to plug in a negative 2, and then I'm just going to go through and see what I get. So negative 2 times negative 2 would be positive 4. So let's write positive 4 there. And then, of course, we have minus 1, and 4 minus 1 is simply 3. So the answer for this first question would be 3. We're basically saying that this algebraic expression, negative 2x minus 1, has a value of 3 when we let x be equal to negative 2. Okay, let's look at the second question. Here we want to evaluate. We have 5, and then again, in the place of x, let me use some parentheses. So some parentheses there. So 5x is going to be squared. And then we have this minus 3. And again, I have x, so let me use some parentheses. And then after that, we have plus 1. So then plus 1. So I think it's a little bit easier if you use these parentheses here, especially if you have multiple x's in your problem. And the idea is we want to substitute a negative 1 in everywhere there's an x. So everywhere I put parentheses here, and then we'll just see what we have. So let's put a negative 1 here and a negative 1 here. So if I square negative 1, again, the negative and the 1 are both squared, that's positive 1. So this would be 5 times 1, and then you could treat this as negative 3 times negative 1. That would be positive 3, so plus 3, and then plus 1. So here I would do 5 times 1, which is 5, and then plus 3, and then plus 1. And then I could just run through this. 5 plus 3 is 8. 8 plus 1 is 9. So 9 is the answer I'm looking for. So again, we're saying that this algebraic expression 5x squared minus 3x plus 1 has a value of 9 when we let x be equal to negative 1. All right, let's look at question 3, the final question. So here we're asked to simplify. We have 5 multiplied by the quantity 9x minus 1, then plus 2 times the quantity 4x plus 3. So the idea here is we're just going to use our distributive property to clean up first. So we're going to remove the parentheses. So let me write this out. So 5 times the quantity 9x minus 1, then plus 2 times the quantity 4x plus 3. So 5 times 9x would be 45x, then minus 5 times 1 is 5, then plus 2 times 4x is 8x, and then plus 2 times 3 is 6. So that's the first step. If anybody tells you to simplify, you always want to remove any parentheses. And then the other thing you want to do is you want to combine any like terms. So in other words, here we have 45x and we have 8x. Those are like terms. So what I can do to combine those, I can take the coefficient 45 and add it to the coefficient 8, and that's going to give me 53. So this would be 53 and then x. And then I have this negative 5 and then plus 6. I could just do that operation. Negative 5 plus 6 is going to be positive 1, so that's just plus 1. So we end up with 53x plus 1 as a simplified version of this guy. So this is my answer right there. All right, let's take a look at our quiz. We're asked to determine whether the following statement is true or false. We have that x equals 6 is a solution for the equation 7 times the quantity x minus 6 is equal to 30 minus 5x. Now, what you want to do is actually just plug in for x here and plug in for x there. And you're given a value of 6, and you want to see if the left and the right sides are equal. So that's all we're really doing here. So we would say 7 times the quantity, plug in a 6 for x, so 6 minus 6, is equal to 30 minus 5 times plug in a 6 for x. So that's all I'm doing. 6 minus 6 is 0. So this would be 7 times 0, which we know is 0, is equal to 30 minus 5 times 6. So 5 times 6 is 30. You would have 30 minus 30, which we know is 0. So you get 0 equals 0, which is a true statement. So x equals 6 is going to be the solution for this equation. We would mark true. All right, let's look at the second question now. We want to determine whether the following statement is true or false. We have x equals negative 3 is a solution for the equation. And here we have 6x minus 30 is equal to negative 4 times the quantity 7x minus 3, then minus 8. So again, all I'm doing here is I'm plugging this negative 3 in for x in this equation that I'm given. I'm going to see if the left and the right sides are equal. Okay, so let's go through this and see what we get. We have 6 times, in the place of x, I'm going to put a negative 3, then minus 30. We'll say this is equal to, we've got the negative 4 times the quantity 7, and then you have an x. So let me put some parentheses here. Again, I'm just going to plug in a negative 3 for that x, then minus 3, close that down, and then put minus 8. Okay, so on the left-hand side, 6 times negative 3 is negative 18. So let's write negative 18 and then minus 30 over here. And if I do negative 18 minus 30, that's going to give me negative 48. So on the right-hand side here, inside the parentheses, 7 times negative 3 is negative 21. And then negative 21 minus 3 would be negative 24. So let me actually show this in multiple steps. So you'd have negative 4 times the quantity. This would be negative 21 minus 3 like this. And then negative 21 minus 3 would be negative 24. So this is negative 24. Then if we do negative 4 times negative 24, that would be positive 96. So let's write this as 96 minus 8 like this. And then if we execute this, 96 minus 8 is going to be 88. So we can see that this right here is a false statement. This is false. So that tells me that x equals negative 3 is not a solution for the equation. So therefore, the answer I want to select here is that this statement is false. All right, let's look at question 3 now. So we're asked to determine whether the following statement is true or false. X equals negative 2 is a solution for the equation 7x equals 7 times the quantity 6 plus 4x. So let's write 7. Again, in the place of x, I'm going to plug in a negative 2. So 7 times this negative 2. You can just write that as negative 14 down here. We'll put equals and equals. Over here on the right-hand side, you're going to have 7 times the quantity 6 plus 4. Again, in the place of x, I'm going to plug in a negative 2. Let's close that down. So 4 times negative 2 is negative 8. Let's just erase this in line. So we'll put this as negative 8 here. 6 plus negative 8 is negative 2. So this is negative 2. And 7 times negative 2 is negative 14. So this is a true statement. So that tells me that I want to select true here because x equals negative 2 is a solution for our given equation. All right, let's take a look at our quiz. For question 1, we're asked to solve the following equation, and we're given x minus 2 is equal to 7. So the idea here, if we're going to solve an equation, we want the variable to be on one side of the equation by itself and then a single number on the other. So what we can do to achieve this goal is to use inverse operations. In other words, if I notice here that I'm subtracting away 2 from x, I want to undo that by adding 2, but I got to do that to both sides of the equation. So what I would do is say that I have plus 2 over here, and then to make that legal, plus 2 over here. So again, you have to do the same thing to both sides of the equation. This is going to cancel. If you have minus 2 and then plus 2, that's 0. X plus 0 is just x. So the left-hand side is just x here. On the right-hand side, I have 7 plus 2, which is going to give me 9. So x equals 9 is the solution I want. So this guy right here. Okay, let's look at question 2. We have x plus 3 is equal to negative 12. So the idea here again is to isolate x on one side of the equation. And to do that, I'm just going to what? I have this plus 3 that's being done to x. So to undo that, I'm just going to subtract 3 away from each side of the equation. This will cancel. 3 plus negative 3 is 0. X plus 0 is just x. On the right-hand side, I just simplify. So negative 12 minus 3 would give me negative 15. So x equals negative 15 is what I'm looking for. So this answer right here. Okay, let's look at question 3. So we want to solve the following equation. We're given negative 5x plus 6 times the quantity x minus 1 is equal to 5. So let's start with this negative 5x. I'm just going to copy that. This 6 is multiplying this quantity. So we can simplify or clean up here by using our distributive property. So just distribute the 6 to each term. So this is plus 6x minus 6, right? 6 times x is 6x, then minus 6 times 1 is 6. Then this equals 5. Now from here, we can just clean up. So we know that negative 5x plus 6x would just give me x if I combine like terms. Then I have my minus 6 and then equals 5. Now from here, what do I need to do to isolate x? Well, 6 is being subtracted away from x. So to undo that, I'm just going to add 6 to both sides of the equation. This would cancel. Negative 6 plus 6 is 0. And we end up with x is equal to 5 plus 6 is 11. So x equals 11 is what I'm looking for. All right, let's take a look at our quiz. For the first question, we're asked to solve the following equation. We're given x over 2 is equal to 14. So remember, the idea here is that we want x on one side of the equation. We want a single number on the other. So x equals some number. So you need to undo what's being done to x to achieve that. And if you look at this guy, x is being divided by 2. So what is the inverse operation or the opposite operation of division? You want multiplication. So what I would do is I would multiply both sides of the equation by 2. And essentially what would happen here is we're going to divide this by this. 2 divided by 2 is 1. And 1 times x is just x. And this will be equal to 14 times 2 would give me 28. So x here just equals 28. Okay, let's look at question 2. We're asked to solve the following equation. We have negative 3x is equal to 102. So negative 3, I'm going to put times x like this to make this more visible. And this is equal to 102. So again, if I want x by itself, what's being done to x? Well, negative 3 is multiplying x. So you need to do the opposite operation of multiplication, which is division. And I'm just going to divide both sides of the equation by negative 3. Again, the coefficient of x, or what's multiplying x. So this divided by this is 1. Negative 3 over negative 3 is 1, and 1 times x is just x. And this will be equal to, if we look at this guy, 102 divided by negative 3 is going to give me negative 34. So x equals negative 34 is my solution. All right, let's look at question 3. We're asked to solve the following equation. We're given 12x minus 10x is equal to 30. So the idea here on the left-hand side is that you would just combine like terms or simplify. 12x minus 10x would be what? That's just 2x. So this is just 2x, and this equals 30. Now again, what's being done to x? It's being multiplied by 2. So I'm just going to divide both sides of the equation by 2 to undo what's being done to x. This will cancel with this and give me a 1, right? 1 times x is just x. And this equals 30 divided by 2 is 15. So x equals 15 is our solution. All right, let's take a look at our quiz. For the first question, we're asked to solve the following equation, and we are given 15 minus 8x is equal to negative 3 multiplied by the quantity 7x plus 8. All right, so the first step that we're always going to do when we have a linear equation in one variable, we want to simplify each side separately. If we look at the left-hand side, there's nothing we can do. You can just copy that. It's 15 minus 8x. Those are not like terms, so nothing you can do. On the right-hand side here, you can use your distributive property to remove the parentheses. So in other words, I can take negative 3 and multiply it by 7x, and then I can do negative 3 times 8. So negative 3 times 7x is going to be negative 21x, and then negative 3 times positive 8 would be negative 24. Okay, so now on the left side, I can't do anything to simplify, and on the right side, I can't do anything to simplify. So I move on to my next step, and that's to move all the variable terms to one side and all the constants to the other. Now, I like my variable to end up on the left, but you could put it on the right. It's really up to you. So I'm going to add 21x to both sides of the equation. And what's going to happen is, because I have negative 21x plus 21x, this cancels out and becomes 0. So basically, I have 0 minus 24, which is just negative 24. So you don't have to write the 0. Now, before I do anything with this guy right here, notice that I have this 15 over here, and I want to get rid of that. I want all my constants on the right-hand side. So I'm just going to subtract 15 away from both sides of the equation. And so what's going to happen is this is going to cancel, right? 15 minus 15 is 0. And so on the left-hand side, now I just have these variable terms. I have negative 8x plus 21x. If I combine like terms there, I'm going to get positive 13x. So let's write positive 13x, and this is equal to, over here on the right side, now I just have constants. Negative 24 minus 15, that's going to give me negative 39. Okay, so now the final step here is to isolate the variable. So how do I do that? Well, right now you have 13 that is multiplying x. So to undo multiplication, I use division. So I'm going to divide both sides of the equation by 13. Again, because that's the coefficient of x, or that's what's multiplying x. And so this guy right here is going to cancel with this guy. 13 divided by 13 is 1. And so you have 1x, or just x, is equal to, over here, negative 39 divided by 13 would be negative 3. So x equals negative 3 is going to be the solution for this equation. So coming back up here, I want this guy right here. So x equals negative 3. All right, let's look at the second question now. Again, we're asked to solve the following equation. So negative x minus 19 is equal to 6 times the quantity 2x minus 1. So on the left-hand side, we can't simplify any further. You have negative x and you have negative 19. Those are not like terms. On the right-hand side, I could use my distributive property to clean up and remove the parentheses. So let me just copy this negative x minus 19. Can't do anything with that. Here, 6 times 2x would be 12x. Then minus 6 times 1 would be 6. And so now each side is as simple as I can make it. Again, here's where you want to move all the variable terms to one side, all the constants to the other. So what I'm going to do is I'm going to subtract 12x away from each side of the equation. So we already know that this is going to cancel. 12x minus 12x is going to be 0. And then what I'm also going to do is I'm going to add 19 to both sides of the equation. And we know also that this is going to cancel. Negative 19 plus 19 is 0, so that's gone. So on the left-hand side now, I just have these variable terms. So I'm going to have this negative x, and you can think about this as negative 1x, and then basically plus negative 12x. So that would be negative 13x. Then this equals. Over here, negative 6 plus 19 would be positive 13. And again, once we get to this point, well, we want to isolate x completely. And we see that we have multiplication here. Negative 13 is multiplying by x. So to undo the multiplication, I'm just going to divide. So I'm going to divide both sides of the equation by negative 13, which is the coefficient of x, or what's multiplying x. And of course, this is going to cancel, give me 1. And 1 times x is just x. And this equals 13 divided by negative 13 is just negative 1. So x equals negative 1 is our solution. So this is what I'm looking for right there. Okay, let's look at question number 3. We're asked to solve the following equation, and we have negative 7x and then plus 4 times the quantity 2x plus 3. We're going to set this equal to negative 12 plus 4x. On our left-hand side, we can certainly clean up. We can remove the parentheses here using our distributive property. So let me write negative 7x, and then 4 times 2x would be 8x, so plus 8x. Then 4 times 3 would be 12, so let's put plus 12. And this equals my negative 12 plus 4x. Now on the right-hand side, I can't do anything else, but on the left-hand side, I do have these like terms. I have negative 7x and I have 8x. So I want to continue to simplify until I can't anymore. So negative 7x plus 8x would be just x. So let's write this as x plus 12 is equal to negative 12 plus 4x. So now each side is as simple as I can make it. So again, I want to move all my variable terms to one side and all my constants to the other. So let's subtract 4x away from each side of the equation. And we can see that this is going to cancel. 4x minus 4x is 0. That's gone. Then I'm going to subtract 12 away from each side of the equation. And so we'll see that this will cancel. 12 minus 12 is 0. So what I have now is x minus 4x on the left-hand side. And that's going to give me, again, you could just put a 1 here. That's going to give me 1 minus 4, which is negative 3. And then times x. And this equals, over here, negative 12 minus 12 would be negative 24. To finish this up, again, think about what's being done to x. It's being multiplied by negative 3. So I'm just going to divide both sides of the equation by negative 3. Again, that coefficient of x, this cancels. And what we're going to end up with is x is equal to negative 24 divided by negative 3 is going to be positive 8. So x equals 8 is our solution. So we want this guy right there. X equals 8. All right, let's take a look at our quiz. For the first question, we're asked to solve the following equation. And we're given 2 is equal to, we have negative 8 thirds times x, then plus 1, then plus 7 thirds. So if you have an equation with fractions involved, you can choose to clear the fractions or you can choose to just work with the fractions. It's really going to be up to you and your personal preference. I am going to choose to clear the fractions just so we get some practice. You'll notice that you have a denominator here of 3 and a denominator here of 3. So what we'll do is we'll multiply both sides of the equation by 3, and that's going to clear all those denominators. So over here on the left, I would have 2 times 3, and this equals, you'd have negative 8 thirds multiplied by 3, then times x, then plus 1 is multiplied by 3, then plus 7 thirds is multiplied by 3. So remember, if you do this, you're multiplying every term in the equation by 3 to make everything legal. Okay, so we know that 2 times 3 is 6, and this equals, this cancels, negative 8 times x is negative 8x, then plus 1 times 3 is 3, then plus this cancels, you would get 7. Okay, on the right-hand side, you'll notice that you have 3 plus 7. We could just simplify that and say it's 10. So let's write 6 is equal to negative 8x plus 10 like this. And now we're at the step where we've simplified everything as much as we can. And basically what you want to do from here is move all your variable terms to one side and all your constants to the other. So I like my variable to end up on the left, but what I'm going to do is actually just subtract 10 away from each side of the equation. And I'll go ahead and flip this in a moment. So let me cancel this. And let's say 6 minus 10 is going to give me negative 4. So I'll say negative 4 is equal to negative 8x. And I am legally allowed to flip that. So I can basically just say that negative 8x is equal to negative 4, right? So these are basically saying the same thing. And now what I can do, since negative 8 is multiplying x, if I want to isolate x, I just divide both sides of the equation by negative 8. And we know that negative 8 divided by negative 8 is 1, and 1 times x would just be x. So this equals negative over negative is positive. And basically we know that 4 over 8 would just be a half, right? So x equals 1/2 here. That's going to be our solution. So coming back up here, we would circle this one, x equals 1/2. Okay, let's look at the second question now. We're asked to solve the following equation, and we have 25 over 18. We'll set this equal to, we have 5/4 times x, then minus 5/3 times x. Okay, so clearing the fractions in this case is a little bit more challenging because finding the LCD is more involved here. So 18, I would factor that first, and I would say, well, this guy is going to be what? You can think about it as 3 times 6, and 6 is 2 times 3. So let me write 3 squared, or 9, times 2 like this. Okay, so everything is factored completely. All right, then 4, we know that's 2 times 2. Let me just write 2 squared. And then 3 is a prime number, so let me write 3. And you can put to the first power here. You can put that to the first power there. So when we think about these denominators and their prime factorizations, if we want to find the LCD, remember, you want to find the least common multiple of those denominators. So basically to do that, if I was to say, okay, what is the LCM of 18, 4, and 3? Essentially what you do is you list each prime factor, and if there's a duplicate among the factorizations, you go with the highest number of repeats among those prime factorizations, okay? So in other words, you're looking for the highest power that occurs, and so in this case with 3, you would go with 3 squared, because over here it's 3 to the first power, so you go with the highest power, so you go 3 squared. Then times, here it's 2 to the first power, here it's 2 squared, so I'm going to go with 2 squared. So 3 squared is 9, 2 squared is 4, 9 times 4 is 36. So this is my least common multiple of 18, 4, and 3, which is known as my LCD, or least common denominator, that I can obtain. So I'm going to multiply both sides of the equation by 36. So let's go 36 times 25 over 18. This equals, we'll have 36 times 5 over 4 times x, then minus 5/3 times 36, then times x. Okay, so 36 divided by 18 is 2. 2 times 25 is 50. This equals 36 divided by 4 is 9. 9 times 5 is 45. Then times x, then minus 36 divided by 3 is 12. 12 times 5 is 60. Then times x. Now on the right-hand side, we can combine like terms. We see that 45x minus 60x would be negative 15x. So let me write 50 is equal to negative 15x like this. And again, it's perfectly legal, if you're like me and you like your variable on the left-hand side, to rewrite this and say negative 15x is equal to 50. These two are saying the exact same thing. 50 is equal to negative 15x. Here, negative 15x is equal to 50. Okay, so how do we get x by itself? I'm just going to divide both sides of the equation by negative 15. Again, the coefficient of x, or what's multiplying x. And we're going to see that this basically here is going to cancel with this and give me 1. So I have 1x, or just x, is equal to 50 over negative 15. We know that's negative. And I can see that I have a common factor of 5. So in other words, I could write this as 5 times 10. And I could write this as 5 times 3. And let's cancel this 5 with this 5. So basically our answer is going to be that x is equal to negative 10 thirds. Let me make this 3 a little bit better. So let's go back up. And we're looking for this answer right here. X equals negative 10 thirds. Okay, let's look at question number 3 now. We're asked to solve the following equation. We have negative 7.7x plus 0.1x is equal to negative 22.04. All right, so if you want to clear the decimals from your equation, again, it's completely unnecessary, it's just up to you, then what you would do is count the number of decimal places you have. So you have 1 here, you have 1 here, and then you have 2 here. So when you find the highest number of decimal places, in this case it's 2, you're going to multiply both sides of the equation by 10 raised to that power. So here it's 10 squared, right? If you had 3, then it would be 10 cubed. If you had 4, it would be 10 to the 4th power, so on and so forth. So 10 squared is 100. So I'm just going to multiply everything by 100, and that's going to move the decimal point 2 places to the right. Let me show that so no one gets lost. So 100 times negative 7.7x plus 100 times 0.1x is equal to negative 22.04 times 100. So on the left-hand side, again, if I multiply something by 100, I'm just moving the decimal point 2 places to the right. So this would be negative 770x plus this would be 10x is equal to, this would be negative 2,204. Okay, so from here, I don't have any decimals, and I can just solve this normally. So on the left-hand side, negative 770x plus 10x would give me negative 760x, and this equals negative 2,204. As a final step, I'm going to divide both sides of the equation by this negative 760, the coefficient of x. Now, if you want to list your answer as a fraction, you can, but I'm just going to report my answer as a decimal because we were working with decimals. This is completely up to you. So I'm going to cancel this and put x is equal to, I'm going to punch this into my calculator, and I'm going to get 2.9. So x equals 2.9 is my solution. So coming back up here, I'm just going to put x equals 2.9. All right, let's take a look at our quiz. For the first question, we're asked to identify the following equation as conditional, an identity, or a contradiction. We're also asked to give a solution if possible. So our first example here is 5 times the quantity 12 plus 10x. This is set equal to negative 10 times the quantity 1 minus 5x. All right, so I'm just going to simplify each side to begin. On the left-hand side, we would distribute 5 to each term inside the parentheses. So 5 times 12 is 60, then plus 5 times 10x is 50x. This equals negative 10 times 1 is going to be negative 10. And then negative 10 times negative 5x would be plus 50x. Now you can see that you have a problem because you have 50x on the left and you have 50x on the right. So just think about this logically. Whatever I plug in for x here and here is going to result in the same value. Okay, so whatever it is. But then you're adding 60 to it here and you're adding negative 10 to it here. So how can these two sides ever be equal? Well, they can't. So that's the problem here. And you can show this more cleanly if you just subtract 50x away from each side of the equation. And what happens is this cancels and this cancels. And what we're left with is a false statement. You would get 60 is equal to negative 10, which is false. So this guy right here is known as a contradiction. There's no solution. In other words, there's no real number that you can plug in for x that would satisfy this equation. So we come back up here, we'll say this is a contradiction, and there's no solution. Okay, let's look at question 2. So once again, we're asked to identify the following equation as conditional, an identity, or a contradiction. Give a solution if possible. So we have 3 times the quantity x plus 6 is equal to negative 9 times the quantity negative 4 minus x. Okay, so looking at this guy, again, I just want to clean up and simplify each side. So 3 times x would be 3x, then plus 3 times 6 would be 18. This is equal to negative 9 times negative 4 is positive 36. Then negative 9 times negative x would be plus 9x. Okay, so from here, I'm going to move all my variable terms to the left, and I'm going to move my constants to the right. So I'm going to subtract 9x away from each side of the equation. And we know that this is going to cancel. And then also I'm going to subtract this 18 away from each side of the equation. And we know that this is going to cancel. So 3x minus 9x is going to give me negative 6x. And this would be equal to, let me erase this to make this a little bit better. Over here on the right, 36 minus 18 would be 18. We'll divide both sides of the equation by negative 6 to finish this up. We show that this cancels. And what we have is that x is equal to 18 divided by negative 6 is negative 30. So this is a conditional equation, right? So basically, this equation is true when x equals negative 3, and it's false otherwise. So it's true under that condition. So coming back up here, we see conditional, x equals negative 3. Let's circle that one. Okay, let's look at the final question, question 3. We're asked again to identify the following equation as conditional, an identity, or a contradiction. Give a solution if possible. So we have negative 8 times the quantity negative 6x, then plus 6, then plus 6, and this equals, let me slide this down a little bit so I can fit it. We'll have the negative 12 minus 6 times the quantity 5 minus 8x. On the left-hand side, negative 8 times negative 6x is going to be 48x. The negative 8 times 6 is going to be minus 48. Then you have plus 6. Now, of course, we could just simplify this now. Negative 48 plus 6 is negative 42. So let's fix that right there. We'll put this equal to. Over here, I have negative 12. And then you have, I'm going to treat this as negative 6. So negative 6 times 5 is going to be negative 30. And then negative 6 times negative 8x is going to be plus 48x. Now over here, negative 12 minus 30 is going to be negative 42. So what you have here is an identity. You have the exact same algebraic expression on the left as you have on the right. In other words, what you could do here is you could subtract 48x away from each side of the equation, and this would cancel here and here, and you're left with negative 42 is equal to negative 42, which is always true. Okay, so we end up with a true statement here. So this is an identity. It doesn't matter what I plug in for x because it's always going to result in the same value on the left as on the right. So we come back up here and just say that this is an identity and there's infinitely many solutions because, again, I can just plug in any real number that I want and I'll always get a true statement. All right, let's take a look at our quiz. For the first question, we're asked to solve each word problem, and we're given that two brothers, Jason and Steve, are different ages. Jason is 7 years older than Steve. If their combined age is 47, how old is each person? So the idea here is that once we solve our problem, we should figure out what is the age of Jason and what is the age of Steve. So that's our goal. So the first thing I'm going to do is I'm going to let a variable, you could use X or Y or Z, whatever you want to use, be equal to the age of one of those people. So it could be Jason, it could be Steve, whatever you want to use. So I'm just going to let's say X be equal to, and let's see, we have Jason is 7 years older than Steve. So let's just start with Steve. So X is going to equal Steve, or actually more specifically, Steve's age. Okay, so then how can we model Jason's age? Well, we know that Jason is 7 years older than Steve. So basically, since X represents Steve's age, then we'll say X plus 7 is going to represent Jason's age. So I'm going to say then we'll say X plus 7 will be equal to Jason's age. Okay, so from here, we just want to make ourselves a little equation. And what we see here is that in the problem, it says their combined age is 47. So combined means if we added their two ages together. So in other words, if we took Steve's age, which is X, and we added that to Jason's age, which is X plus 7, the result, let me make this 7 a little bit better, the result should be 47. So let's solve this equation, and when we get our solution for X, we'll know Steve's age, and then we can add 7 to that, and we'll find out Jason's age. So we'll come back up to this in a moment, and what I'll say here is that we would have X plus, you can just drop the parentheses here, so X plus 7 equals 47. X plus X is 2X, then plus 7 equals 47. Let me subtract 7 away from each side of the equation so that I can isolate this 2X part. So subtract 7 over here, subtract 7 over here. This would cancel. And what we're going to have is 2X is equal to 47 minus 7 is 40. Let's divide both sides of the equation by 2. This cancels. You get X is equal to 20. Okay, so we have X equals 20, but again, when we're solving a word problem, we can't just list X equals 20 as our answer. We have to make sense of what we just found. So coming back up to the top, again, we said that X was Steve's age. So we know Steve is 20 years old. And then we said that X plus 7 was Jason's age. So again, if X is 20, 20 plus 7 is 27, so that's Jason's age. So my answer here is I'm looking for that Steve is 20 and Jason is 27. So I want this guy right here. And again, you can check that just by going back to the problem and saying that Jason is 7 years older than Steve. Well, Jason is 27 and Steve is 20. So that checks out. So you can put a check mark there. And it also says their combined age is 47. Well, 20 plus 27 is 47. So you can put a check mark there. So we know this is the correct solution. Okay, let's look at question 2. This is a very similar problem in terms of the setup. So again, we're asked to solve each word problem. We have that the owner of a local cafe found that the orders for coffee one Monday were double that of tea. If the orders for both were 30, how much of each drink type was sold? So again, a very similar setup to the last problem. You're given a sum here of 30. So it's going to be set up the same way. But let me start by saying we're going to let X be equal to, and again, you could use either one of these. You could use the tea or the coffee, whatever you want to do, and just represent the other one in terms of what you chose. So I'll just go with the orders of tea, and I'm just going to put T here for short. I don't want to write everything out. It'll just take too long. So X is going to be equal to the number of orders of tea that this cafe received on that Monday. So then how can we represent the number of orders for the coffee? Well, it says here specifically, if we read back through, that the orders for coffee were double that of tea. So if T is represented by X in terms of the number of orders, well, then the coffee would be 2 times X. That's what doubling something is. It's multiplying it by 2. So we would say 2 times X is equal to, let's just put coffee. I'm not going to put orders of coffee, so let's just put coffee. So COFFEE. And basically, once we have this set up, again, we go into our equation, just like in the last example. We see here that the total orders for both were 30. So that just means I'm going to combine the two. So in other words, X plus 2X, so the number of orders from T, which is X, plus the number of orders for coffee, which is 2X, is given to me right there, 30. Okay, so we just have to solve this equation. We'll know how many orders we got for T, and then we can multiply that by 2 to get the number of orders we got for coffee. Let me slide down here and get some room. So x plus 2x would be 3x. This equals 30. Very easy to solve this. We divide both sides of the equation by 3, and we'll see that this will cancel and give us x is equal to 10. So again, coming back up here, x equals 10 means that on this Monday, the cafe got 10 orders for tea. And then 2 times that amount, or 20, that's how many orders they got for coffee. So I'm looking for 10 for tea and 20 for coffee. So I want this guy right there. All right, so this next problem, you may have struggled with it for a little while, but hopefully you got it. If you didn't, I'm going to go through the solution here. So for question 3, again, we're asked to solve each word problem. So this is a very common formula that you see in algebra. It's I, which is the simple interest earned, is equal to P, which is the principal or the amount that is invested, times R, which is the rate, which is given as a decimal, times T, which is time. Generally speaking, this is going to be in years, but in some cases it might not be. Just depends on the situation. So let's read through the problem, and then we'll go through the formula and try to make sense of it. So we see here that Samantha inherited some money from her aunt. She deposited part of the money in a savings account paying 8% annual simple interest and $10,000 more than that amount in a different account paying 2% annual simple interest. The annual simple interest earned from both accounts is $7,200. How much money was invested at each rate? So generally speaking, when you think about this problem, you want to start with a general understanding of the simple interest formula. When we go to our bank accounts now, we get something called compound interest. So that means if I deposit money into the account, it earns interest and that interest earns interest. With simple interest, that's not how it works. You just earn interest on the principal and you never earn interest on the interest. So in other words, if I deposit $1,000 in a bank, okay, so this is my P or my principal here, and let's say the interest rate I get is 5%. So as a decimal, that's 0.05. So this would be my R, or my interest rate as a decimal. Well, this is what I'm going to get. Let's just say per year, if I multiply these two guys together, I get 50, right? Or $50 if you want to think about it that way. So every year I'm getting $50, and then I can just multiply it by the number of years or the time. Let's say it was 3 years, for example. This would be my time. So this formula right here would just tell me that if I invested $1,000 at 5% interest for 3 years, I could just multiply it together and I would get $150, right? So 150, this would be my simple interest earned, or my I. Okay, so that's basically how this formula works. So let's use this to solve our problem here. Okay, so the first thing whenever you start the problem is just think about what you're asked to find. So we're asked to find how much money was invested at each rate. So in other words, how much is invested at 8% and how much is invested at 2%. So let's let a variable, let's say x, be equal to the amount invested at 8%. So I'm just going to put 8% here just to keep things short, but hopefully if you're writing notes, you just put the amount invested at 8% to make that crystal clear. So then what can we say about the amount invested at 2%? Well, it says here in the problem, $10,000 more than that amount in a different account paying 2% annual simple interest. Well, if x is the amount that's invested at 8%, then that means x plus, again, 10,000 more, so plus $10,000 would be the amount invested at 2%. Again, I'm just keeping this short. You could write as a full statement, the amount invested at 2%. Okay, so that's up to you. So now that we have these two things set up, let's think about how we can go through and get ourselves a little equation going. And I have a little table set up, and I think if you're struggling with a problem, you want to write down the formula you're given and make yourself a little table, okay? So what is the simple interest that this person's going to earn at 8%? Remember, we did our formula earlier. We said if a person put up $1,000 and they got 5% interest, and they did that for 3 years, they would earn $150. So if it's unclear how to do this when you have variables involved, just make yourself a little simple example, and then just go through and model it based on that. We know that the rate here is 8%, so let's write 0.08. We know here the rate is 2%, so 0.02. So we have that. In each case, it's 1 year in terms of the time. So let's put 1 and let's put 1, because again, if we go back and you read through this, it says the annual simple interest earned from both accounts is $7,200. So when we talk about annual, we're talking about 1 single year. So the time period is 1. And really, you could delete that column because multiplying by 1 doesn't change anything. But for the sake of completeness, we're going to leave it in there. Now, when we talk about the principal amount, it's given to us right here. We've already modeled it. We know that she's going to invest X dollars at 8%. So let's put X. And we know that she's going to invest X plus $10,000 at this 2%. Okay, so we have everything we need to get this interest over here. Again, all we did here was just multiply through. 1,000 times 0.05 times 3 gave me 150. Well, I'm going to do the same thing here. I'm going to do x times 0.08 times 1, which is 0.08x. Then here I'm going to do 0.02 times 1, which is 0.02. And then I need to multiply this by this quantity. So let me go 0.02 like this. I'm going to try to squeeze this down as best as I can. So x plus 10,000 like that. We're told that the annual simple interest earned from both accounts is $7,200. So in other words, the interest she earns from the account paying 8% plus the interest she earns from the account paying 2%, the sum is $7,200. So all I need to do is figure out, okay, this is the interest she earns at 8%. So it's 0.08x. Then plus, this is the interest she earns at 2%. So 0.02 times the quantity x plus 10,000. Okay, so now we're getting somewhere. What should this be equal to? We were just told this was $7,200. Okay, so let's scroll down here. We're going to solve this equation. Again, if you want to clear the decimals, it's really up to you. You can multiply everything by 100, or you can work with the decimals. Again, completely optional. So let's just say this is going to be 8x plus 2 times the quantity x plus 10,000. And this is going to be equal to, I'm going to need to move this 2 places to the right, so 720,000, so 720,000. Okay, let me clean this up by using my distributive property here on the left. So this is 8x plus, this would be 2x, and then plus this would be 20,000, like this. This equals 720,000 over here. All right, so 8x plus 2x is going to be 10x. So let's write that. We're going to have 10x here, and then plus 20,000 is equal to 720,000. All right, to isolate this variable term here of 10x, I'm going to subtract 20,000 away from each side of the equation, and we'll see that this is going to cancel over here. And what we'll have is 10x is equal to 720,000 minus 20,000 is 700,000. And to finish things up, we're just going to divide both sides of this equation by 10. And so this cancels and you get x is equal to, essentially you're just deleting a 0 here. If you divide by 10, you move the decimal point 1 place to the left. So this is basically going to be 70,000. Okay, so we know this was the amount invested at 8%. And again, she invested 10,000 more than that into the account paying 2%. So it's going to be $70,000 for the account that paid 8% and $80,000 for the account that paid 2%. So going back up here, looking through this, we have $70,000 at 8% and $80,000 at 2%. So we want this guy right there. All right, let's take a look at our quiz. For the first question, we're asked to solve each word problem. We're told for his birthday party, Jerome mixed together 10 gallons of Ruby's fruit punch and 2 gallons of Uncle Todd's fruit punch. Ruby's fruit punch contains 28% fruit juice, and Uncle Todd's fruit punch contains 52% fruit juice. What percent of the mixture is fruit juice? So if you understand the basics of working with mixture word problems, then this problem is quite simple. If you're a little bit lost on it, I'm just going to take the time and walk you through it. And then if you get something similar in the future, it'll be really easy for you. So the first thing is I suggest to make a table. So if you come down here, I have a little table set up, and we have Ruby and then we have Uncle Todd. So those are the two names for our fruit punches that we're going to be working with. We have the gallons, we have the percentage of fruit juice, and then we have the pure fruit juice. So let's go back up. We're just going to get some information and fill in the table. So for Ruby, we're using the 10 gallons. And then for Uncle Todd, we're using 2 gallons. So 10 gallons and then 2 gallons. Let's go back. So this would be 10 and this would be 2. In the end, we're going to have a final mixture. So we can just write that in. So we'll say we'll have a final mixture. And basically it's 10 plus 2 or 12. Okay, going back up and thinking about the percentage of pure fruit juice, well, in Ruby's, it's 28%, and in Uncle Todd's, it's 52%. So let's come back down. So I'll say this is 0.28. Again, that's just 28% as a decimal. And then I'll say this is 0.52. Again, that's 52% as a decimal. Now, how do I get this pure fruit juice over here? Well, basically, I just multiply, right? So in other words, if I have 10 gallons of fruit punch, and it contains 28% fruit juice, well, then I can say, well, 0.28 times 10 would be 2.8, and that's the number of gallons of pure fruit juice in the fruit punch. Similarly, 2 times 0.52 would be 1.04. Now, I don't know this part right here yet. This is what I'm trying to find. So this is a question mark. But this one I can get right now. The amount of pure fruit juice that's going to be in the final mixture, I can just add it because it's only coming from these two sources. So 2.8 plus 1.04 is going to be 3.84. Now, if we go backwards, in other words, we started with 10 gallons and a percentage as a decimal, so 0.28, and we multiplied. 10 times 0.28 gave me 2.8. But what if I was missing this one like I am here? Well, I could divide 2.8 by 10 to get 0.28. So that's all I'm going to do here. I'm going to divide 3.84, or the amount of pure fruit juice that I have in the final mixture, by 12, the total number of gallons in the final mixture, and that's going to give me my percentage of fruit juice. So let's do that on a calculator. 3.84 divided by 12, and that's going to give me 0.32, or 32% if you want to put it as a percent. So let's go back up, and let's just mark our answer here as 32%. Okay, let's look at the second question. So we're told to solve each word problem, and we're asked how many pounds of mixed nuts that contain 60% peanuts must Jessica add to 4 pounds of mixed nuts that contain 70% peanuts to make a mixture with 62% peanuts. Okay, so what I'm going to do is let a variable, I'm just going to let x be equal to, what we're looking for is the amount of the 60% peanuts. So I'm just going to put 60% like this. And then we really don't need to model anything else in terms of this. We can just write this up in a little table. Let me go down here and I'll show you what I mean. So for the weight, we know that for the 60% peanuts, we've modeled this with x. For the 70% peanuts, it's given to us in the problem as 4. And then for the final mixture, which is 62%, well, I know I'm only getting it from here and here, so I'm just going to add the 2. It's just x plus 4. So that's all it's going to be. So I have my weight modeled. Now I need the percentage of peanuts. Well, it's given to me right here. So 60% I'm just going to write as 0.6 or 0.6 as a decimal. And then 70%, 0.7. 62%, I'll put 0.62. So pure peanuts, I'm just going to multiply, right? Just like I did in the last problem. So this would be 0.6 times x. Then this would be 0.7 times 4, which is 2.8. And then this would be 0.62 times the quantity x plus 4. Okay. Now this pure peanuts is just going to be the amount of pure peanuts we have in pounds, because this is weight and this is percentage. So if I multiply them together, I'm getting pure peanuts in pounds. Now let's think about how we can get an equation. We know the pure peanuts from this guy right here plus the pure peanuts from this guy right here has to be equal to the pure peanuts in the final mixture. Again, this is in terms of weight. So 0.6x plus 2.8 has to be equal to this 0.62 times the quantity x plus 4. Okay, so that's our equation there. Pretty simple to solve that. Again, if you want to clear the decimals, you can multiply everything by 100. It's not necessary if you're working with a calculator, but I'm just going to do it for completeness. So this would go 2 places to the right. So this would be 60x, then plus this would be 280. This would be equal to, this would be 62 times the quantity x plus 4. So what I'm going to do here, just use my distributive property. 62 times x is 62x, and then plus 62 times 4 is 248. Let me copy this on the left. We have 60x plus 280. What I'm going to do is subtract 62x away from each side of the equation. Let's show this as canceling over here. Let me slide down a little bit. And let me subtract 280 away from each side of the equation. And so this is going to cancel. On the left-hand side now, 60x minus 62x would be negative 2x. And this equals 248 minus 280 is going to be negative 32. To finish this up, let's divide both sides of the equation by negative 2. This will cancel. We'll get x is equal to 16. So coming back up here, she's going to need to use 16 pounds. All right, let's look at question 3. So again, we're told to solve each word problem, and we're given that Kayla left the movie theater and traveled south. Jenny left 1 hour later, traveling 15 miles per hour faster in an effort to catch up to her. After 4 hours, Jenny finally caught up. Find Kayla's average speed. So this one involves our distance formula. So I've already set that up for us here. I have a little table with Kayla and Jenny, and then distance, rate, and time. So remember, distance is equal to rate of speed multiplied by time traveled. And maybe I shouldn't use it looks like an x there, like a variable. So let me put a multiplication symbol like that. Okay, let's go back up. So you're going to use a variable. Let's let x be equal to the speed of one of them. You want to, in the end, find Kayla's average speed, so let's just use hers. So I'm just going to put Kayla like this, so Kayla. And you could put her average speed in miles per hour. I'm just going to put Kayla for short. And then basically, how can we model Jenny's speed? Well, it says she's traveling 15 miles per hour faster. So we'll say x plus 15 is going to be equal to, I'm going to put Jenny, but again, you could put Jenny's average speed in miles per hour. Again, completely up to you. So x is the speed for Kayla, and x plus 15 is the speed for Jenny. So for Kayla, the rate is x, and for Jenny, it's x plus 15. Okay, let's think about the time here. The time that's given to us, we're told that after 4 hours, Jenny finally caught up. So we know that Jenny is traveling for 4 hours. But it says that she left 1 hour later than Kayla. So that means Kayla traveled for an hour more, okay? So that means that she traveled for 5 hours and Jenny traveled for 4. So for our time, let's put Kayla as 5 and Jenny as 4. Now, how do we get the distance? Again, we just multiply. We go 5 times x, which is 5x, and then we go 4 times the quantity, x plus 15. And that's all it's going to be. Now, in order to get an equation, remember, if we go back, it says specifically here, Jenny finally caught up. In other words, they both started at the same place and they both ended up at the same place. So their distance is going to be equal. So let's go back here and let's set the distance here for Kayla, which is 5x, equal to the distance here for Jenny, which is 4 times the quantity x plus 15. So 5x is equal to 4 times x is 4x, then plus 4 times 15 is 60. Let's subtract 4x away from each side of the equation, and we'll see that this cancels, and 5x minus 4x is x, and that equals 60. That tells me that Kayla was driving at 60 miles per hour, and basically Jenny, although it doesn't ask for it, is driving at 75 miles per hour. So this is what we want right here. It's asking for Kayla's average speed, which is 60 miles per hour. All right, let's take a look at our quiz. For the first question, we're asked to solve each equation, and we are given 1/2 is equal to, we have x over, we have x plus 7. So if you have a proportion equation, the idea is that you want to cross multiply to set things up. And all that means is we're going to take the denominator of one fraction, so let's just start with the leftmost, and multiply it by the numerator of the other, in this case, the rightmost. So you have 2 times x, which is just 2x, so just write that. Then you're going to have equals. Now we're going to do the same thing, but I'm going to work with the denominator in this right fraction here, and I'm going to multiply by the numerator of this leftmost fraction. So x plus 7 times 1 would just be x plus 7. So that's really all you have to do to set this up. Once you have it in this format, it's just like solving any other linear equation in one variable. So from here, what I'm going to do is subtract x away from each side of the equation. And so this is going to cancel over here. 2x minus x is simply x, and this will just be equal to 7. So I've already found my answer here. I just want x equals 7, so I'm going to circle that guy right there. Okay, let's look at the second question. Again, we're asked to solve each equation. We have this x plus 4. This will be over 10. This is set equal to, now we have x minus 8, and this is going to be over 5. So the idea here is that, again, to set this up, we take the denominator of one fraction. We're just starting with the leftmost. You could have started with the rightmost. It really doesn't matter. And I'm going to multiply by the numerator of the other fraction, in this case, the rightmost fraction. So we have 10 times the quantity x minus 8. So make sure you use parentheses here because you want to multiply by that entire quantity. Then this equals, again, I'm just going to use the same process. I'm going to take this denominator and multiply it by this numerator. So we'd have 5 times the quantity x plus 4. So once you've set it up in the proper format, like we have here, just go through and use your regular procedure for solving an equation. So we would use the distributive property here to remove the parentheses. So we'll go 10 times x, which is 10x, then minus 10 times 8, which is 80. This equals 5 times x, which is 5x, then plus 5 times 4 is 20. Now what I'm going to do is subtract 5x away from both sides of the equation. And so this will cancel from over here. And then what I'm going to do also is add 80 to both sides of the equation. And so this is going to cancel over here. All right, so on the left-hand side now, you have 10x minus 5x, which is going to give me 5x. And this equals 20 plus 80 would be 100. As a final step, notice that you have 5 that's multiplying x. So I'm just going to divide both sides of the equation by 5. This will cancel. And you'll have x is equal to 100 divided by 5 is 20. So x equals 20 is what we're looking for. So just coming back up here, this is what we want. Again, x equals 20. Let's look at question 3. We're asked to solve each equation. And what we have here is x plus 7 over, we have x plus 19. This is set equal to 1/3. Again, all I want to do here is cross multiply. So I'm going to take this guy and multiply it by this guy. So 1 times anything is just itself. So I'm just going to say that I have x plus 19. Again, x plus 19 times 1 would just be x plus 19. Then this equals, now I'm going to take this 3 and multiply it by this quantity x plus 7. So 3 times, again, the quantity, you got to wrap this in parentheses, x plus 7. What I'll do from here, just use my distributive property on the right. So we'll go x plus 19 is equal to 3 times x is 3x, and then plus 3 times 7 is 21. Nothing I can really do to simplify any further. So let's subtract 3x away from each side of the equation, and we'll say that this is going to cancel. And then also what I'll do is I will subtract 19 away from each side of the equation, and we know that this is going to cancel. On the left-hand side now, I have x minus 3x, which is negative 2x. And this equals 21 minus 19 is 2. Let's divide both sides of the equation by negative 2. And so we're going to see that this cancels, and you're going to get x is equal to 2 divided by negative 2 is negative 1. All right, so looking through our solutions, we want this one, which is x equals negative 1. All right, let's look at our quiz. For the first question, we're asked to solve each inequality, and we're given 4 plus x is greater than 3. Okay, so just like if we're solving an equation, when we're solving an inequality, we want our variable to be isolated on one side and we want a number on the other. So how can I isolate x? Well, what's being done to x? In this particular case, 4 is being added to it. So just like with an equation, we could subtract 4 away from both sides of the equation. In this case, it's just an inequality. So we would say that we can subtract 4 away from both sides of the inequality. And so this is going to cancel away. And you'll have x is greater than 3 minus 4 is just negative 1. So x is greater than negative 1 is the solution we want to this guy right there. Okay, let's look at question 2. Again, we're asked to solve each inequality. We have negative 20x is greater than 100. All right, so the idea here again, I want to isolate x on one side of the inequality. So what's being done to x? Well, it's being multiplied by negative 20. So what I can do legally is divide both sides of the inequality by negative 20. But there's one key difference here, and that is if you multiply or divide both sides of an inequality by a negative number, you have to flip the direction of the inequality symbol. So this is something that you can't forget because you'll get the wrong answer. So this guy, it is a greater than now. It's going to turn into a less than. This is going to cancel. And so what I'm going to have is x is now less than 100 divided by negative 20 is negative 5. So be careful about these answers here. This should be x is less than negative 5. So this is what we want right there. Okay, let's look at question 3. Here again, we're asked to solve each inequality. And now we have 13x is greater than 52. Again, 13 is multiplying x. So let's divide both sides of the inequality by 13 so that we can isolate x there. And what will happen is this will cancel with this, and I'll just have x is greater than 52 divided by 13 is just going to give me 4. So x is greater than 4 is going to be my solution. All right, let's take a look at our quiz. So for the first question, we're asked to solve each inequality, and we have 7 times the quantity 5 plus 8x, and this is greater than or equal to, we have 35 minus x. Okay, so the idea here is that we're going to use basically the same steps we used when we were solving an equation, but now we just have an inequality. There's just one key difference that you have to remember. If you multiply or divide both sides of an inequality by a negative value, you have to flip the direction of the inequality symbol. Other than that, you're just trying to isolate x just like if you had an equation. So I'm going to use my distributive property here. So 7 times 5 is 35, then plus 7 times 8x is 56x. This is greater than or equal to, you have 35 minus x. So let's get all the variable terms to the left and all the constants to the right. So what I'll do is I will add x to both sides of this inequality. And 35 is on each side. Again, you can legally get rid of it because if I subtract 35 away from each side, it's just going to be gone. 35 minus 35 is 0, so it's just going to cancel away. And since I added x over here, basically this side is just going to be 0. Okay, normally we don't write it, but when everything cancels away, you need to write 0 there so that you can show that there's a 0 in that place. So 56x plus x would be 57x, and this is greater than or equal to 0. And then to finish this up, we would divide both sides of the inequality by 57. And so this would cancel, and you would get x is greater than or equal to 0 divided by 57 would be 0. So x is greater than or equal to 0 is going to be our solution. Coming back up here, so this is what we want. X is greater than or equal to 0. Okay, let's look at the second problem. So again, we just want to solve each inequality. We're given 36 minus 3x is less than negative 7x, then minus 4 times the quantity 1 plus 4x. Okay, so on the left-hand side, really there's nothing I can do. So let's just copy 36 minus 3x. We'll say this is less than. On the right-hand side, of course, I can use my distributive property to clean up, and then I'll be able to combine some like terms. So let's go negative 7x, and then I'm going to treat this as negative 4. Negative 4 times 1 is negative 4, and then negative 4 times 4x would be minus 16x. Okay, so as I mentioned, you'll be able to combine like terms. You have negative 7x and negative 16x. That's going to give you negative 23x. So I think we don't need an extra step. Let me just write it in here. I think you can figure that out. So let me put negative 4 and then minus 23x. Okay, so from here, I'm moving all the variable terms to the left, all the constants to the right. So let's add 23x to both sides of the inequality. And let's subtract 36 away from each side of the inequality. And let's see. This is going to cancel here, and this is going to cancel here. On the left-hand side, negative 3x plus 23x is going to be 20x. And this is less than negative 4 minus 36 is negative 40. As a final step, let's divide both sides of the inequality by 20. And so this is going to cancel. You get x is less than negative 40 divided by 20 is going to give you negative 2. So x is less than negative 2 is going to be my solution. I'm looking for this guy right here. X is less than negative 2. Okay, let's look at question 3. So we want to solve each inequality. And we're given negative 23x is greater than or equal to negative 6 times the quantity 4x plus 5. And then we're adding to this 3 times the quantity x minus 4. Okay, so the first thing I'm going to do, the left-hand side, I can't do anything with negative 23x. I'm just going to copy it. This is greater than or equal to. On the right-hand side, I can use my distributive property to clean up. Negative 6 times 4x would be negative 24x. Negative 6 times 5 would be minus 30. Then plus 3 times x is 3x, and then minus 3 times 4 is 12. I could do negative 24x plus 3x. That's going to be negative 21x. Let me actually make another line. So let me put negative 23x and make this 3 better. Is greater than or equal to, again, this is going to be negative 21x. Negative 30 minus 12 is going to be negative 42. Okay, so each side is as simple as I can make it. Really, all I want to do is add 21x to both sides of this inequality here. And so what's going to happen is this guy over here is going to cancel. And on the left-hand side, negative 23x plus 21x is going to give me negative 2x. This will be greater than or equal to negative 42. So here's what I'm going to do. To isolate x, since negative 2 is multiplying it, I'm going to divide both sides of the inequality by negative 2. But again, if I divide both sides by a negative, or if I multiply both sides by a negative, then I have to flip the direction of the inequality symbol. So because I'm dividing by negative 2 there, this has to become a less than or equal to. So this guy right here is going to cancel. And what I'm going to have is x is less than or equal to negative 42 divided by negative 2 is positive 21. So I'll get x is less than or equal to 21. So we're looking for this answer right here. X is less than or equal to 21. All right, let's move on now and look at question 4. So we're asked to solve each inequality. And here we're going to say that we have x plus 4. This is greater than or equal to negative 2. And then we're going to say and it's less than or equal to positive 1. So the idea here is you have something called a 3-part inequality. And your goal is to isolate x in the middle. So what's being done to x? Well, you'll see that you have this plus 4 here, or 4 is being added to it. So all you want to do here is just subtract 4 away from each part. So in other words, I want to subtract away 4 from here, subtract away 4 from here, and subtract away 4 from here. So this will cancel. And in the middle now, I just have x. So that's exactly what I want. On the left-hand side, negative 2, you could say minus 4, you could say negative 2 plus negative 4. Either way, that's going to be negative 6. So let's put a negative 6 there. I'm just going to copy my sign. So this is going to be a less than or equal to. I'm going to copy my sign. This is a less than or equal to. Over here, you have 1 minus 4, or again, you could say 1 plus negative 4. Either way, that's going to be negative 3. So my answer here is that x is going to be greater than or equal to negative 6, and it's going to be less than or equal to negative 3. So I want this guy right there. All right, let's look at our quiz. For the first question, we're asked to determine if the given ordered pair is a solution to the equation. So the given ordered pair is 0, 5. Now remember, with an ordered pair, the leftmost value is the x value. So this is the x value. And the rightmost value is the y value. So our linear equation in two variables is 2x minus y equals 7. So all I'm going to do is I'm going to plug in a 0 for x, and I'm going to plug in a 5 for y, and I'm going to see if I get a true statement. That's all this is. So in this place, I'm going to plug in a 0, and in this place, I'm going to plug in a 5. That's all I'm doing. So 2 times 0 is 0, so you'd have 0 there, and then minus, you'd have 5 there, and this equals 7. So this gives me negative 5 is equal to 7, which is false. So that means this ordered pair 0, 5 is not a solution for this equation. So we want this answer right here where it says no, the ordered pair 0, 5 is not a solution. Okay, let's look at the next one. So again, for question 2, we're asked to determine if the given ordered pair is a solution to the equation. So we have 2, negative 1. Again, this is your x value. This is your x value. And this right here is going to be your y value. So just plug into the equation. So you have negative 3 times, for x I want to plug in a 2, and then plus 5 times, for y I want to plug in a negative 1, and this should be equal to negative 11. So on the left, negative 3 times 2 is negative 6, and then plus 5 times negative 1 is negative 5. Does this equal negative 11? Yes, it does. Negative 6 plus negative 5, or you could say negative 6 minus 5 would be negative 11. So negative 11 equals negative 11. So this is a true statement. So we'll say yes, this ordered pair, 2, negative 1, is a solution for our given equation. Let's look at question 3. So it says determine if the given ordered pair is a solution to the equation. We have 1, 5. So 1, 5. Again, this is your x value. This is your x value. And then this right here is your y value. Okay, so we have this equation, negative, and then you're going to plug in a 1 for x, then plus 4 times. For y, you're going to plug in a 5. This should equal 19. Does it? Well, you can eyeball that and see you're going to have 20 minus 1, which is 19, so yes. Well, let's just go through it officially. The negative of 1 is negative 1. Then plus 4 times 5 is going to be 20. This equals 19. And again, negative 1 plus 20 would be positive 19. So 19 equals 19. So yeah, that's a true statement. So we would say yes, this ordered pair 1, 5 is a solution for this equation. All right, let's take a look at our quiz. For the first question, we're asked to give the ordered pair of the point. So this should be really, really easy for you. But essentially, just to recap, an ordered pair is just a way to notate the solution for a linear equation in two variables. So it looks like this. You have an x value, a y value. And if we want to plot an ordered pair, what we say is a point on our coordinate plane, well, we're just finding the meeting point between these two, right? So in other words, the x value gives me the location on the x-axis or the horizontal axis, and the y value gives me the location on the y-axis or the vertical axis. So if I look at this point right here, I'm thinking about, well, where am I? Again, you could always start from the origin. So where am I on the x-axis? Well, I'm going 1, 2, 3, 4 units to the right. Let me put a label there of a 4. My x value there is simply 4. And then where am I on the vertical axis? So starting at the origin, I could go up 1, 2 units, right? So let me put a 2 there, so that's clear. So my y value here is a 2, right? So basically, you could think about this point here as going 4 units to the right and 2 units up if I started from the origin. Or I could go 2 units up and 4 units to the right, again, if I started at the origin. So the ordered pair here is going to be 4, 2. So let's circle this, 4, 2. Okay, let's look at the second question. So again, we want to give the ordered pair of the point. And now, if we look at this point right here, in terms of the origin, we know that this point right here is 0, 0. Let me label that. So this is 0, 0. If I look at this point, I have not moved at all horizontally. I'm still at the same x location that I would be if I was sitting at the origin. So the x value here is 0. So let's put that there. Now the y value, I've traveled up 7 units. I can label that as 7. So let's put a 7 there. So the ordered pair I'm looking for would be 0, 7. So let's circle 0, 7 like that. Okay, let's look at question 3 now. So we're asked to give the ordered pair of the point. So let's circle this point here. And sometimes it will help if it's a little bit far off to just make some lines going down and some lines going across so you can see what the corresponding values are going to be. So the x value here is going to be 9, right? Starting at the origin, I would go 9 units to the right. So let me put a 9 there. And the y value here would be 6. I'm kind of covering it up with these dashed lines here, so let me make that a little bit better. But essentially, starting at the origin, I would go 6 units up. So let me put a 6 there. And this guy right here, it's basically found by me going from the origin 9 units to the right and 6 units up, or I could go 6 units up and 9 units to the right. So I want 9, 6 as the ordered pair. So let's circle 9, 6. All right, let's take a look at our quiz. For the first question, we're asked to determine which linear equation represents the given graph. Now, as we move on in this course and we go through the next few lessons, we'll find a better way to do this. The best way to solve this, if you were given a graph and they asked you for the equation, you would look at the y-intercept and then you would look at the slope and you could generate an equation that way. But we haven't really talked about that yet. So for this part, I'm just going to use plug and chug. Again, as we get further along in the course, we'll find better ways to do this. So I'm going to take the two intercepts. I'm going to take this one and I'm going to take this one. So the ordered pair there is going to be 0, -1. That's the y-intercept, or where we're crossing the y-axis. And then this one right here, the x-intercept, is going to occur at -5, 0. So I'm just going to take those two guys, and I'm going to cut this away, and I'm just going to paste this in here. And essentially all I'm going to do is I'm going to check to see if both of these are a solution in the equations here. Now you might ask why I didn't grab the third one. Well, you only need 2 points to make a line. So you can check the third one if you want, but really I'm just going to do 2 just to make it a little bit quicker. So starting with this one, if I plugged in a 0 for x, so 7 times 0, and I plugged in a -1 for y, would that give me a value here of -12? You can immediately see that that's not going to work. So you can cross that out as a possibility. Let's go to the next one. So we have 2 times 0 minus 3 times -1, would that be equal to -10? No, you can cross that out. At this point, you could circle this one, but again, you always want to check to make sure. So we would say that x is 0, then plus 5 times -1. Does that equal -5? Yes, it does, right? 5 times -1 is -5. So this one checks out. Now the other one, if you plugged in a -5 for x, and then plus 5 times 0 would be 0, so you can just get rid of that. Does -5 equal -5? Yes, it does. So this is the equation of the line that we're looking for. And again, if you want some extra practice, you could always go through and graph it, and then compare your graph to this guy right here. Okay, let's look at question 2. We're asked to determine which linear equation represents the given graph. So in the last example, I had clearly defined intercepts. So you have that here. But this one, it looks like it's going to be a non-integer value. So I'm just going to grab that point there. So this guy right here, which is the y-intercept, it's going to occur at 0, 3. And then for this point right here, I want 2 units to the left, or -2 for the x value. And then I want 4 units down, or -4 for the y value. So let's grab these 2 points, and let's paste this in. And let's just check to see which one it's going to work in. You can probably eyeball this and see, because you have the one with the 0. I would do that one first. If I plugged in a 0 here, -2 times 3 would give me -6. So I'm just going to start with this one. I think I don't even need the other 2. So we have 7 times, I'm just going to check this, so -2, and then minus 2 times -4. Does that equal -6? 7 times -2 is -14, and then -2 times -4 is going to be +8. Does that equal -6? Well, yes, it does. -14 plus 8 is -6, so you get -6 equals -6. So these both work as a solution in this first guy. So that's going to be my equation of that line. So 7x minus 2y is equal to -6. Okay, let's look at question 3. So again, we're asked to determine which linear equation represents the given graph. And I have this intercept here, which is going to occur at 0, 2, so that's my y-intercept. And again, the x-intercept here, it looks like it's a non-integer value, so we really won't be able to read that from the graph. But let's just take this one over here. So we have a value for x of 4. So I'm going 4 units to the right. And then my value for y would be -4 because I'm going 4 units down, right? So 4 units to the right, 4 units down. So let's grab these. Again, I would start with this guy right here because it has a 0 in it. If I plugged in a 0 for x, basically you would have 9 times 2, and that's not going to give you 7. So that doesn't work. If I plugged in a 0 for x, then basically we'd have 2 times 2, which does give you 4. So let's do this one. So 3 times 0 plus 2 times 2. Does that equal 4? Yes, right? You get 4 equals 4. So let's show this as 0, and this is 4 equals 4. So this does work out. Let's go ahead and put a check mark there. Then let's try the other one. I'll just erase these parentheses here. I'll put a 4 here and a negative 4 here. 3 times 4 is 12. And then plus 2 times negative 4 is negative 8. Does that equal positive 4? Yes. 12 plus negative 8 is 4. So you get 4 equals 4. So this one works as a solution as well. So this is the equation of that line. So 3x plus 2y equals 4. All right, let's take a look at our quiz. For the first question, we're asked to find the slope given the following points. We're going to have this first ordered pair of 3, 9. Let me just write that out. So 3, 9. We have a second ordered pair here, which is 0, 5. So we're going to use our slope formula. And in order to do that, we have to label one of these points as x sub 1, y sub 1, and the other is x sub 2, y sub 2. Again, it does not matter which one gets labeled as which. Generally speaking, I just take the first point and say it's x sub 1, and then y sub 1, and then I'll take the second point and say it's x sub 2, y sub 2. Again, you could flip this around. It would not matter. As long as you're consistent and don't flip around the notation. In other words, don't say this is x sub 1 and then y sub 2. You can't do that. It either has to be all 1 or all 2. Okay, so just make sure you do that. All right, so the formula, our m, which stands for slope, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So change in y values over change in x values. So this would be equal to, here my y sub 2 is 5, and then minus my y sub 1 is 9. This is over. My x sub 2 is 0, and my x sub 1 is 3. Okay, so looking at this, 5 minus 9 we know is negative 4. This is over 0 minus 3, which would be negative 3. So basically my slope is 4/3 or 4 over 3. So this is what I want right here. M equals 4 over 3. Okay, let's look at the second question. Again, we're asked to find the slope given the following points. So we have this negative 2, 1, and then we have this negative 7, negative 5. All right, so looking at this guy, this is my x sub 1, and this is my y sub 1. Again, you can change the labeling if you want. It's up to you. This will be my x sub 2, and this will be my y sub 2. Okay, so just plug into the formula. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So y sub 2 is negative 5, then minus y sub 1, which is 1, then over x sub 2 is negative 7, then minus x sub 1, which is negative 2. So be careful here. Minus a negative is plus a positive. Let me write this out. So minus a negative 2. So I would write it out like that first, and then I would change it. So let me actually slide this down so I can show it completely so that nobody gets lost. Let me put equals here. Let me change my color. So I'll put negative 5 minus 1 over negative 7. Instead of minus a negative, I'm going to do plus a positive. So plus 2 like this. So negative 5 minus 1 is going to be negative 6, and this is over. Negative 7 plus 2 is going to be negative 5. We know negative over negative is positive, so this is 6/5 or 6 over 5. So I want this answer right here. M, our slope, is equal to 6 over 5. Okay, let's look at the third question. Again, find the slope given the following points. So here we have negative 11, 1, and then we have this negative 15, 5. So let's say this is, I'll just change it up. I'll say this is x sub 2, and this is y sub 2, and this is x sub 1, and this is y sub 1. Again, you can change the labeling. It will not matter. So I'm going to say m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So here we have y sub 2, which is 1, and we have y sub 1, which is 5. This is over x sub 2, which is negative 11, minus x sub 1, which is negative 15. Again, minus a negative is plus a positive. I think this is pretty much the only thing that trips people up in these formulas. So 1 minus 5, let's go ahead and say that's negative 4. And then negative 11 minus a negative 15 is negative 11 plus 15, which is going to give me positive 4. So negative 4 over positive 4 is going to give me negative 1. So m, my slope, is equal to negative 1. All right, let's take a look at our quiz. For the first question, we are asked to write the slope-intercept form of the line given the following information. We're given the y-intercept occurs at the point 0, 4, and we're given the slope, which you could label as m if you wanted to. This is going to be negative 3. So again, when you think about the slope-intercept form of the line, it is y is equal to m, the slope, times x plus b, again, where the y-intercept occurs at 0, b. So all we have to do is just match this up. we know that m, the slope is negative 3. So basically this will be negative 3. And we know that b is going to be the y coordinate from the y-intercept. So in this case, it's 4. So we're just going to put a 4 there. So to write this out, we would want y is equal to, this would be a negative 3 times x and then plus 4. So I want this guy right here, y equals negative 3x plus 4. Okay, for question 2, we're asked to write the slope-intercept form of the line given the following information. So it passes through 5, 7, and we have the slope, which is negative 3. All right, so if you're given a point and you're given the slope, you want to use something called point-slope form. Okay, so point-slope form if you're given a point and a slope, or in some cases, you're actually going to be given 2 points, and then you can use point-slope form as well. Okay, so that goes like this. You're going to have y minus y sub 1 is equal to m times the quantity x minus x sub 1. So we are given our slope. Again, m stands for slope. Slope is negative 3. So I'm going to plug in a negative 3 there. We are given a point, and that point, which is 5, 7, let me write this off here. So 5, 7, this is what you're using to plug in for x sub 1 and y sub 1. So this guy is x sub 1, and this guy right here is y sub 1. So in other words, here's y sub 1, I'm going to plug in a 7, and here's x sub 1, I'm going to plug in a 5. So that's all we're doing, we're just plugging into the formula. So what we're going to have here is y minus 7 is equal to negative 3 times the quantity x minus 5. So from here, it says we want to put this in slope-intercept form. Let me actually erase all this. And slope-intercept form is y equals mx plus b. So to put this guy right here into the form of this guy right here, all I need to do is solve for y. So basically, I'm just going to say that I'm going to add 7 to both sides of the equation. This will cancel, and you're going to get y is equal to this negative 3 times the quantity x minus 5, and then plus 7. Okay, let me get rid of this. And let me use my distributive property now just to clean up a little bit. So y is equal to negative 3 times x is negative 3x. And then negative 3 times negative 5 would be plus 15, and then plus 7. And then 15 plus 7 is going to give me 22. So let's put 22 right there. So what I'm looking for is y equals negative 3x plus 22. So this guy right here. Okay, let's look at question 3. We're asked to write the equation of the line in standard form. So standard form will vary a little bit based on that textbook that you're working with, but generally speaking, it's ax plus by is equal to c, or we would say a, b, and c are integers, and a is greater than or equal to 0. Again, that might change based on your textbook. But what I'm going to do is say that we have y is equal to negative x over 4. Let's maybe write this as negative 1/4 x. So negative 1/4 x, then plus 2. So first, I'm just going to clear this denominator. I'm going to multiply everything by 4. So this would give me 4y is equal to, if I multiply this by 4, I would just have negative 1, or you could put negative x if you want, and then plus, if I multiply this by 4, I would have 8. So what I would do here, since I want this guy to be on the left, right, because I want ax plus by equals c, I'm just going to simply add x to both sides of the equation. So let's put this over here like this. And this would cancel, and it would give me my final form. I can actually just erase this in line and rewrite this as x plus 4y is equal to 8. So that's what I want in standard form, and I want this answer right here. So x plus 4y is equal to 8. All right, let's take a look at our quiz. For the first question, we're asked to determine if the following lines are parallel, perpendicular, or neither. So hopefully you remember from the lesson that basically we would compare the slopes. If the slopes are the same and the y-intercepts are different, you have parallel lines. Then if you have slopes whose product is negative 1, then you have perpendicular lines. And then if neither of those conditions are met, then you have neither. So let's look at this first guy here, 2x plus y equals 7. I think you could probably just put this in slope-intercept form. That's probably the quickest way to do it. There's other ways to do it. It's really going to be up to you. So let me go 2x plus y equals 7. Remember, you want to solve this for y and have it as y equals m the slope times x plus b the y-intercept. So just subtract 2x away from each side of the equation. This would cancel, and you would have y is equal to negative 2x plus 7. So that tells me the slope is negative 2. And let me drag this up here, and I'll just put a little arrow there showing this is my guy in slope-intercept form. Let's do the same thing with this one. So we have 6x plus 3y equals -9. If I want to solve this for y, then what I'm going to do is first subtract 6x away from each side of the equation. This would cancel, and you're going to have 3y is equal to -6x and then -9. Let me get rid of this. We know that at this point, so let's get rid of that. And we want y by itself, and 3 is multiplying y. So in order to get rid of this 3 right here, I'm going to divide both sides of the equation by 3, or every term in this equation by 3, however you want to think about that. And essentially what's going to happen is this will cancel, and now I have y by itself. -6/3 is -2, then times x. -9/3 is -3 or -3. So looking at these two, again, we have the same slope. We have -2 and -2. So if the slopes are the same and the y-intercepts are different, here it would occur at 0,7, here it would occur at 0,3, well, we know we have parallel lines. So these two lines are parallel. Okay, let's look at the second question. Again, we're asked to determine if the following lines are parallel, perpendicular, or neither. So we have x plus 4y is equal to -12. So let's subtract x away from each side of the equation. We know that this would cancel. We'll have 4y is equal to -x minus 12. And to get y by itself, let's divide everything by 4. So divide this by 4, this by 4, and this by 4. And so this is going to cancel. You'll have y is equal to, we'll go -1/4 x, and then minus 12/4 is 3. Okay, so for this one, 4x minus y equals -5. Let's see, all I really have to do is add y to both sides of the equation. So let's go ahead and add y to both sides of the equation. So this is going to cancel. I'll actually just erase it. And I'm going to add 5 to both sides of the equation. So let's do that over here. So that'll cancel, and I'll actually just erase it. And so you get y is equal to 4x plus 5. So that's my slope-intercept form. Now the two slopes are not the same. You have a slope of -1/4 and you have a slope of 4. But we always want to multiply them together in this section to see if their product is -1. And I think you already can see that -1/4 times +4 is in fact going to give you -1. So what's going to happen is these two lines are going to be perpendicular, right? The product of their slopes is going to give me an answer of -1. So that's perpendicular lines. Okay, let's look at question 3. Again, we're asked to determine if the following lines are parallel, perpendicular, or neither. So for this first one, you have 7x plus y is equal to -3. Let me just subtract 7x away from each side of the equation. This cancels. You get y is equal to -7x minus 3. And then for this one, you have 9x minus y is equal to -5. Again, all I'm going to do is just add y to both sides and add 5 to both sides. So what would this look like? We would have this cancels and this cancels. So 9x plus 5 is equal to, this would be y. Let me get rid of this. And of course, you could just rearrange it and just put this as y is equal to, we'll have this 9x plus 5. Now looking at this, you can tell immediately you're going to have an answer of neither, right? The slopes are not the same. You have -7 and you have 9. And obviously, if I multiply those two together, I'm going to get -63, which is not -1. So this one would be neither. Let's take a look at our quiz. For the first question, we're asked to determine which inequality matches the given graph. So before we even look at this, I want to note that the answers here on the next page, you'll notice you have something in the format of ax plus by. Let's just use a less than symbol. This will stand in for any inequality symbol we want to use. Let's say c. So this is the format we want this in the end. Let's think about how we can find the inequality that matches this graph. The first thing I'm going to do is I'm going to consider this boundary line, and I'm going to find the equation of that line in slope-intercept form. So for that, I need the y-intercept, and I need the slope. Let's say it's m. It's going to be rise over run, and it's going to be y equals mx plus b. Okay, so let's start with that. So where's my y-intercept? Again, where does this line cross the y-axis? Well, it's going to be right there. This is going to be 0, -5. So 0, -5. Okay. So from here, what's my slope? Again, you can use any 2 points you want. Let's just pick this one and this one. I think it's a little bit easier. So my rise is up 1, 2, 3, 4. So let's put 4 over. My run is going to be to the right, 1, 2. So my run is 2. 4 divided by 2 is 2. So we have the slope, which is 2, and we have the y-intercept, which occurs at 0, -5. So we would say y is equal to, for m, I'm just going to plug in a 2, then times x, and then plus b. B is going to be negative 5 here, so let's put minus 5. Okay, let's get rid of everything here. Our boundary line is solid, so that means we have a non-strict inequality, meaning we have, in this case, it's going to be a greater than or equal to. How do we know that? Because again, it's a solid boundary line and we're shading above the line. So you'll notice we've shaded above the line like this. So we would say y is greater than or equal to 2x minus 5. So we don't have our answers in this format, so we do have to do additional work here. What I'm going to do is I'm going to subtract 2x away from each side of the inequality. And so this is going to cancel. And I'm going to have negative 2x and then plus y. We'll say this is greater than or equal to negative 5. And you'll see that it looks similar to this, but it's a little bit different because all the signs have changed. So to make it match, again, I'm just going to make this negative 2 positive. So I'm going to multiply everything here by negative 1. And when we do that, we have to remember to flip the direction of the inequality symbol. So this would be positive 2x, and this would be minus y, and this would be positive 5. So everything got multiplied by negative 1, and then I flipped the direction of the inequality symbol because that's required. So we end up with 2x minus y is less than or equal to 5. So that's our answer. Okay, let's look at question 2. Again, we're asked to determine which inequality matches the given graph. I'm just going to use my same strategy. So what is the y-intercept here? And then what is the slope m, which is rise over run. So the y-intercept here, it's going to be there where we cross the y-axis. So this would occur at 0, negative 3. And then in terms of the slope, just take that point there and you would go up 1, 2, 3, 4. And then to the right, 1, 2, 3, 4, 5. So this would be a rise of 4 and a run of 5, so 4 over 5, or you could say 4/5 if you wanted to. So in slope-intercept form, it's y equals m, which is 4/5, times x, and then plus b. B is negative 3, so let's put minus 3. So let's get rid of this. And then in terms of this inequality, I want you to notice that we're shading below the line. So we're shading below the line. And we have a broken up or dashed line, so it's a strict inequality. So we're going to say here that y is strictly less than 4/5 x minus 3. So again, I want to put this into a different format, but it's probably quicker to just subtract y away from each side like this, and then to add 3 to both sides like this. So essentially what that's going to do is cancel over here and cancel over here. And let's say that we have 3 is less than 4/5 x, and then we're going to have minus y. Now I'm just going to rewrite this as 4/5 x minus y. Let me make this better. So minus y like this is greater than 3. And then to clear this denominator here, I'm just going to multiply everything by 5. So what I'm going to do is say this would be 4x minus 5y is greater than 15. So this is what I'm looking for. Let's paste this in here. So we want 4x minus 5y is greater than 15. So that guy right there. Okay, let's take question 3. Determine which inequality matches the given graph. So again, the y-intercept here is going to occur at 0, negative 1. So y-intercept 0, negative 1. And then the slope m. So m is rise over run. So this is up 1, 2, 3. To the right, 1, 2, 3. So 3 over 3, which is 1. So y equals 1x, or just x, and then minus 1, right? Because the y-intercept occurs at 0, negative 1. So your b value there is negative 1. Now, this boundary line is a solid line. So I know I'm going to have a non-strict inequality, and I'm shading below the line. So essentially what I'm going to have is y is less than or equal to x minus 1. So I think it's probably easier just to subtract y away from both sides and add 1 to both sides. So we'll see that this over here would cancel, this would cancel. And so on the left-hand side, I have 1. This is less than or equal to. Over here, I just have x minus y. And of course, you could write this as x minus y is greater than or equal to 1. So this is what we're looking for here. We have this x minus y is greater than or equal to 1. All right, let's take a look at our quiz. For the first question, we're asked to determine if the following relation represents a function. So remember, for you to have a function, each x value has to be associated with one and only one y value. So in other words, if I look at this relation here, it's a set of 4 ordered pairs. We have 0, 3, 4, 2, 10, negative 1, and 3, 2. Really, the quick way to solve this is just to look for duplicate x values. If you have duplicate x values, then you don't have a function, right? Because that given x value that's a duplicate corresponds to more than one y value. Visually, to see this, you could say this x value of 0 corresponds to a y value of 3. Then the x value of 4 corresponds to the y value of 2. The x value of 10 corresponds to a y value of -1. Then the x value of 3 corresponds to a y value of 2. So for each x value here, there's one and only one associated y value. So yes, this relation is a function. Let's look at question 2. Again, we're asked to determine if the following relation represents a function. So we're given a set of 4 ordered pairs. And let's just go through this again. For an x value of 1, you have a y value of -7. For an x value of 6, you're given a y value of 9. For an x value of -2, you're given a y value of -3. But here we see 6 again, right? So you have a duplicate x value. And now we're saying that it corresponds to a y value of -5. So you could put comma -5. So this violates the definition of a function. For an x value of 6, I don't have a clear association. It could be 9 or it could be -5. So this violates the definition of a function. So we'll say no, this relation is not a function. Okay, let's look at question 3. It says determine if the following relation represents a function. And so again, we have this set of 4 ordered pairs. We have -9. This x value corresponds to a y value of -5. We have -1. This x value corresponds to a y value of -3. We have 27. This x value corresponds to a y value of -14. Then lastly, we see -1 again, which now corresponds to a y value of 0. So again, you have duplicate x values, -1 and -1. So there's no clear association here between an x value of -1 and a y value. If I'm working with -1 as the x value, it could be a y value of -3, or it could be a y value of 0, right? No clear association. So no, this relation is not a function. All right, let's take a look at our quiz. For the first question, we're asked to solve each linear system using the graphing method. We're given x plus y equals 2, and we're given x minus 4y equals 12. So I'm just going to quickly write these in slope-intercept form. We're going to go to the coordinate plane. I've actually already graphed everything, but I just want to show you how it would be set up. So let me put this down here and say that this would be y is equal to, all I would do is subtract x away from each side, so -x, and then plus 2. So we know that our y-intercept would occur at 0, 2, and our slope is -1. For this one, we have x minus 4y is equal to 12. Let me subtract x away from each side. So subtract x over here, subtract x over here. This would cancel. You'd have -4y is equal to -x plus 12. I'm going to divide everything by -4 so that I can get y by itself. If this cancels, you're going to get y is equal to, we have negative over negative, which is positive. Let's write this as 1/4 times x, and then minus 12 divided by 4 would be 3. And as I said, I already graphed everything just to make it a little bit cleaner. It's kind of hard to draw on a tablet like this. So basically for this one, you see that the y-intercept occurs at 0, 2. So that's going to be this point right here. Let me get a different color. So this one right here, that's my y-intercept. And my slope is -1. So down 1 to the right one, down 1 to the right one, down 1 to the right one, so on and so forth. So that's how you get this line right here. Then this one, the y-intercept occurs at 0, -3. So that's right there. The slope is 1/4. So up 1 to the right, 1, 2, 3, 4. So you got that point right there. And you can get all their points. That's how you draw that line. The main thing is to see this point of intersection here, which is going to occur at, let me put an arrow there, 4, -2. Okay, so this is where these two lines intersect. And so that means that this point, 4, -2, is on both lines, and so it satisfies both equations of the system, and it's our solution. So we want this 4, -2. Okay, let's look at question 2. Again, we're asked to solve each linear system using the graphing method, and we have 3x minus 9y is equal to -12. Again, I'm just going to put this in slope-intercept form, so let's subtract 3x away from each side, and let's cancel this. We'll have -9y is equal to, let's write -3x and then minus 12. Let's divide everything by -9. So let's go through here. This will cancel. Y is equal to negative over negative is positive. So this would be 3 over 9, which is 1/3. So 1/3 x. Negative over negative is positive. 12 over 9, you can divide each by 3. So this would be 4/3. All right, let's look at this one now. So we have x minus 3y is equal to 3. And if I want to solve for y, again, I would just subtract x away from each side. That cancels. You'll have -3y is equal to negative x and then plus 3. Let's divide everything by negative 3 so that we can isolate y. This cancels. I'll just put my arrow going there. So y is equal to, we'll say negative over negative is positive. So basically this is 1/3 x, and then positive 3 over negative 3 would be minus 1. Now before we try to graph this, do you see a problem? Yes, we have parallel lines, right? So we have 1/3 x and we have 1/3 x. So the slope is 1/3 and the slope is 1/3. You have different y-intercepts. So you really don't even need to graph this because you know it would be no solution, right? Parallel lines are never going to intersect. Therefore, there's no point or ordered pair that's going to satisfy both. Now we can show this graphically just to get a better idea of what this looks like. So this guy right here has a y-intercept at 0, 4/3. So that's a little bit hard to plot. So what you can do is actually get a different point. You can get your x-intercept. In this case, it's going to be at negative 4, 0. And then you could use your slope, which is 1/3, to go up 1 to the right, 1, 2, 3, up 1 to the right, 1, 2, 3. So you can get additional points that way. So that's that line. Then this guy right here has a y-intercept at 0, -1. So let's circle that real quick. So that's going to be right there. And then the slope is 1/3. So up 1 to the right, 1, 2, 3. You could also go down 1 to the left, 1, 2, 3 as well. But you see these two lines are parallel. They're never going to intersect. And so there's no solution for the system. All right, let's look at question 3. Again, we're asked to solve each linear system using the graphing method. So we have 7x minus y is equal to 3. So what I want to do here is subtract 7x away from each side. This would cancel. We have negative y is equal to negative 7x and then plus 3. Then let's multiply everything by negative 1 so we can get y by itself. So I'm just going to change the sign of everything. So this would be y, this would be 7x, and then this would be minus 3. Okay, so we've got that one done. Now this one is pretty easy. We have x minus y equals negative 3. So let's actually write this as negative y is equal to, I'm going to subtract x away from each side, so negative x and then minus 3, and then just multiply everything by negative 1. So this sign would change, this sign would change, and this sign would change. So for the first guy, the y-intercept occurs at 0, -3. That's going to be right there. And the slope is 7. So up 1, 2, 3, 4, 5, 6, 7 to the right 1. So there's that point right there. And you'll notice that that is actually the point of intersection. I might as well note that now. So it's 1 unit to the right and 4 units up. So this is going to be 1, 4. That's going to end up being our solution. For the other guy, it has a y-intercept at 0, 3. So right here, that's the y-intercept, and the slope is 1. So up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, so on and so forth. So you see your solution here is at 1, 4. So coming back up here, we want this guy right there. All right, let's take a look at our quiz. For the first question, we're asked to solve each linear system using substitution. So we have x minus 3y is equal to 4. And then we have negative x minus 5y is equal to negative 4. Okay, so with substitution, you always want to look for a variable that has a coefficient of 1 or negative 1. That's the easiest case scenario. You'll notice that this guy right here is basically just x, or you could really put this, if you wanted to make it crystal clear, as 1x. So what I'm going to do is I'm going to solve this equation here for x, and then I'm going to plug in for x in the other equation. So in other words, I would have, let me just drag this down here, I would have x minus 3y is equal to 4. If I want to solve for x, that means I want to isolate x on one side. And to do that, I'm just going to add 3y to both sides of this equation. So this would cancel. And so we would say that this is x is equal to, let's put 3y and then plus 4. So here we have x equals some algebraic expression. In this case, it's 3y plus 4. So what I'm going to do is I'm going to take this right here, and I'm going to plug it in for x right there. That's all I'm doing. So this is going to go in right there. So you have a negative out in front, so make sure you copy that. So negative. Inside, I'm going to plug in the 3y plus 4, because that is what x is equal to. X is equal to that, or you can think about it as x is the same as 3y plus 4. Then minus 5y, this equals negative 4. We'll come back up in a moment. Let's just solve this guy. We have a linear equation in one variable, so we should be able to figure out what y is. I'm going to apply this negative to each term inside. So this will be negative 3y, then minus 4, then minus 5y. This equals negative 4. If you have the same thing on each side of the equation, you can get rid of it, right? Because I could add 4 to both sides, and it would go away. And we'll show this real quick. So plus 4 and plus 4. And so this is gone, and this is gone. On the right-hand side, everything is canceled. Remember, if you cancel with addition or subtraction, it's 0. -4 plus 4 is 0. So make sure you write that there because you don't have anything else. So on the left-hand side, -3y minus 5y would be -8y. This equals 0. To finish this up, let's divide both sides of the equation by -8. And so this is going to cancel here. We'll have y is equal to 0 divided by -8 is 0. So y equals 0. So we found one of our unknowns. So how do we figure out what x is equal to? Well, you just plug in a 0 for y in one of the original equations. It doesn't matter which one you use. So let's just use this first one. So I'm going to plug in a 0 there. If you plug in 0 for something, that term is just going to disappear, right? So you just have x equals 4. So x equals 4. And again, to show this in case anybody's confused, it's just x minus 3 times 0 is equal to 4. Well, 3 times 0 is 0, so you might as well just say this is x minus 0, and x minus 0 is just x, so this is just x equals 4, okay? But again, after you do this a few times, you'll notice that you can just kind of shortcut that and say, okay, well, x will just equal 4 there. So this is my solution here. Again, you can check it if you want. I'll let you do that on your own. In the interest of time, I'm just going to skip that. The ordered pair would be 4, 0. So coming back up here, I want this answer right here, the ordered pair 4, 0. Okay, let's look at question 2. Again, we're asked to solve each linear system using substitution, and we have -7x plus 6y is equal to -24. And then we have -6x plus y is equal to -4. So again, if you can find a variable with a coefficient of 1 or -1, that's what you want to go for. Here I have y, or again, you could write this as 1y if you wanted to make it clear. But again, I'm just going to solve this equation for y, and then I'm going to plug in for y in the other equation. So to solve this for y, all you would really have to do is add 6x to both sides of the equation. So let me show that here. So 6x plus 6x. This, of course, would cancel. So this is gone. And you would have y is equal to, you would have 6x and then basically -4. Okay, let me get rid of this. We're going to keep that original form there. Let me just draw a little arrow there. And then all I want to do here is just take this part right here and plug it in for y there. Okay, so this is going to go right there. So let's say that we have -7x plus 6 times, you're going to take this algebraic expression here, 6x minus 4, and plug it in for y, because again, y is equal to that or the same as that. So I can replace y with that in this equation. Then this equals -24. Now I'm going to have a linear equation in one variable. Let's slide down. We'll come back up in a moment. So I'm going to have -7x plus 6 times 6x is 36x. And then minus 6 times 4 is 24. And this equals -24. Again, if you see the same thing on each side, you can get rid of it. Because I could add 24 to both sides of this equation. This would be gone and this would be gone. Because there's nothing left on the right, I'm just going to put a 0 there. -24 plus 24 is 0. And then -7x plus 36x is going to be positive 29x. So this equals 0. Again, divide both sides of the equation by 29. So we can get x by itself. And you get x is equal to 0. Okay, so let me plug that in for x in one of the original equations. You can actually get rid of this. You don't need this anymore. So let's just use this one right here. I think it's going to be less work. So we'll say -6 times 0 plus y equals -4. Again, you can shortcut this and say, well, this term would disappear if I plugged in a 0 for x, and you just get y equals -4. But again, if it's a little too advanced for you, just go through the steps. No big deal. -6 times 0 is 0, and then 0 plus y is just y, so this equals -4. So as an ordered pair, this would be 0, -4. So I want this answer right here, 0, -4. Okay, let's look at question number 3. We want to solve each linear system using substitution. So we have 5x minus 7y is equal to -7. And then we have -3x plus 8y is equal to -11. Okay, so unfortunately, we don't have the easy case scenario for this problem. We don't have a variable with a coefficient of 1 or -1. So we just have to pick something that we think would be easier. I'm just going to solve the first equation for x. So to do that, I have 5x minus 7y is equal to -7. And so to solve for x, I would first add 7y to both sides of the equation. So let me just get rid of this. And then I would just divide everything by 5, right? Because 5 is multiplying x. So let me divide every part of this equation or every term in this equation by 5. This would cancel. And what we're going to get is that x, let me make this arrow just a little bit better, a little bit cleaner. X is equal to, you would have, let's say 7/5 y and then minus 7/5. And now I'm just going to plug in for x in this other equation. So this right here, this is what x is equal to. That's going to go in right there. So what we're going to say is -3 times, plug in this in, so 7/5 y minus 7/5, and then plus 8y is equal to negative 11. Let me slide down, we'll come back up. So I'm basically going to use my distributive property here. So negative 3 times 7/5 would be negative 21/5, then times y. Then we have negative times negative, that's positive, and then 3 times 7 is 21, and this is over 5. Then plus 8y is equal to negative 11. Again, I like to clear the fractions. You don't have to, you can work with them, but I'm just going to take this time and multiply everything by 5. So this would be negative 21y plus 21 plus this would be 40y is equal to negative 55. So again, I just multiplied everything by 5. If you need to pause the video and show that, that's going to be up to you. Just join me here in a moment when you're done. Okay, so what I want to do here on the left is just combine like terms. Negative 21y plus 40y is going to be positive 19y. And then let me subtract 21 away from each side of the equation. So negative 55 minus 21 is going to be negative 76. To finish this up, let me divide both sides of the equation by 19, the coefficient of y. So y would be equal to negative 76 divided by 19 would be negative 4. So y equals negative 4. If I want to get x, I just plug in for y in one of the original equations. Let me just take this first equation. Again, you can use the second one. It's really up to you. So 5x minus 7 times negative 4 is equal to negative 7. Well, this is negative 7 times negative 4. That's positive 28. So let's say 5x plus 28 is equal to negative 7. Let's subtract 28 away from each side of the equation. This would cancel. You're going to get 5x is equal to negative 7 minus 28 is negative 35. So to finish things up, let's divide both sides of the equation by 5. This cancels. You get x is equal to negative 35 over 5 is 7. So x here is equal to negative 7. So as an ordered pair, we would say this is negative 7 comma negative 4. So I'm looking for this answer right here, negative 7 comma negative 4. All right, let's take a look at our quiz. For the first question, we're asked to solve each linear system using elimination. So we're going to have 6x plus 9y is equal to 27. And then we're going to have 8x plus 18y is equal to 30. So what you need to do here is make one pair of variable terms into opposites. Now, if I look at this guy right here, this 9y and this 18y, I can see that this term right here is double that of this term right here, right? If I multiply 9y by 2, I'd have 18y. So probably the simplest way to deal with this is I'm just going to take this equation right here, and I'm going to divide everything by negative 2, or you could say multiply everything by negative 1/2. So divide this by negative 2, divide this by negative 2, divide this by negative 2, and that would give me 8 divided by negative 2 is negative 4, so negative 4x. 18 divided by negative 2 is negative 9, so minus 9y. And then 30 divided by negative 2 is negative 15, so equals negative 15. And now what you have is one pair of variable terms that are opposites. So you have the 9y and the negative 9y. And maybe I should drag this over just a little bit more so they line up. But basically you just add the two left sides together, set this equal to the sum of the right sides. So essentially 6x plus negative 4x would be 2x. These two guys would cancel. 9y plus negative 9y is 0. And this equals 27 plus negative 15 would be 12. Right? So divide both sides of the equation there by 2. You get x is equal to 6. So x is equal to 6. And then from there you can plug into any equation. Let's just work with this one right here. So 6 times 6 plus 9y equals 27. This would be 36 plus 9y equals 27. Let's subtract 36 away from each side of the equation. This would cancel. You're going to get 9y is equal to 27 minus 36 is negative 9. Divide both sides of the equation by 9. You get y is equal to negative 1. So y equals negative 1. So as an ordered pair, 6 comma negative 1. So coming back up here, you want 6 comma negative 1. All right, let's look at the second question. Again, we're asked to solve each linear system using elimination. We have negative 12 is equal to negative 3y plus 3x. Then we have 0 is equal to 21y plus 42 plus 21x. The first thing we want to do is write everything in standard form. So ax plus by equals c. So let's rewrite this one as just 3x and then minus 3y is equal to negative 12. Now, you'll notice that everything here is divisible by 3, or you could also divide everything by negative 3. I would probably hold off on that just for a second until we see what we need to do. But again, if you wanted to do that first to see where it leads, it's up to you. Then for the second one, let's write 21x and then plus 21y I'm going to subtract 42 away from each side of this equation. So this would be equal to negative 42. I know that everything here is divisible by 21. So I could do that if I wanted to. I think that's probably what we want to do. If I divide everything here by 21, this would just be x, this would just be y, and this would be negative 2. Okay. Now if I divide everything here by 3, this would be x, this would be negative y, and this would be negative 4. All right, so without doing much work here, we now have opposite coefficients on our variable y, right? So this is negative 1, this is positive 1. So we can go through and just add the left sides. X plus x is 2x. This is going to cancel. So this equals negative 4 plus negative 2 is negative 6. Divide both sides of the equation by 2. You get x is equal to negative 3. So we'll say x equals negative 3 here. And then for y, again, you can just plug into either equation. So let's just do this one. Negative 3 plus y equals negative 2. Let's add 3 to both sides of the equation. And what we're going to see is that y is equal to positive 1. So y equals 1, or the ordered pair negative 3 comma 1. So negative 3 comma 1 is what I want. Okay, let's look at question 3. So again, solve each linear system using elimination. So we have 36 plus 12y is equal to negative 7x. And then we have 9x is equal to negative 9y plus 18. For each one of these, I want to write them in standard form. So this guy up top, let's write negative 7x. I'm going to subtract 12y away from each side. So minus 12y. And this would be equal to 36. So again, all I did was I subtracted 12y away from each side. So this would be minus 12y over here. And this would be gone over here. And essentially from there, I just flipped the order around, which is legal, right? 36 is equal to negative 7x minus 12y is the same as me saying negative 7x minus 12y equals 36. For this one, I have 9x, and then I could add 9y to both sides, and this would be equal to 18. So again, just added 9y to both sides. Now you'll notice here that everything is divisible by 9, so you have a 9 here, and an 18 here. You could do that first, but again, you're going to have to figure out how you're going to get a pair of opposite variable terms. You could use this guy or this guy. Let's just use this guy. What I'm going to do is actually multiply everything here. Or actually, I think that would be too complicated for people. Let me divide everything by 9 first. And then I'm going to multiply by 7. So essentially, I'm just multiplying everything by 7/9. But I think people will get lost if I do that. So let me just do it in 2 steps. So let me get rid of this. Let me get rid of this. And let me put this as a 2. And now I can just multiply everything by 7. So this would be 7, this would be 7, and this would be 14. Again, if you want to do that in one step and multiply everything by 7/9, that's up to you. I just did it slowly so no one would get lost on what I'm doing. Okay, so here, this is going to cancel, right? So essentially, negative 12y plus 7y is going to be negative 5y. And this equals 36 plus 14 is going to be 50. Divide both sides of the equation by negative 5. This cancels. You get y is equal to negative 10. Okay, so I know y is negative 10. Now, how do I get x? Again, just plug in. And what I can do, you can actually divide this again and get rid of the 7. You don't need this anymore. So put this back to where it was. And you could plug in a negative 10 for y. So you could say x plus negative 10 is equal to 2. And then what I would do is just add 10 to both sides of the equation and get that x is equal to 12. So x is equal to 12. So the ordered pair here would be 12 comma negative 10. So coming back up here, I want this one, 12 comma negative 10. All right, let's take a look at our quiz. For the first question, we're asked to solve each word problem. So I'm just going to read this with you. We have that Wendy and Molly are selling cheesecakes for a school fundraiser. Then we're told that customers can buy New York style cheesecakes and chocolate marble cheesecakes. We're then told Wendy sold 1 New York style cheesecake and 7 chocolate marble cheesecakes for a total of $135. Then we're told that Molly sold 4 New York style cheesecakes and 7 chocolate marble cheesecakes for a total of $162. We want to find the cost each of 1 New York style cheesecake and 1 chocolate marble cheesecake. Okay, so this type of problem is actually really easy to solve. If you struggle with this one, let me walk you through this first one, and then you might want to pause the video and try the other 2 on your own because they set up in a very similar way. So the first thing is you want to identify what you're trying to figure out, and you're just trying to figure out what is the cost each of 1 New York style cheesecake and 1 chocolate marble cheesecake. So I'm just going to let a different variable represent each one of those. So I'm going to say something like let x be equal to, and I'm going to keep this really short. So I'm just going to put ny for the cost each of one New York style cheesecake. I think writing that out would be quite ridiculous. You can write it out in your notes if you need to. Then I'll put let's use y here, and we'll say this equals to, let's go ahead and put for chocolate marble cheesecake, maybe just write marble, so something like that, or you could put maybe something like CM, whatever you want to do, it doesn't really matter. We know what it stands for. Okay, so what I'm going to actually do from here is fill out some information in a table. You don't need this, but if you're struggling with the problem, it might help you visualize what's going on. So you're just going to take these totals here. So you see that for Wendy, she sold 1 New York style cheesecake, 7 chocolate marble cheesecakes, and the total amount or the total revenue from that was $135. So let's go down, and for Wendy, for NY or the New York, I'm going to put 1. For the marble or the chocolate marble, I'm going to put 7. And then for total sales, I'm going to put 135. Now, this isn't enough to get an equation. Let me go back up and then I'll explain what I'm talking about. Let's get the information for Molly, and we'll make sense of all this. So for Molly, let's see, it's 4 for the New York, it's 7 for the chocolate marble, and then total revenue is $162. So we have 4, we have 7, and we have 162. So what you want to do here is think about, how do I get the total sales from something? Just think about in your everyday life. Well, if I was buying some cheesecakes, if I bought 1 New York cheesecake, how would I figure out how much I spent? Well, I'd need to multiply that 1 by the price each, right? And we represented the price for 1 New York style cheesecake with X. And we're going to put X here as well. And then the price for 1 marble or chocolate marble cheesecake, to be more specific, was represented with Y. So let's put Y here and Y here. Now, all we would do is just add these two amounts together. The amount that people spent on the New York style cheesecakes plus the amount that people spent on the chocolate marble cheesecakes would give me her total sales or her total revenue from selling these two cheesecakes. So let's put a plus here and an equals here, a plus here and an equals here. So this gives me my two equations for the system. Really an easy system to solve overall. We're going to have x plus 7y is equal to 135. And then we're going to have 4x plus 7y is equal to 162. So for this particular system, I think substitution is probably the easiest. I know a lot of you will eyeball that and see 7y and 7y. So you could multiply one of these equations by -1, and you'd have opposite variable terms going. But I think it's probably easier just to solve this first guy here for x. So let's say x is equal to, I'm going to subtract 7y away from each side of the equation. So -7y, and then plus 135. And then since x is equal to this, I'm going to plug in for x in this equation right there. So that's going to give me 4 times, again, just plugging this in, -7y plus 135. Close that down. Let's move this over here. Let's put plus 7y is equal to 162. And all I'm going to do is just clean up, use my distributive property. So 4 times -7 is -28. Then times y, then plus 4 times 135 would give me 540. Then plus 7y, this equals 162. Okay, so on the left-hand side, let's combine like terms. We have -28y plus 7y, that's -21y. And then let's just write this out. We could do it in one step, but I'm just going to write this out. So plus 540 equals 162. Let me slide down here a little bit and get some room going. So what I'm going to do is subtract 540 away from each side of the equation. That will cancel. You get -21y is equal to 162 minus 540 is going to give me -378. And to finish things up, let me divide both sides of the equation by -21. And so we're going to see that this is going to cancel. And what we end up with here is y is equal to negative over negative is positive, and 378 divided by 21 is going to be 18. So remember, y equals the price for 1 chocolate marble cheesecake. So we know that's $18. So just coming back up here, I'm going to be plugging in an 18 for this y here. And actually, it's probably easier for me to write x is equal to, again, subtract 7y away from each side. So -7. In the place of y, I'm just going to plug in an 18. And then plus 135. Just easier to do it this way in terms of your calculator, because you can just punch this in and figure out what it is, and you'll have x. So punch in -7 times 18 and then plus 135. Well, -7 times 18 is going to be -126. And if you add 135 to that, you're going to get 9. So let's put 9 here. So what does this mean? Let me write this over here. So x equals 9, y equals 18. Well, it's just telling me, again, if I go back up, that x is the price each for one New York style cheesecake. So we're looking for a price there of $9. And y is the price each for one chocolate marble cheesecake. And in this case, it was 18, so $18. So this is the answer we're looking for. Okay, let's look at problem 2. So again, if you had trouble with this one, it sets up exactly the same way as the last problem. So you might want to pause the video at this point and try it again on your own, see if you can get it. If not, please join me here and we'll go ahead and go through the whole thing. So we're going to solve each word problem. And now we have the senior classes at Jacob High School and McMain High School planned separate trips to the county fair. The senior class at Jacob High School rented and filled 8 vans and 14 buses with 836 students. McMain High School rented and filled 11 vans and 13 buses with 837 students. Each van and each bus carried the same number of students. How many students can a van carry? How many students can a bus carry? There's one part of this question where everyone gets lost if they do get lost, and it's this statement here that says each van and each bus carried the same number of students. What this means is that when we think about all the vans involved, all the vans will carry the same number of students. And then when we think about the buses involved, all the buses carry the same number of students. But it's not true that the buses and the vans carry the same number of students. So that is a bit confusing the way that's written. All right, so let's start out by just letting a variable. Again, we can use x, y, z, whatever you want to use. I'm going to let that equal the number of students a van can carry. So I'm just going to put van for short. And then we'll put, for y, that's going to be the number of students that a bus can carry. All right, so just like in the last example, we used a table. So we're just going to fill one out. I'm just going to grab the information for Jacob High School. So it's going to be 8 vans, 14 buses, and 836 students. So we have 8, we have 14. Let me make this 14 better. And then we have 836. Okay, for McMain, let's grab that information. We have 11, 13, and 837. So 11, 13, and 837. Okay, so the idea here, again, just like the last example, we don't have a revenue like the last example, but we still need to multiply each one of these by the variable that we need. So in other words, we have 8 vans. How many students are in each van? Well, that's represented with x. Then plus, we have 14 buses. How many students are in each bus? That's y. And this equals the total number of students that were transported. In this case, it's 836. Same thing here. So I'm going to put an x, and then I'm going to put a y, put an equals. And basically, you have your 2 equations. Now, these equations are not as easy to work with as in the last example. So we have 8x plus 14y is equal to 836. And we have 11x plus 13y is equal to 837. Let me get this out of the way and put this here. Now, in terms of what you want to do, again, we only know substitution and elimination. We're obviously not going to graph this, but you can use either one. It doesn't really matter. You get the same answer. I would probably start by dividing this top guy here by 2, just so I'm working with smaller numbers. So I would say this is 4x plus 7y is equal to 418. Okay, let me get rid of this. You can actually legally just replace this. And again, all I did was I took that equation, I divided everything by 2 so that these numbers here were smaller. All right, so if I want to use elimination, what I can do is I can multiply, let's just say this equation here by, let's just go ahead and do negative 11. So I'm going to multiply this by negative 11. And what that's going to give me is negative 44x. And then I'll put this one as times 4. And this is times 4. And that's going to give me positive 44x. So basically those x's are going to cancel when we add them together. So let's go through here. So negative 11 times 4x would be negative 44x. And then negative 11 times 7y would be minus 77y. And this equals negative 11 times 418 is negative 4,598. All right, so here 4 times 11x is going to be, let me do this in a different color. I'll probably use like a light blue. So let's go 44x. And then plus 4 times 13 is 52, then times y. And this equals 4 times, and this 7 is terrible, so let me fix that. 4 times 837 is 3,348. All right, so let's come down here. We're going to add the left sides together, so this is going to cancel. And negative 77 plus 52 is going to be negative 25, so negative 25y. And this equals negative 4,598 plus 3,348 is going to be negative 1,250. Let's divide each side of the equation by negative 25. And let's see that this is going to cancel. And we have y is equal to, negative over negative is positive, 1,250 divided by 25 is going to be 50. So we know y is 50, and that's how many students a bus is going to carry. So now we just need to figure out what x is. Okay, so let me actually undo this, and we can plug 50 into either of these original equations. Again, I just took this one up here and divided by 2. It's fine to plug it into there. So we'll go 4x plus 7 times 50 is equal to 418. So 7 times 50 is going to be 350. So let's put that in there. And then what I'll do is I'll subtract 350 away from each side of the equation. This will cancel away. 418 minus 350 is 68. So you're going to get 4x is equal to 68. Let's divide both sides of the equation by 4. This cancels. You're going to get x is equal to 17. So let me write here x equals 17. And again, x was 17 and y was 50. So 17 students for the van and 50 students for the bus. Okay, let's look at the last problem here. Again, very similar to the other two. And so for question 3, again, we're asked to solve each word problem. We have Lamonte High School is selling tickets to a fall musical. On the first day of ticket sales, the school sold 15 senior citizen tickets and 3 student tickets for a total of $135. The school took in $231 on the second day by selling 13 senior citizen tickets and 14 student tickets. What is the price each of 1 senior citizen ticket and 1 student ticket? Okay, so looking through this guy, again, it sets up in a very similar way. We can use a table if we want, or we can skip that at this point. I'm just going to use a table for the sake of completeness, but you might want to pause the video and just, again, try this on your own. I think you can get it. But if you're coming back to look at the solution, again, I'm just going to let x be equal to the price of, let's say, one of the senior citizen tickets. So let me just put senior here for short. And then I'll say then y would be equal to the price of a student ticket. So let me just put student, okay, just to abbreviate. So again, just filling out a table, if I look at the information for the first day, we've got 15 senior citizen tickets, 3 student tickets, and it's $135. So 15, 3, and 135 is what's going to go in there. And then on the second day, you've got 13, 14, and 231. So 13, 14, and 231. And again, if you're looking for total sales, well, you need the amount that you sold times the price each. And we're representing the price or the cost for a senior ticket with X. And then we're representing the price or the cost each for a student ticket with Y. So again, you're just going to sum these just like you did in the very first example, same setup. And basically you just have a little system here. So this first one, let me write out this equation. You're going to be able to simplify that a little bit. So let's put this equals 135 and then 13x plus 14y is equal to 231. Now, this is why I like to look at things before I do anything. So at first glance, you might think, okay, well, I'm going to use elimination, but I think substitution is better because for this first equation, everything is actually divisible by 3. So 15 divided by 3 would be 5. So let's get rid of this and put a 5. 3 divided by 3 is 1. And 135 divided by 3 is 45. Okay, so from here, I can just solve this guy for y. So I can say that y is equal to, I'm going to subtract 5x away from each side, so negative 5x and then plus 45. And then I'm just going to plug in for y in this equation here. So I'm going to be plugging this in right there. So 13x plus 14 times the quantity, negative 5x plus 45. This should be equal to 231. All right, let's slide down and solve this real quick. We'll come back up for the answer. So you have your 13x. Let's just copy that. Plus, what is 14 times negative 5? That's going to be negative 70. So let me actually just write minus 70, and then x would come along for the ride. Then plus 14 times 45 is going to be 630, and this equals 231. So on my left-hand side here, 13x minus 70x would be negative 57x, and then plus 630, and this equals 231. Okay, so let me subtract 630 away from each side of the equation. This would cancel. And then coming down here, what we're going to have is negative 57x is equal to 231 minus 630 would be negative 399. To finish things up, let's divide both sides of the equation by negative 57. This would cancel. You get x is equal to, we know negative over negative is positive. 399 over 57 is going to be 7. So x is going to be 7. And coming back up here, let me just write this to the side. So x equals 7. I'm just going to plug into this first guy right here and just say 5 times 7 is going to be 35. Then plus y equals 45. Let me subtract 35 away from each side of the equation. And so this is basically going to be y is 10. Okay, so x is 7 and y is 10. So coming back up here, Again, X was the cost of a senior ticket, and that's going to be $7 or $7. And Y was the cost for a student ticket, and that's going to be $10 or $10. So we want this answer right here. All right, let's take a look at our quiz. For the first question, we're asked to determine which system matches the graph. Now, before we do any work, I just want to call your attention to the fact that our answers are given in this format of AX plus BY. Let's just use a less than symbol to represent any inequality symbol, and then let's put C there. So this is what we want. Well, first off, we know for the boundary line, this guy right here, it's going to have a y-intercept. So let me put a y-intercept that occurs at 0, 3. Okay, so that's the first piece of information. And then my slope, we see that if I started here and I went up 1, 2, 3, 4, 5, and then went to the left 1, 2, 3. So the slope m has a rise. Let me write this out. So a rise over a run. So the rise is 5. The run is -3. Okay, so this is basically just -5/3. That's how we would think about this. All right, so to write this in slope-intercept form, it's y is equal to m, which is -5/3, times x plus b, the y-intercept, which is 3. So we have the boundary line, and I want you to notice that the boundary line is solid. So this tells me that because we would shade below the line, you can see this. The whole solution is not there, obviously, because this is a system, but you can see that we're shading below the line. So this would be y is less than or equal to, because again, we're shading below the line, and it's a non-strict inequality because this is a solid line, so that boundary line is included. So we'll put the -5/3 x plus 3. So this is the first inequality of our system. We'll get the other one in a second. Again, I just want to transform this so that it matches our answers. So let's go ahead and multiply everything by 3. So this would be 3y is less than or equal to, I'll put -5x and then plus 9. Again, I just multiplied every part of this inequality by 3, completely legal. So from here, what I'm going to do is just add 5x to both sides of the inequality, and you would have 5x plus 3y is less than or equal to, this would be 9. Okay, so that part is done. Now let's think about this one. So this has a y-intercept of 0, -1, and a slope which is down 1 to the right 1, 2, 3. So basically the rise is -1 and the run is +3. So that's -1/3. So y is equal to, again, m, the slope is -1/3 because we went down 1 and to the right 3. And let me actually make this just a negative out in front like this so it's more clean. And then times x. And then my y-intercept was at 0, -1. So let's put -1. Now, we can see here, from looking at this guy, we would be shading above the line. Again, the full solution is not there because it's a system, because you're shading above this one and below this one. So this part that's yellow is the overlap between the two. But we can see we're shading above the line. So we can change this to a strict inequality strictly greater than. Now, why is it strict? Again, because this is a broken or dashed line, so the boundary line is not included. Now, I'm just going to make this match this format now. So I'm going to multiply everything by 3. So this would be 3y is greater than -x and then -3. Let me add x to both sides of the inequality. And this gives us x plus 3y is going to be greater than -3. And let's come through here and see what we got. Looks like this top one, 5x plus 3y is less than or equal to 9. And then x plus 3y is greater than -3. So this is what we want right there. Okay, let's look at the second question. And this one is a lot easier because if you look at this one, we have a horizontal line involved. So we can get that one right away. Let's actually save it till the end. Let's do the harder one first. So this has a y-intercept at 0, 3. Maybe I should write this out so nobody gets lost. So y-intercept 0, 3. And a slope of what? Up 1, 2, 3, 4 to the right 1, 2. So m, your slope is rise over run. And in this case, again, I went up 1, 2, 3, 4 and to the right 1, 2. So 4 over 2, which is 2. So y equals 2, which again, that's your m, times x plus b. B here is 3. Okay, so that's your boundary line. And are we shading above or below the boundary line? Well, if you look at it, again, a lot of this is cut off because it's a system, but you can see that the solution, if you were just thinking about this part, would be to shade below the line. Okay, we're shading below the line. So this would be a less than or equal to, because again, it's a solid boundary line, so it's included, right? You want a non-strict inequality. So what we would do from here is just subtract 2x away from each side of the inequality. So I would have minus 2x plus y is less than or equal to 3. Now I already have seen these solutions, and I can tell you that the leading term here is positive. So that's something we often do, and it's really easy to do because all you're going to do is multiply both sides of the inequality by -1. But remember, when you do that, you have to flip the direction of the inequality symbol because you're multiplying by a negative. So this would be positive 2x, this would be minus y, this would get flipped. So now it's a greater than or equal to, and this 3 is a negative 3. So that's how we want to look at that one. And then for the other guy, it's very, very simple. This is a horizontal line, right? So basically it's y is equal to -1, okay? And you can see from the solution, it's basically us shading above the line like this. And that yellow area is the overlap between the two. We shaded below the line here and above the line here. So this right here is going to be a strictly greater than, because again, when I think about this, this is a dashed or broken boundary line, so it's not included, so we want a strict inequality. And let's look. So we have 2x minus y is greater than or equal to -3, and then we have y is greater than -1. So this is what we want right there. Okay, let's look at question 3, which is our final question here. Again, just determine which system matches the graph. And it looks like for this first one, let's just pick this one. My y-intercept occurs at 0, 1, and my slope, let's go down 1 to the right, 1, 2, 3. So my slope, m, is basically going to be -1 over 3, or -1/3. Let's just write it like that. So y is equal to -1/3 x, and then plus 1. Okay, so are we shading above or below? Well, it looks like we're going to be shading above, right, to get into that shaded region. Again, you can do this all the way down just to be clear, but this is a solid boundary line. So this means we're going to have a non-strict inequality. So y is greater than or equal to -1/3 x, and then plus 1. Okay, let's get rid of all this, and let's transform this real quick. Let's multiply everything by 3. So 3y is greater than or equal to, this would be -x, and then plus 3. And then we could add x to both sides of the inequality. So this ends up giving me x plus 3y is greater than or equal to +3. Okay, so that's the first guy. What about the second guy here? Well, the y-intercept occurs at 0, -2. So 0, -2. Again, this is the y-intercept. And the slope, if I go down 1, 2, 3, 4, and then to the right, 1, 2, 3. So it's basically going to be m is -4 over 3, or -4/3. So you would have y is equal to the slope, -4/3, times x, and then plus b, so -2. Okay, let me make this 3 better. Let's get rid of this. For this guy, it's going to be a dashed line, so we know it's a strict inequality, and we're shading below the line. Okay, we can see that. Again, that yellow area is going to be the overlap between the two graphs. For this one, we shaded above the line. For this one, we shaded below. So since it's below, and again, we're using a strict inequality here, we just want a strictly less than. And so I'm just going to multiply everything by 3. So that's going to give me 3y is less than -4x, and then basically -6. Let's get rid of this. And let's add 4x to both sides of this inequality. So that is going to give me 4x, and then basically plus 3y. And this will be strictly less than -6. All right, so we're looking for x plus 3y is greater than or equal to 3. And then 4x plus 3y is less than -6. So we want this answer right there. All right, let's take a look at our quiz. For the first question, we're asked to simplify each. And what we see here is that we have x being cubed, then multiplied by x raised to the 5th power, then times x being squared. So the idea here is we're going to use our product rule for exponents. And basically we use this when we have the same base and we're multiplying exponential expressions. So in other words, everywhere here, we have a base of x, we have a base of x, and we have a base of x. So if we're multiplying and that's the case, we can just keep the base the same. So we keep our base as x, and then what we're going to do is just add our exponents. So we have an exponent of 3, we have an exponent of 5, and we have an exponent of 2. So x here is raised to the power of 3 plus 5, which is 8, plus 2, which is 10. So this would be x to the 10th power. So this is what we want right here. Okay, let's look at the second question. Again, we're asked to simplify each. And so here we have 2x squared, and then we'll have y cubed. Now this whole expression here is wrapped inside of parentheses, and it's raised to the 5th power. So the idea here is that this exponent here of 5 is going to apply to everything inside of the parentheses. So in other words, what I'm saying here is you're going to take 2 and you're going to raise it to the 5th power. Then I'm going to take x squared and I'm going to raise that to the 5th power. And then I'm going to take y cubed and I'm going to raise that to the 5th power. So first and foremost, we have 2 to the 5th power. So there's really nothing you can do with that. You could write it as 32 if you wanted to, but generally speaking, in an exponent section, you would leave it as 2 to the 5th power. Then if we have x squared being raised to the 5th power, this is where we use our power to power rule. So in other words, here, x is going to stay the same, and then I'm going to multiply my exponents. So 2 times 5 would give me 10. Then times, again, y cubed being raised to the 5th power, we have our power to power rule. So my base here, y stays the same, multiply exponents, 3 times 5 is going to give me 15. So what this ends up giving me is 2 to the 5th power, or again, you might want to write 32, times x to the 10th power, times y to the 15th power. So we want this answer right here. Okay, let's look at our third question. Again, we're asked to simplify each. And here we have 3x to the 4th power, and then we have y squared, and then we have z to the 8th power. And this is all wrapped in parentheses, and we're going to raise this to the 7th power. Okay, so again, this exponent of a 7 here is going to apply to everything inside. I'm just going to say 3. Let me make this a little bit better. So 3 is going to be raised to the 7th power. And then x to the 4th power is raised to the 7th power. And then y squared is raised to the 7th power. And then z to the 8th power is raised to the 7th power. So what I'm going to do from here is I'm just going to take 3 to the 7th power. I'll leave that alone for now. And then x to the 4th power being raised to the 7th power, again, power to power rule. So x stays the same. 4 times 7 is 28. And then y squared being raised to the 7th power, y stays the same. 2 times 7 is going to be 14. And then z to the 8th power being raised to the 7th power, z stays the same. 8 times 7 is 56. So our answer here that we're looking for is 3 to the 7th power, and then x to the 28th power, and then y to the 14th power, and then z to the 56th power. So I'm just going to take this answer right there. All right, let's take a look at our quiz. For the first question, we're asked to simplify each. And it looks like we're going to have inside of parentheses 5x squared, and then we'll have y cubed, and I'm going to close this down, and this is all raised to the power of negative 2. So remember, this exponent here applies to everything inside. So what I'm going to do is say that I have 5 raised to the power of negative 2, and then x squared is raised to the power of negative 2, and then y cubed is raised to the power of negative 2. So we know how to simplify with negative exponents. Let me actually slide down a little bit so we have some room. We'll come back up to the answers in a moment. Basically, for this one, there's 2 different ways you can think about it. One way is to take the reciprocal of the base. So in other words, for 5, the reciprocal is 1 over 5. And then just make your exponent positive. So this would be 1 over 5 squared, or 1 over 25. Another way you can think about it is, if you drag an expression across the fraction bar, you always need to just change the sign of the exponent involved. So in other words, if I wrote this as 5 to the power of negative 2 over 1, I could say this is equal to, I can take this and drag it across the fraction bar. I'll put a 1 up here, and now I'll say this is 5. So the base stays the same, but the exponent here just changes the sign. So now it's 1 over 5 squared. So another way to think about that if you want, a lot of students find that easier. So let me say, either way, that this is going to be 1 over 5 squared. Then times, over here, we have x squared being raised to the power of negative 2. Again, x stays the same. 2 times negative 2 is negative 4. And I'll simplify this in a moment. Let's just keep going down. For this one, y cubed is raised to the power of negative 2. Y stays the same. 3 times negative 2 is negative 6. Now, both of these can be drug across the fraction bar. So in other words, I can put an x here, I can put a y here, and then just change the sign of the exponent. So this would be positive 4, and this would be positive 6. So let's get rid of this. And basically my answer here, I'm just going to put this in the middle. My answer here is 1 over 5 squared, or 25, times x to the 4th power, y to the 6th power. So I am looking for this answer right here. Okay, let's look at the second question. Again, we're asked to simplify each. So here it looks like we have 2x to the 4th power, and we're going to multiply this by, let me put this in, you could use brackets or parentheses, whatever you want to use. You're going to have 1 over 3x raised to the power of negative 1, and then let's close this down. This is all raised to the power of negative 2. Okay, so not that bad overall. This 2x to the 4th power, at this point I really can't do anything with it, so I'm just going to copy it. So 2x to the 4th power, then times, everything inside of here is raised to the power of negative 2. So let's put 1 raised to the power of negative 2 over 3 raised to the power of negative 2. And then we'll have x to the power of negative 1, which is raised to the power of negative 2. Now, obviously, you can do this more quickly. I'm just trying to show all the steps so nobody's lost. 1 raised to any power is always going to be 1. So you don't really have to worry about this one. You can actually just delete that exponent and it will be fine. For this 3 to the power of negative 2, again, I can just drag this across the fraction bar. So I can drag this across the fraction bar. And I got to change the sign of the exponent from negative 2 to positive 2. So let's actually just get rid of this and get rid of this. And put a 3 squared up here. Of course, you could put 9, but I'm just going to keep it as 3 squared for right now. And then down here, x to the power of negative 1 raised to the power of negative 2. X stays the same. Multiply exponents. Negative 1 times negative 2 is positive 2. So this becomes x squared down here. So this becomes x squared down here. Now to further simplify, what I'm going to do is put the numerator as 2 times 3 squared like this. And then I'll put times, I'm going to put x to the 4th power over x squared. So we can simplify this using our quotient rule for exponents. So remember, what we do is we keep x the same, and we subtract the exponent in the denominator, which is 2, from the exponent in the numerator, which is 4. So essentially, you get x to the power of 4 minus 2, which is x squared. So what we end up with here is 2 times 3 squared, and 3 squared is 9. 2 times 9 would be 18, and then times x squared. So this is 18x squared. So this is the answer we want right there. Okay, let's look at the third question. And this one looks a little bit involved. So let's look. We have 3x raised to the power of negative 2, then y raised to the power of negative 1, then z raised to the power of negative 5. Now this is all wrapped in parentheses and raised to the power of negative 1. Then this is over. For this guy right here, we have 2x to the power of negative 1. We have y raised to the power of negative 5. We have z raised to the power of 7. This is wrapped in parentheses and raised to the power of 0. Now, for this one right here, you really don't have to worry about anything because any non-zero number or any non-zero expression raised to the power of 0 is going to give you 1. When you get a problem like this in your book, you're going to assume that this guy right here, this expression, is not going to be 0, right? So that you're not violating any laws. Okay, so for this guy right here, I'm just going to say that this is going to be 1. So this would now be, we have 3x to the power of negative 2, y to the power of negative 1, z to the power of negative 5, raised to the power of negative 1. You could put this over 1 if you want, but essentially you could simplify this in a lot of different ways. You could go through and just apply this exponent to everything inside the parentheses, or what you could do is you can actually drag this whole thing into the denominator and change this exponent to positive. Let's just try that just to get something new. It's not necessarily faster, but essentially what would happen is this guy right here is going to go, let me put a fraction bar here and put a 1. It's going to go into the denominator, and I'm only going to change this exponent here. Okay, I'm not going to change the exponents inside. So 3x to the power of negative 2, y to the power of negative 1, z to the power of negative 5. So now instead of this being raised to the power of negative 1, again, I drug it across the fraction bar. Now it's raised to the power of 1, or you can just leave it as being non-visible. And of course, I can just drop the parentheses at this point, and I can further simplify because all these guys can now go into the numerator. And again, it would have been faster for you to just use the power to power rule and multiply because you would have ended up with them in the numerator. But I just wanted to show you something different. So let's go ahead and say that we're going to have x squared, then y, then z to the 5th power. And again, all I'm doing is I'm dragging this guy, and this guy into the numerator, okay, in each case, and I'm changing the sign of the exponent. So negative 2 becomes 2, negative 1 becomes 1, negative 5 becomes 5, and this would be over. Don't forget about that 3 that you still have there. So it's x squared y z to the 5th power over 3. So it looks like I'm looking for this answer here, x squared y z to the 5th power over 3. All right, let's take a look at our quiz. So we're asked for question 1 to write each number in scientific notation, and the number we're given is 836,000. So not a very big number, but we can still write this in scientific notation. So the first thing I'm going to do, I'm going to set this up and put a times 10 and then raise to some power. Let's just put n for right now. This is the general setup. So what goes in this position here, again, you take your decimal point and you move it to immediately after the first non-zero digit in the number. So in this case, I would basically have the number 8.36, and you can drop those zeros there. They don't add value in this case. So let me just put this in here, and I probably need to slide this down so it fits. So let's write in, I'll do this in a different color, 8.3. Let me make the 3 better, so 36. Okay, so the key here is that we need to understand what goes here in this position of n. And I'm just going to count the number of places that I moved my decimal point. So I took it from here and I went 1, 2, 3, 4, 5 places to the left. So in order to get back to where I was, I need to put a 5 here because multiplying by 10 to the 5th power is going to move my decimal point 5 places to the right. So I'm just undoing what I just did, right? So if you punch this into a calculator, you'll be right back to 836,000. So we want 8.36 times 10 to the 5th power. We want this guy right here. Okay, let's look at question 2. So we're asked to write each number in scientific notation. So in this particular case, let's see, we have 3,200,000,000. So 3,200,000,000. Let's write that out. Make sure I don't forget any zeros there. And let me put equals here. I'm going to put my a times 10 to the power of n. Okay, so if you struggle with this, just start off with this format. And then we know basically for this a, I'm going to move my decimal point immediately to the right of the first non-zero digit in the number. So we have that 3 there, so I'm going to put it immediately after the 3. And basically all you're going to have is 3.2 because the zeros that follow don't add any value, so you can just drop them off. So you have 3.2 times 10 to what power? Again, how far did I move this guy? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be a 9 here. And again, all I'm doing is if I multiply this by 10 to the 9th power, I'm just moving my decimal point 9 places to the right, and I'm right back to this number that I started with. So this would be 3.2 times 10 to the 9th power, or this guy right here. All right, let's look at question 3. So again, we're asked to write each number in scientific notation. So this is going to be 0 point, and it looks like I have 4 zeros. So let's put 0, and I'm going to change the colors here, 0, and then 0, and then 0, just so everybody's clear that there's 4 zeros. I know when you have a lot of them in a row and there's no commas in a number like this, it's really hard to really read what's going on. So then let's put 5, 3, 9. Okay, so let's set this up in the same way. I'm going to put a times 10 to the power of n. Okay, so just like this. So what's the a? Again, move the decimal point to the right of the first non-zero digit in the number. So we have to travel all the way to the 5. So you can have this 5.39. So let's put 5.39 there. Let me actually change the color up. So 5.39. And let me make this multiplication symbol over here. All right, so how much did I move the decimal point? So I went 1, 2, 3, 4, 5. So I'm not going to actually put a positive 5 here. I'm going to put a negative 5 here because in this case, if I want to get back to this number, I need to go to the left, right? In the other cases, I needed to go to the right to get back to my original number. Now I need to go to the left, so I want a negative 5 there. So if I did this on a calculator, 5.39 times 10 to the power of negative 5, it's basically like me saying I have 5.39 divided by 10 to the 5th power, and this just means I'm taking my decimal point and moving it 5 places to the left. So what I want here is 5.39 times 10 to the power of negative 5. All right, let's take a look at our quiz. So we're asked to perform the indicated operation, and what we have here is 3x minus 11x squared minus 12, and then we are subtracting away. We have 8x squared minus 13x, and then we are subtracting away 10x plus 8. Okay, so the idea here is that if you're subtracting away a polynomial, you want to change it to addition of the opposite. So in other words, this leftmost polynomial, you can just drop the parentheses. You might want to reorder it and put it in standard form, but that's really up to you. So I'm just going to write it as negative 11x squared and then plus 3x and then minus 12. So for this, since this polynomial is being subtracted away, I'm going to change this to a plus, put a negative 1 out in front. And again, you could just distribute that negative 1 to each term inside the parentheses to remind you to change the sign. So this would now be minus 8x squared, and this would be plus 13x. So you don't have to continuously do this. This is just a little trick that most teachers use. Again, as you do this in the future, you'll just remove the parentheses and change the sign of each term inside. That's all you have to do. So for this one, let's just do the trick again. So we'll put plus, I'll put a negative 1 there. I'm just going to distribute that to each term. So we would have minus 10x and then minus 8. Okay, so from here, you're just combining like terms, so you're not really doing anything hard. You have negative 11x squared and negative 8x squared. That would give you negative 19x squared. Then I have 3x here, and I have 13x here, and I have minus 10x here. So 3x plus 13x is 16x, and 16x minus 10x would be 6x. So plus 6x. And then what else do I have here? It looks like I have this negative 12. And then I have negative 8. So nothing else I can really combine with that. So let's just put this as minus 20, right? Negative 12 plus negative 8 is negative 20. Okay, so this would be our answer. So coming back up here, we want this one, negative 19x squared plus 6x minus 20. So that's going to be our answer. Okay, let's look at the second question here. Again, we're asked to perform the indicated operation. And what we're given here is negative 9x cubed, then minus 6x, then minus 7. Then we're going to go plus, we have negative 14, then minus 8x cubed. Then we're going to go minus, we have 8x cubed plus 10x. All right, so this polynomial here and this polynomial here, they're being added together. So you can just drop the parentheses. So I'm just going to write negative 9x cubed minus 6x minus 7. And then you can put minus 14. You can rearrange it if you want. It's really not necessary. You can end up just combining like terms and then writing that in standard form. So kind of a waste of time if you ask me. Now this minus out in front of these parentheses here, again, you're subtracting away this whole quantity. So again, I'm just going to use a plus negative 1 here. And we're going to change the sign of everything inside. So this would be minus 8x cubed and then minus 10x like this. Let's put equals. So negative 9x cubed minus 8x cubed is going to give me negative 17x cubed. And then negative 17x cubed minus 8x cubed is going to give me negative 25x cubed. Let me actually just put a check mark here and here and here just to show that I use those. You might want to do that on longer problems just to keep track of things. Then I have negative 6x and I have minus 10x. Let me show that I'm going to use this one and this one. So negative 6 minus 10 is negative 16. So this would be minus 16x. So then lastly, I have negative 7 and negative 14. So negative 7 plus negative 14 would be negative 21. So what I'm looking for is this answer here. This negative 25x cubed minus 16x minus 21. That guy right there. Okay, let's look at question 3 now. So we have negative 6x squared plus 7 minus 8x. Close that down. Then we have plus. This other guy here is going to be negative 9x plus 4. And then we have plus. This guy right here is going to be 14x cubed plus 12x squared. Now, if I'm adding polynomials, I can just drop the parentheses. I don't need to do anything special. I can just go right into combining like terms. So let me just write negative 6x squared. And then I'll just put this in standard form. So minus 8x and then plus 7. And then we'll put, this is going to be minus 9x and then plus 4. And then over here, this is going to be plus 14x cubed and then plus 12x squared. Okay, so what I want to do from here is I have an x cubed term here. Nothing to combine with it, but I'm just going to put it out in front for standard form purposes. So 14x cubed. And then I have negative 6x squared and 12x squared. So if I do negative 6 plus 12, that's positive 6. So plus 6x squared. Let me actually check these off as I use them so we don't lose track. Then I have negative 8x minus 9x, that's negative 17x. Let me check these two off. Lastly, I have 7 plus 4, that's 11, so plus 11. And let me check these off. So this is going to be my answer here. So it looks like I'm looking for this one right here, 14x cubed plus 6x squared minus 17x plus 11. All right, let's take a look at our quiz. So we're asked to find each product, and we are given 8x squared multiplied by this quantity, 3x squared plus 2x minus 7. So all we really need to do here is take this monomial here, or this term you can think about it as, and basically use the distributive property to multiply by each term inside of the parentheses. So that's how we're going to simplify this. So 8x squared times 3x squared, we would do 8 times 3, that's 24. And then you're going to do x squared times x squared. X stays the same. Add the exponents. 2 plus 2 is going to give me 4. Then we're going to go plus. We have 8 times 2. That's going to be 16. X squared times x to the first power. X stays the same. Add exponents. 2 plus 1 is going to give me 3. Then I know this is positive times negative, so that's negative. Then 8 times 7 is 56. And then I would say the x squared comes along for the ride. So this would be my answer here. I'm looking for 24x to the fourth power plus 16x cubed minus 56x squared. So I want this answer right here. Okay, let's look at the second question. So we're asked to find each product, and we have the quantity x plus 1 times the quantity 4x plus 1. And most of you already know that there's a quicker way, or I wouldn't say a quicker way, I would say an easier way to remember how to do this, and that's called FOIL, but we're not going to get to that until the next lesson. So for right now, let's actually do this in a different way. What I'm going to do is I'm going to take each term from this first polynomial, and multiply it by this second polynomial. And then when we're done with that, we'll combine like terms. So in other words, I'm going to take x and multiply by the quantity 4x plus 1. Then we'll go plus. We're going to take 1 and multiply by the quantity 4x plus 1. Okay, so x times 4x, we know that 4 would just be there. X times x would be x squared. And then plus x times 1 is just x. And then plus 1 times anything is just itself. So this can just be written as 4x plus 1. So from here, you would just combine like terms. And you can see in the middle, x plus 4x can be combined. So basically, you can treat this as having a coefficient of 1. And so what that gives me is a solution here of 4x squared, nothing combined with that, plus we know 1 plus 4 is 5, x comes along for the ride, so this is plus 5x, and then plus 1. So I'm looking for this 4x squared plus 5x plus 1, so this guy right there. Okay, let's look at question 3. Again, we're asked to find each product. I'm going to actually rearrange the way I read this and write this. I'm going to put the quantity 8x plus 7 on the left, and then on the right, I'm going to put the 6x squared, and then minus 3x, and then plus 3. You're free to do it either way, but this is just how I prefer to set it up. Okay, so what I'm going to do is take each term from this first polynomial, or the leftmost, and multiply it by this second polynomial. Once we're done with that, we'll just combine like terms. So in other words, I'll take 8x and multiply it by the quantity 6x squared minus 3x, and then plus 3. And then I'm going to add to that 7. Let me slide this down so it fits. So this will be multiplied by the quantity 6x squared minus 3x, then plus 3. Okay, and these 3's are not looking too hot, so let's fix those real quick. All right, so let's just go through and crank this out. It's just something you have to deal with. So 8x times 6x squared, 8 times 6 is 48. And then x times x squared, x stays the same. This is an exponent of 1 plus an exponent of 2. 1 plus 2 is 3. And then we have minus 8 times 3 is 24. X times x, we know that would be x squared. So this is x squared. Then plus 8 times 3 is 24. And I always say x comes along for the ride. Okay, so let's move on. You can probably slide this down just a little bit so it fits. And then down here, you have 7 times 6. Let's write that as 42. And then x squared would come along for the ride. Then we know this is minus 7 times 3 would be 21. And then x would come along for the ride. And then plus 7 times 3 is just going to be 21. Okay, so now really it's just a matter of combining like terms. Now looking through here, you see this exponent of 3. That's going to be your highest exponent. So you're going to want to write this term 48x cubed first. There's nothing we can combine with it. I don't have another x cubed involved in this problem. So I'm just going to write it and forget about it. And then from there, let me put a check mark. From there, I have an x squared here and an x squared here. And so negative 24x squared plus 42x squared is going to give me 18x squared. Let's check this one off and check this one off. Then I've got 24x and negative 21x. That's going to be 3x. So let's check this off and this off. Put plus 3x like this. And having trouble with the 3's today, so let's make that again. And then I have plus 21. Nothing I can really do with that. So this would be my answer. So we want 48x cubed plus 18x squared plus 3x plus 21. So this is our answer right here. All right, let's take a look at our quiz. For the first question, we're asked to find each product. And what we have here is the quantity 3x minus 1 being multiplied by the quantity 3x plus 2. So when we have the product of two binomials, we can use FOIL. And so to go through FOIL, we're going to do the first terms. So 3x times 3x, that's going to be 9x squared. Then we're going to do the outer terms. So we're going to have 3x times 2. So plus 3 times 2 would be 6, and x would come along for the ride. Then we're going to do our inside terms. So we'd have negative 1 times 3x. So that's just negative 3x. And then for the last terms, we have negative 1 times positive 2. So that's just negative 2. So once we've gone through these steps, so the f, the o, the I, and the l, you just combine like terms. So what we're going to have here is 6x minus 3x. And 6x minus 3x would just give me 3x. So my final answer here would be 9x squared, and then plus this 3x, and then minus 2. So I'm looking for this answer right here. Okay, let's look at question 2. Again, we're asked to find each product. And so what we have here is 4x minus 5. So this quantity multiplied by the quantity 6x plus 2. Okay, so for the first terms, you have 4x times 6x. So you're going to do 4 times 6, that's 24. And then x times x is x squared. For your outer terms, you have 4x times 2, that's plus 8x. For your inner terms, you have negative 5 times 6x, that's negative 30x. And then for your last terms, you have negative 5 times 2, that's negative 10, or you put minus 10, however you want to think about that. Okay, so you can combine like terms in the middle. Again, what you have here is 8x and negative 30x. So basically, if you do negative 30 plus 8, that's going to give you negative 22. So let's write our final answer here as 24x squared. I'm going to put minus 22x and then minus 10. So I'm looking for this answer here, the 24x squared minus 22x minus 10. All right, let's look at question 3. So again, we're asked to find each product, and we're going to have the quantity 5x plus 5y times the quantity 7x plus 2y. All right, so we're going to do the first terms. So 5x times 7x, 5 times 7 is 35. X times x is x squared. For the outer, we have 5x times 2y, that's plus. 5 times 2 is 10, x times y is xy. For the inner, we have 5y times 7x, so that's plus. 5 times 7 is 35, and x times y is xy. And then for the last, we have 5y times 2y, so this is plus. Let me slide this down a little bit. 5 times 2 is 10, and then y times y is y squared. So do we have any like terms? Yes, we do. We have 10xy and we have 35xy. So we can combine those like terms. So let's say that we have our 35x squared, and then I'm going to do 10 plus 35, that's 45, so plus 45. And then the xy would come along for the ride. And then plus we have this 10y squared. So I am looking for this answer right here. So the 35x squared plus 45xy plus 10y squared. All right, let's take a look at our quiz. So for the first question, we're asked to find each product. And what we're given is this binomial, or this k minus 4, and then this is going to be squared. So the idea here is we're just going to use our little formula. And so what you want to do is you want to take this first term, which is k, and you want to square it. So k is going to be squared. Now, because this is a minus, this sign always goes, whatever it is. If it's a plus, it goes here, or a minus, it goes here. So the next guy right here, just remember, this sign always goes in that position. Then for the middle part here, what you want is 2 times the first guy, so in this case that's k, times the last guy, in this case that's 4. So 2 times 4 is 8. So let's just do that in another step. So let me go k squared minus, I'm going to put this as 8k here. And then the last guy is always going to be a plus, and you're going to take whatever this is here in the last position, and you're going to square it. So in this case, what we end up with is k squared minus 8k plus 16. So we want this answer right here. Okay, let's look at question 2. So we want to find each product, and what we're looking at here, we have conjugates. So essentially we have 2k minus 2, that quantity, times the quantity 2k plus 2. So the idea here is that if you were to do FOIL, the middle 2 terms would cancel, right? So what you want to do is shortcut this a little bit and say, well, all I have to do is take the first guy, which is 2k, and square that guy, and then subtract away the last guy, which is 2, and square that guy. So 2k squared, the 2 is being squared, and also the k is being squared, and then minus 2 squared like this. So let's say this is going to be 4k squared minus 4. So I'm really looking for this guy right here. So this 4k squared minus 4. So this is my answer. Okay, let's look at question 3. Again, we're asked to find each product. So here we have negative 8x minus 7y. So this quantity will be multiplied by this quantity, which is negative 8x plus 7y. So again, we have conjugates here. You have the same terms, but you have different signs. So in other words, you have a negative here and a positive here. So just keep that in mind. So we're just going to shortcut this. Again, you don't have to use FOIL here because the middle 2 are going to drop out. So just square the first guy. So negative 8x is going to be squared. Then subtract away the last guy being squared. So 7y is being squared. So this negative, if it gets squared, is kind of like squaring negative 1. You're just going to get positive 1. So that negative is going to go away. So you're going to have 8 squared, which is 64. Then times x squared, which is just x squared. Then minus, here you'd have 7 squared, which is 49. And then times y squared, which is just y squared. So I'm looking for 64x squared minus 49y squared. So this guy right there. All right, let's take a look at our quiz. For the first question, we're asked to find each quotient. And it looks like we have 50x cubed, and then plus 5x squared, plus 40x. And I'm going to write this as a fraction. So this will all be over this 10x. So if you get something like this, you just want to break it up. And so what I'm going to do is I'm going to take each term from this numerator and divide it by this denominator, or you could say the divisor. So essentially what I'm going to have is 50 10x cubed over 10x, then plus 5x squared over 10x, then plus 40x over 10x. Okay, so going through this, I know that this x cubed would cancel with this x, and I'd have x squared. And then 50 divided by 10 is 5. So essentially in the first position, what I'm going to have is 5x squared. Then plus, coming over here, I know that 5 and 10, if I cancel a common factor of 5, this would be a 2, and let's go ahead and put a 1 up there. And then I can cancel this 2 up here because I have x squared with this x here, so this would be x to the first power. So essentially you would have plus, this would be x over 2 here, and then plus 40 divided by 10 is 4, x over x is 1, so let's put 4 there. So this is what we're looking for. So coming back up here, we want 5x squared plus x over 2 plus 4, so we want this guy right there. All right, let's look at question 2. Again, we're asked to find each quotient. So here we have, and I'm just going to shortcut this, I'm going to put 36x cubed over 9x, and then plus 3x squared, and then over 9x, and then plus 3x over 9x. Again, all you have to do is write this dividend, or you could say the numerator in this case if you're writing it as a fraction, as split up to where each part here is divided by this denominator, or you could say the divisor. So then you just go through and simplify individually. That's all we're really doing here. 36 divided by 9 is 4. X cubed over x would be x squared. And then 3 and 9 have a common factor of 3. Let's put a 1 up there. X squared and x, I can cancel this with one of these. So that's x to the first power. And then let's do this again. Common factor of 3. Let's put a 3 here and a 1 here. And let's cancel this common factor of x. Okay, so what does that leave me with? Up here, I just have 4x squared. So 4x squared. And then what I have here is this x here, so x to the first power. So plus x over, this would be 3. And then over here, I just have 1/3. So this is what I'm looking for my answer. So 4x squared plus x over 3 plus 1/3. So this guy right there. Okay, let's look at question 3. Again, we want to find each quotient. So again, I'm just going to shortcut this, and I'm going to take each term here from this dividend, or you could say the numerator if you write this as a fraction, and divide it by this divisor, or you could say the denominator, again, if it's a fraction. So you put x cubed over 4x, then plus 3x squared over 4x, and then plus 4x over 4x. Okay, so for this one, I know that I can cancel one of these with this, so this would be x squared. And then for this one, I know I can cancel one of these with this, so this is x to the first power, and this is going to cancel completely and be 1. So be careful here. Remember, when this cancels, it's 1. A lot of people make the mistake of just canceling that out and putting it as 0 or something like that and then forgetting that it's there. So you want to make sure that 4x divided by 4x is 1 and that you write a 1 there. So that's very important. So here we're going to have x squared over 4, and then plus we'll have 3x over 4, and then plus we're going to have 1. So I'm looking for this answer right here. So x squared over 4 plus 3x over 4 plus 1. All right, let's take a look at our quiz. So we're asked to find each quotient, and let's write this out. So we're going to have a dividend of 3x cubed plus 11x squared plus 4x and then minus 7. So minus 7. And then our divisor is x plus 2. So x plus 2. Now I'm just going to tell you in advance, this is pretty easy to do overall, but it's very common to make a lot of silly mistakes when you're doing this and to end up with the wrong answer. So just take your time and check your steps as you go. Remember, we're going to use D, M, S, B, R. A lot of people remember this as dad, mom, sister, brother, rover. Dad, mom, sister, brother, rover. If you have to repeat that a few times, if you're lost on which step to do, you can go through that. Again, this is divide, multiply, subtract, bring down, repeat, or remainder. So let's just go through those steps. We start with division, and we're going to do leading term into leading term. So in other words, I'm going to say, what is 3x cubed divided by x? Well, this is going to give me 3x squared, right? Because this would cancel with this and give me a 2 here. Now, I always place this over the x squared term, so I would put this like this, 3x squared. Some books will put this all the way to the left. It's really up to you. I like putting it this way. I think it looks a little bit better. But again, just a personal choice. All right, so now we multiply. So 3x squared times x is 3x cubed. 3x squared times 2 is plus 6x squared. So now we're going to subtract. Now here's where people make a mistake. A lot of times they just put a subtraction symbol here, right? You can't do that because you have to subtract the whole polynomial away. So what that means is you have to change the sign of each term. So we're going to remove this and change this. Okay, so make sure you change the sign of each term in the polynomial that's being subtracted away. This is the most common error when you're doing this type of problem. So let's make a little bar here, and then let's subtract. So we know this is going to cancel. 11x squared minus 6x squared would be 5x squared. And so now we're at the bring down step. So let's bring down this next term. And again, we repeat the process. So we're going to go back to division. Let me erase this highlighting, and let me now highlight this guy. You're doing leading term into leading term. Now, we all should know that 5x squared divided by x is just going to give me 5x. But again, if you need to write it off to the side, then do so. Okay, you don't want to make silly mistakes, even if it takes you more time. So you want to cancel this with this and put this as 5x. So we'll put plus 5x like this. And we'll get rid of this. And then from here, we're just going to multiply. So what is 5x times x? Well, that is going to give me 5x squared. Then what is 5x times 2? Well, that's going to be plus 10x. Okay, from here, let's subtract. Again, you can do the minus in front of a set of parentheses, or if you're getting confident, you can just change the sign of each term. It's really up to you. So this is going to cancel. 4x minus 10x would be negative 6x. Now we're going to bring down the next term, so negative 7, and then we repeat the process. So let me get rid of this highlighting, and let me now highlight this guy right here. So we're going leading term into leading term. So what is negative 6x over x? The x's cancel, and you just get negative 6. So let's put minus 6 here, and then we're going to multiply for one last time. Negative 6 times x is negative 6x. Then negative 6 times 2 is negative 12. Okay, let me come down here a little bit. I'll come back up in a second. Remember, you're subtracting the whole thing away. So I'm just going to change the sign of this guy and this guy. Okay, don't change the sign of only one. Again, that's the most common mistake. That's why I keep repeating myself. So then over this is going to cancel. Negative 7 plus 12 is going to be positive 5. So this is your remainder, this 5 here. So if we go back up, we would say the answer is this 3x squared plus 5x minus 6, and then plus the remainder was 5, and this gets written over the divisor, which is going to be x plus 2. So that's how you would answer that. So looking through my answers here, I see that I have 3x squared plus 5x minus 6, and then plus 5 over x plus 2. So I want this answer right here. Okay, let's look at another one. So this is question 2. So again, we're going to find each quotient. So let's go x cubed and then minus 11x squared plus 28x and then plus 6. And then for this one over here, the divisor is x minus 5. Okay, so let's go a little bit more quickly on this one. Again, we're using DMSBR. Dad, mom, sister, brother, rover, divide, multiply, subtract, bring down, repeat, or remainder. So leading term into leading term. X cubed divided by x is x squared. So let's write x squared here. Then x squared times x is x cubed. X squared times negative 5 is minus 5x squared. We're going to subtract this polynomial away. So I'm going to change this sign and this sign. And then what I'm going to do is combine the like terms. So x cubed minus x cubed is 0. Negative 11x squared plus 5x squared is going to be negative 6x squared. I'll bring down my next term, so plus 28x. And now I'm going to repeat the process. So leading term into leading term. What is negative 6x squared divided by x? We know that negative 6 would be there, so let's put negative 6. X squared divided by x is just x. So this is minus 6x. And then we multiply. So negative 6x times x, we know that's negative. We know we have a 6. X times x is x squared. And then negative 6x times negative 5, we know that's positive. 6 times 5 is 30. And then we just have x that comes along for the ride. Okay, so we're going to subtract the polynomial away. So this becomes a plus and this becomes a minus. Again, you've got to change the sign of both of those guys. Then this would cancel. 28x minus 30x would be negative 2x. And now I'm just going to drop down this 6, so plus 6. And then I'm going to repeat this process. So we're going to go leading term into leading term. So negative 2x divided by x would simply be negative 2. So let's put minus 2 here. And then we're going to multiply. So negative 2 times x is negative 2x. And then negative 2 times negative 5 is plus 10. And so from here, again, I'm going to change this sign and change this sign. I'm subtracting the polynomial away. This is going to cancel. 6 minus 10 is going to be negative 4. So this would be my remainder here. So coming back up here, I have x squared minus 6x minus 2. And then you can put minus 4 over. Your divisor is x minus 5. So I'm looking for this answer right here. So this x squared minus 6x minus 2. and then minus, you have this 4 over x minus 5. So that's the answer I want. All right, let's look at question 3. So again, we're asked to find each quotient. So we have x to the 4th power minus 9x cubed, then plus 14x squared, then plus 14x, and then minus 5. And then this is going to be divided by this x minus 3. So we're going to go leading term into leading term. X to the 4th power divided by x is x cubed. So we're going to have x cubed. We're going to multiply x cubed times x is going to be x to the 4th power. Then x cubed times negative 3 is minus 3x cubed. We're going to change the sign of everything here. So this is a minus and this is a plus. And then we'll combine like terms. Negative 9x cubed plus 3x cubed is negative 6x cubed. Bring down the next term. So plus 14x squared. And then we start the process over. So leading term into leading term. So we know this is just going to be negative 6. So let me put negative 6 here. And then x cubed over x is just going to be x squared. Now we multiply. So negative 6x squared times x is going to be negative. We're going to go 6x cubed. And then negative 6x squared times negative 3. We know that's positive. 6 times 3 is 18. X squared comes along for the ride. Okay, I'm going to go back and forth here. I think we're going to run our room otherwise. So I'm going to change the sign of this guy and change the sign of this guy. And so this would cancel. 14x squared minus 18x squared is negative 4x squared. Let's drop down this next term. So plus 14x. And again, we're just going to repeat the process. So negative 4x squared divided by x. Again, leading term into leading term. Well, we know that negative 4 would be there. And then x squared divided by x is just x. So this would be negative 4x. So let me write negative 4x here. Again, I'm going to multiply. Negative 4x times x is negative 4x squared. And then negative 4x times negative 3 is plus 12x. We'll come back up in a moment. I'm just going to slide down so this is in focus. So I'm going to change this to plus and change this to minus. Combine like terms. This cancels. 14x minus 12x is 2x. Okay, so for the last time, we're going to bring down a term here. So I'm going to bring down this negative 5. You go leading term into leading term. So we would have 2x here divided by x, which we know is 2. So let me put plus 2 here. And then 2 times x is going to be 2x. And then 2 times negative 3 is going to be negative 6. Let's come down here and let's subtract this and add this. Again, just change the sign of everything. This cancels. Negative 5 plus 6 is going to be positive 1. So that's my remainder there. So we're going to have this x cubed minus 6x squared minus 4x plus 2, then plus, again, the remainder was 1, and this will be over my divisor, which is x minus 3. Okay, so I'm looking for this answer right here. Again, it's x cubed minus 6x squared minus 4x plus 2. Then plus, you have your 1 over x minus 3. All right, let's take a look at our quiz. For question 1, we're asked to find each quotient. So let's write out what we have. We have x cubed and then minus 125. So remember, if you're doing division with polynomials, you want to use 0 as a placeholder for each missing term. So I'm missing x squared and x to the 1st power. So I'm going to put plus. Let me do this in a different color so it stands out. So 0. And then I'll go back to black. We'll say x squared and then plus. Again, I'm going to use a different color here. So I'll put 0. And then I'll go back to black. So then x. And then minus this 125. So let's set this up like this. And then the divisor here is going to be x minus 5. So x minus 5 like this. Okay, so hopefully you remember how to do this from the last section. Again, you can always write the DMSBR, the dad, mom, sister, brother, rover, to recall what steps you need to do. So divide, multiply, subtract, bring down, and then repeat or remainder. So we start with division. And again, we do leading term into leading term. So here I have x cubed that's going to be divided by x. So I can do this off to the side. So x cubed divided by x is going to be x squared. Remember, I like to write it here. But again, if you're more comfortable writing it over here, some books do that. It's really up to you. It's personal preference. So after we've done our division, we're going to multiply. So x squared times x is going to be x cubed. And then x squared times negative 5 is going to be minus 5x squared. Okay, so here, again, we go to the subtraction step. And instead of wrapping this like this, I think at this point we know that we're just going to change the sign of each term. So I'm going to put this as a minus and this as a plus, and then we're going to combine like terms. If you keep struggling with that step, again, you can always wrap your polynomial in parentheses, put a negative out in front, and then drop the parentheses and change the sign of each term inside. Okay, so we're just going to combine like terms. So this is going to cancel the x cubed minus x cubed. That's gone. Then 0x squared plus 5x squared is just 5x squared. I'm going to bring down the next term. I realize it's 0x, but we're just going to do that. So we're going to bring down the 0x. And then we're going to repeat the process. So in other words, we're going to go leading term into leading term. So 5x squared divided by x, I think all of us know that is basically going to be 5x. So let me put plus 5x here. And then we're going to multiply. So 5x times x would be 5x squared. And then 5x times negative 5 would be minus 25x. So again, when I come to the subtraction step, I'm going to change the sign of this one and this one. So now I'm going to combine like terms. This cancels. 0x plus 25x is just going to be 25x. And then I'm going to bring down this last term here, which is negative 125. And again, now I'm going to repeat the process. So what is 25x divided by x? Well, that's just going to be 25. So let me do this in a different color. I'm just going to put plus 25 here. And I'm going to multiply. So 25 times x is going to be 25x. And then 25 times negative 5 is going to be negative 125. And again, for subtraction, I'm just going to change the sign of each. So this will be negative and this will be positive. And again, if we combine like terms, then this will cancel and so will this. So basically, you're going to end up with 0, so there's no remainder. So the answer I'm looking for here is x squared plus 5x plus 25. Again, you can always check this with multiplication. So coming back up here, I want the x squared plus 5x plus 25. So that's what I'm looking for. Okay, let's look at the second question. Again, we're asked to find each quotient. And now we're going to have x to the fourth power plus 2x cubed, and then plus 2x squared, and then minus x, and then minus 1. And then my divisor over here, I'm missing x to the first power. So I'm going to write x squared plus, let me do this in a different color. So 0, let me come back to this other color, x. And I didn't give myself enough room, so let me slide this down a little bit. And then I need plus 1 here. Okay, so again, the procedure is the same. So we're going to go leading term into leading term. So what is x to the fourth power divided by x squared? That's going to be x squared. Again, I'm going to write this over here. If you want to write it all the way to the left, once again, that's up to you. I'm going to multiply x squared times x squared and get x to the fourth power. And then x squared times 0x. Let's just put this as plus 0x cubed. I realize that multiplying 0 by anything is just 0, but just as a placeholder, let's do it this way. And then x squared times 1, let's put plus x squared. Okay, so again, when we subtract away this polynomial, I'm just going to change the sign of everything. So then we're going to combine like terms. This is gone. This would be 2x cubed. And then 2x squared minus x squared would be just plus x squared like this. And I'm going to drop down or bring down my next term. So minus x comes down here. Okay, so now we repeat the process. You have leading term into leading term. So 2x cubed divided by x squared. We know that would be 2. So let me put plus 2 here. X cubed over x squared is just x. So it's plus 2x there. And then multiply. So 2x times x squared is 2x cubed. And then 2x times 0x, let's just put this as plus 0x squared. And then 2x times 1, let's put plus 2x. Again, when we get to this subtraction step, I just want to change the sign of this guy, and this guy, and this guy, and then just combine like terms. So this is gone, x squared. You say minus 0x squared is just x squared. And then negative x, you can put a negative 1 there if it's helpful. So negative 1x minus 2x, or negative 1x plus negative 2x, is going to be negative 3x. Okay, let me drop down or bring down this next term. So this is negative 1 here. And then we just do leading term into leading term. So x squared divided by x squared is obviously 1. So let me put plus 1 here. And then I'm going to multiply 1 times this guy, so I can just copy it. It's going to be x squared plus 0x and then plus 1. And I'm going to come down here. I don't think we can fit this all on the screen. I'm going to change this to minus, and this to minus, and this to minus. And let's see what we have. So this cancels. Negative 3x minus 0x. You might as well just say it's negative 3x minus 0. This is just negative 3x. And then negative 1 minus 1 is going to be negative 2. So this negative 3x minus 2 is my remainder. So let's come back up here. I think I can actually fit it all on the screen. So we're going to have x squared plus 2x plus 1, and then plus this negative 3x minus 2 over this divisor here of x squared plus 1. So I'm looking for this answer right here, the x squared plus 2x plus 1, plus you have your remainder, the negative 3x minus 2, over your divisor, x squared plus 1. This is what we're looking for right there. All right, let's look at the third question. Again, we're asked to find each quotient. So here it looks like in the dividend, we're missing x to the first power. So let's write x cubed and then minus 2x squared. And then again, let me change the color. So plus, I'll do this in like a maroon. So 0, let me go back to black here. So this is my x to the first power. And then also we have minus 9. So then let's put this like this. We have x minus 3 out here. Okay, so again, you already know what to do. We're going to go leading term into leading term. X cubed divided by x is going to be x squared. If we multiply x squared times x is going to be x cubed. And then x squared times negative 3 is minus 3x squared. And then for the subtraction step, let's change this to minus and this to plus. We'll combine like terms. This will cancel. Negative 2x squared plus 3x squared would be x squared. Drop this down, so plus 0x. And just repeat the process. So x squared divided by x would be x. So let's put plus x here. Multiply x times x is x squared. And then x times negative 3 is minus 3x. And again, we're going to change the signs here and combine like terms. So this is minus and this is plus. So basically, you would just have 3x out of this. And I would drop down this last term, this minus 9. And then just do this one more time. So we're going to go division. 3x divided by x is 3. So plus 3. And then we're going to multiply. So 3 times x is 3x. And then lastly, 3 times negative 3 is going to be negative 9. And of course, because we're subtracting this away, I'm going to change this sign and this sign. And so, of course, this is going to cancel out completely. 3x minus 3x is 0. Negative 9 plus 9 is 0. So this is a big fat 0 here, so no remainder. So my answer here is going to be x squared plus x plus 3. So I want this x squared plus x plus 3. All right, let's take a look at our quiz. For the first question, we're asked to find the greatest common factor for each. And let's see, we have this 15x squared y. We're going to have this 30x to the 4th power y squared. And then we're going to have 40x to the 6th power y cubed. Okay, so this is one of those things that as you practice more and more, it becomes really, really, really easy. This is something that after a while, you can just eyeball this and quickly get your answer. But when you first start, you really do need to take the time to break things down. So for the number parts, you're just going to factor everything. So this would be 5 times 3. And this, let's think about 30, it's 3 times 10. So I'm going to put 3 times 5 times 2. Let me put the 2 over here. And then for 40, it's basically 8 times 5, and 8 is 2 cubed. Let me put 2 cubed times 5. Okay, so if I'm building my GCF, and I'm thinking about just the numbers right now. We'll get to the variables in a second. Those are easier to do. Well, when we think about it, we're looking for prime factors that are common to everything, okay? So in other words, I have a 2 here, and I know it's 2 cubed, but we have a 2 here, we have a 2 here, but no 2 here, so it can't go in. Then I have a 3 here and here, but not here, so it can't go in. I do have a 5 that is common to everything, here, here, and here. So you want to always go with the smallest number of repeats between any of the prime factorizations when that prime factor is common to everything. In this case, we only have 5 to the 1st power everywhere, so I'm just going to put a 5 in. So that's all you need to do. So let's get rid of this. And now let's think about the variable part. This is really, really easy. So basically, you just ask yourself the question, is that variable involved in each term? I have an x, I have an x, I have an x. What's the smallest exponent on that variable? Here's a 2, a 4, and a 6, so I want x squared. That's all you need to do. Then for y, you have it there, there, and there. The smallest exponent is a 1, so just put a y there. So I'm looking for 5x squared y. That's going to be my GCF. So I want this 5x squared y. Okay, let's look at question 2. Again, we want to find the greatest common factor for each. So we're going to have 12x squared y squared z squared. And then we're going to have 60x squared y. And then we're going to have 84 z squared y. Okay, so number-wise, if we think about the GCF, again, a lot of you will notice that everything here is divisible by 12. So 12 divided by 12 is 1, 60 divided by 12 is 5, and 84 divided by 12 is 7. So we already know that this is going to be 12. But again, to do this the slower way, in case you want to see that, this is what? It's 4 times 3, or 2 squared times 3. 60 is 5 times 12. So we'll basically say it's 2 squared times 3 times 5. And then 84 is 12 times 7. So 2 squared times 3 times 7. So again, when you look at what's common to everything, it's 2 squared times 3. So 2 squared times 3, 2 squared times 3. The 5 and the 7 are not common to everything. So when you build your GCF, you're going to get 4 times 3 or 12 as the GCF. Okay, so that's the number part. All right, when we go to the variable part, again, is the variable involved in everything? You have an x here and here, but not here. So x does not go in. You have a y here and here and here. So y goes in. The smallest exponential power is a 1, right? Occurs there and there. So it's just going to be y. And then for z, it occurs here, but not here, right? So it can't go in. So the GCF here is going to be 12y. So we want that guy right there. Okay, let's look at question 3. Again, we want to find the greatest common factor for each. All right, so we're going to have 45 and then x cubed, and then we're going to have q to the 5th power, and then we have 63, and then we have q to the 4th power, and then we have y squared, and then we have 81. Let me slide this down here a little bit. So then we have x being cubed and then y being squared. Okay, so number-wise, I think that pretty much everybody will see that the GCF is going to be 9, right? So number-wise, it's 9. Again, if you need to factor everything, you can, but if you look at 45, it's 9 times 5, or 3 squared times 5. If you look at 63, it's going to be 9 times 7, or 3 squared times 7. If you look at 81, it's 9 times 9, or 3 to the 4th power. So what's going to be common to everything is 3 squared or 9. So that's going to be the number part. Now, variable-wise, you have an x here, no x. Then you have a q here, no q. Then you have a y here, but no y here. So really, it's just 9 is the number because none of these variables are going to be common to everything, so it can't go in when you build your GCF. So we just want a 9 here as the answer. All right, let's take a look at our quiz. For the first question, we're asked to factor out the greatest common factor from each. And what we have here is 27x cubed and then plus 9x. So what is the GCF from these two terms? We have a 9 here and a 27 here. So basically, you know that 27 is divisible by 9 and so is 9. So the number part would be 9. So let's go ahead and put a 9 here. And then variable-wise, I have an x cubed and an x to the 1st power. So I'm going to go with x raised to the smaller power, which is just the 1st power or just x. So we have 9x here, and that goes out in front of a set of parentheses. And what goes inside of here is you're going to take the original terms and you're going to divide it by the GCF. So 27 divided by 9 is 3. X cubed divided by x is x squared. And then 9x divided by 9x is going to be 1. So I'm looking for 9x multiplied by the quantity, 3x squared plus 1. So I want this answer right here. Okay, let's look at question 2. Again, we're asked to factor out the GCF or greatest common factor from each. So we have 25x to the 4th power minus 15x cubed. Looking at 25 and 15, I know they're both divisible by 5. This is 5 times 3, and this is 5 times 5. So now I can pull out a 5. Let's go ahead and do that. And then variable-wise, I have x to the 4th power and x cubed. So now I can pull out an x cubed. Again, what goes inside here, I'm just going to take these original terms and divide them by the greatest common factor. 25 divided by 5 is 5. X to the 4th power divided by x cubed is going to be x. We have our minus there. 15 divided by 5 is 3. X cubed over x cubed is 1. So I'm looking for 5x cubed times the quantity 5x minus 3. So this guy right there. Okay, let's look at question 3. So again, we're asked to factor out the GCF from each. So this one looks kind of long. So 125. We have x cubed. We have y to the 5th power. Then plus we have 60x to the 4th power. And then y to the 4th power. And then minus 85x to the 5th power. And then we have z squared. Okay, so let's think about 125, 60, and 85. So I know everything is divisible by 5. In fact, this would be 5 times 25, or you could say 5 cubed. So this is 5 cubed. And this right here is 5 times 12, right? 12 is 4 times 3, so 5 times 2 squared times 3. And then 85 is 5 times 17. So what's common to everything is one factor of 5. So let's pull that out. Basically put that right here. Variable-wise, I have an x, an x, and an x. The smallest power is a 3, so let's put x cubed. And then we have a y, and no y. And we have a z, and no z, and no z. Okay, so this is what we're pulling out. Again, put these guys in here, and you're just going to divide. You're just going to divide each term by this GCF to get what goes inside the parentheses. 125 divided by 5 is 25. X cubed over x cubed is 1, so you just have y to the 5th power. 60 divided by 5 is 12. X to the 4th power over x cubed is x, and then y to the 4th power will come along. And then 85 divided by 5 is 17. X to the 5th power over x cubed is x squared. And then you would have z squared. So let's put that like this. So it looks like I'm looking for this answer right here, which is going to be 5x cubed times the quantity 25y to the 5th power plus 12xy to the 4th power minus 17x squared z squared. All right, let's take a look at our quiz. We want to factor each using the grouping method. So the idea here is to write out, we have 4x cubed plus x squared plus 8x plus 2. So you can take the first two as a group and the last two as a group. Again, you're trying to pull out a common factor and then look for a common binomial factor. So sometimes that works. Other times you have to switch the grouping around. But for this one, it'll work fine. So from the first two, you'll notice that you could pull out an x squared. And what that would give you is 4x plus 1. From these second two here, I could pull out a 2. And what that's going to give you is 4x plus 1. So the idea here is that I've obtained this common binomial factor, so the 4x plus 1. So in other words, what I can do here is pull this out in front of some parentheses. So 4x plus 1, that is getting factored out. So this is going here and here. And then inside the parentheses here, what's left? You have x squared, and then plus, you have this 2 here, right there. So I'm going to put that there. So what we want is this answer right here. It's in a different order, but it's multiplication, so it doesn't matter. You have x squared plus 2, you have x squared plus 2, and then this is multiplied by, you have this 4x plus 1, you have this 4x plus 1. So this is the answer we want right there. Okay, for question 2, again, factor each using the grouping method. Looks like we have 2xy minus 14x, and then plus y squared minus 7y. So you want to eyeball things and see if the variables are going to work out. So in other words, if I have the first two as a group, if I pull out an x, I'm going to have a y and then no variable. Here, if I pull out a y, I'm going to have a y and then no variable. So that looks like that part works out. So I would go with that first. Again, sometimes it doesn't work out. Sometimes you have to change things around. And sometimes you get something that's prime and you can't factor it. But from this one, I could pull out a 2x. And inside you would have just y left and then minus this guy right here. If I pull out a 2x, I'm basically going to have a 7. Then from this guy, if I pull out a y, I'm going to have y minus 7 like this. Again, I have my common binomial factor, so this and this. And so what's going to happen here, I'm going to pull this out in front of some parentheses. So y minus 7 like this. And this is going to be left. So inside these, I'm going to have 2x and then plus. This is left here, so 2x plus y. So I'm looking for y minus 7, this quantity, times the quantity 2x plus y. So this guy right there. All right, let's look at question 3. So again, factor each using the grouping method. So we have 80ac minus 15bf, then plus 30af, and then minus 40bc. All right, so before I do anything, I want you to notice here that you have 80, you have 15, you have 30, and you have 40. So everything here is divisible by 5, so you want to pull that out first. If you make a mistake and don't pull this out first, you can fix it in the end. You're just going to have additional factoring. So always check your binomials to see if there's a common factor other than 1, because sometimes you miss it and then you can catch it in the end and save your answer. So I'm going to pull out the 5 here first. That's going to give me 16ac minus, this would be 3bf, plus this would be 6af, then minus this would be 8bc. Okay, so now I'm looking at the inside. Don't worry about the 5. We're just going to keep copying that. That's basically a given at this point. Now, is there any way to make it work with the first two as a group and the last two as a group? When you're in an algebra class, the way they give you these problems is you just have to work out the variables, and so the rest will take care of itself, okay? Now, if you're making a problem up on your own, it's not going to be like that, but the way these test banks are written, this is how it works. So in other words, if I put these two together and these two together, I want you to notice that you have AC and AF. So if I pull out an A, you have C and you have F. This one you have B, F, and BC. You pull out a B, you have F and C. Now you would have C and F, and here you would have F and C. So you need to switch the order around yet again. So I'm going to copy the 5, and then I'm going to put 16AC, and I'm going to put plus 6AF. I'm going to flip this order around. So I'm going to put minus 8BC, and then minus 3BF. And again, the reason I'm doing that is because in this one, I'm going to have C and F. In this one, I want to have C and F as well. Okay, you can do it in a different order, but you're going to have to change it around. And I think that's a little bit more work. Let's put equals, and let's come over here and say we have this 5. And then from this first group, looks like I can pull out a common factor of 2. And then also I have the A. And what will be inside here, 16 divided by 2 is 8. And then if we have AC over A, that's just going to be C. And then plus, if I do 6 divided by 2, that's 3. And then AF divided by A is just going to be F. Okay, so from this second group, it looks like I want to pull out a negative here, right? Both have a negative, and this sign in here, everything is positive. So I want to pull out a negative, and I also want to pull out a B. Okay, so I want to pull that out. And then inside, basically I'm just pulling out the B in each case. So I'm just going to have the 8C, and then everything's positive, and then I'm going to have 3F. Okay, let me close this down. So what you see here is you have this common binomial factor. So the 8C plus 3F and the 8C plus 3F. So So let's go through here, and I'm going to say I have 5. Just keep copying that. This is getting factored out. So you have this 8c plus 3f. Okay, so that gets pulled out in front of some parentheses. Now, the parentheses here are going to have what? Well, you think about what's left over. You have the 2a, so the 2a, and then minus the b, so minus the b, and that's all it is. So 5 times the quantity 8c plus 3f times the quantity 2a minus b. So we're looking for this answer right here. 5 times the quantity 2a minus b, and then times the quantity 8c plus 3f. Again, I know it's in a different order, but we're multiplying, so both answers are acceptable. All right, let's take a look at our quiz. So for the first question, we want to factor each. So we have p squared minus 5p, and then plus 6. So again, this is the easy case scenario. The leading coefficient here is 1. So we can just set up our two binomials here, and I can put a p here and a p here, and I only have to work out what goes here and what goes here. So give me two integers whose sum is negative 5 and whose product is positive 6. So we know this is negative and this is negative because negative times negative is positive, negative plus negative is negative. So basically what I want here is a negative 2 and a negative 3, right? Negative 2 plus negative 3 is negative 5. Negative 2 times negative 3 is positive 6. So I'm looking for this answer right here. The quantity p minus 3 times the quantity p minus 2. Again, the order does not matter when you multiply, so both of these answers are acceptable. All right, let's look at question 2. Again, we're asked to factor each, and we have a squared plus a minus 12. And again, I'm just going to set this up. We know that the first position of each is a. And in terms of the signs, you have this guy as plus, and this guy is minus. So no, one sign is positive and one sign is negative. That's pretty easy. And then just think about the factors of 12. What I want are two factors of 12 such that the sum, if I add them together, is 1, and the product is negative 12. Well, if you go through and you just do some subtraction, so you would do 12 and 1, that would never work. Then you have 2 and 6, that's not going to work. But then you have 3 and 4. If I did positive 4 and negative 3, that would work. So positive 4 and negative 3. So basically you would do 4 minus 3, that gives you 1, and then 4 times negative 3 is negative 12. So I want the quantity a plus 4 times the quantity a minus 3. So I want this answer right here. Okay, let's look at question 3. Again, we're asked to factor each. So we have 4a squared minus 52ab, and then plus 160b squared. Now, some people will sit there and say that you didn't explain to us yet how to factor something out when the leading coefficient is not 1. And we're going to get to that in the next section. But really, you don't even need that technique yet because this is divisible by 4, so is this, and so is this. So you always want to look for additional factoring before you start any problem. So what I would do here is just pull out a 4, and inside I would have a squared, and then minus 52 divided by 4 is 13, and then times ab, and then plus 160 divided by 4 is 40, and then times b squared. Okay, so that's the first problem. The second problem is you have this other variable. Well, I'm just going to tell you in advance, it's not harder if you have a second variable like this. I'm going to write my 4, and I'm going to set up my parentheses here. I know that this is a squared, so this comes from a, and this comes from a. And if you have something like a b squared here, you just put a b here and a b here. Think about it. B times b will give you b squared, so you don't have to think about it. And the outer is ab, the inner is ab, so that's going to combine and give you that ab in the middle there. Okay, so just write it and forget about it. That's all you have to do. At this point, I'm just thinking about two factors of 40 such that the sum is negative 13 and the product is positive 40. Well, again, I know this has to be a negative and a negative because negative plus negative is negative. Negative times negative is positive. Okay, well, let's start thinking about factors of 40. You have 1 and 40. No. You have 2 and 20. No. You have 4 and 10. No. You have 5 and 8. Stop. 5 plus 8 is 13. So negative 5 plus negative 8 is negative 13. So I want a negative 5 here and a negative 8 here. So basically you have 4 times the quantity a minus 5b times the quantity a minus 8b. So you want this answer right here. All right, let's take a look at our quiz. So for the first question, we're asked to factor each. And let's see, we're given 15x squared, then minus 6x, and then minus 48. The first thing you always want to do for this type of problem is pull out any GCF that is not 1. So you have 15, 6, and 48. Forget about the signs. We know we could pull out a 3, right? Everything is divisible by 3 there. So let's just pull that out to start. This would be 5x squared, and then minus 2x, and then minus 16. Okay, so from here, you can use the AC method or you can use reverse FOIL. What I'm going to actually do is use reverse FOIL for the first two, and then for the last one, I'm going to use the AC method. And the reason I'm choosing to do that is, if you have a prime number, right here is the leading coefficient, well, it's generally speaking going to be quicker to use reverse FOIL. Again, I know a lot of students hate reverse FOIL, but I think it's something that you just have to practice at, and it just becomes really, really easy once you do a lot of problems. So I'm going to put a 3 here, and I know, because this is 5, and again, 5 is a prime number, x squared, this is 5x, and this is x. So that's why I use this, because the first two are already given for me, okay? I just need to work out what goes here and here. So what I'm thinking about here are factors of 16. Forget about the fact that's negative. I'm going to play with the signs and make everything work. So I'm just thinking about factors of 16. So I'm going to be doing a subtraction here. So I have 1 and 16. Is it possible for that to work? If I put a 16 here, it's obviously way too big. I'm trying to get a middle term here of negative 2x, so that would never work. 16 here is still way too big, so forget about that. And then next you have 2 and you have 8. Can we make that work? Well, if we put an 8 here, forget about it, it's too big. But if I put an 8 here and a 2 here, can we make that work? Well, my outer here, just think about everything as being positive for a second, is 10x. My inner here is 8x. Could I play with that and get to negative 2x? Yes. If I make this negative, so where this is negative 10x, and I make this positive to where this is positive 8x, that would work out, right? Negative 10x plus 8x would give me the negative 2x in the middle. So let's get rid of this and get rid of this. So looking at it, this is the solution that I want. The 3 times the quantity 5x plus 8 times the quantity x minus 2. Okay, let's look at question 2. Again, we're asked to factor each. We have 7x squared minus 41x and then minus 56. Okay, so looking at this, you have 7, you have 41, forget about the sign, and you have 56. Again, forget about the sign. So 41 is a prime number, so there's really nothing I can pull out from here. So I'm just going to set this up. And again, when you think about this, because this is a prime number here, it's better to use reverse FOIL, in my opinion. If you want to use the AC method, that's fine. It's really up to you. So let's think about factors of 56. Again, forget about the signs for right now. I'm just going to try to make this work. So you have 1 and 56. You're going to have 2 and 28. You're going to have 4 times 14. You're going to have 7 and 8. And that's basically it. So we're just going to play around with this. Now 56, you can't put it here because you'd have a common factor of 7. And remember, if you have a common factor of 7, you should have a common factor of 7 in the original, but you don't have that. So you cannot put a 56 here. You could put a 56 here, but obviously that's too big, so get rid of that. Then you have 2 and 28. You can't put the 28 here because you'd have a common factor of 7, but you could put the 28 here, but again, that's just way too big, so get rid of that. And then you have 4 and 14. Can't put the 14 here, but you can put the 14 here, and you could put the 4 here. Would that work? 7 times 14 is 98, so that's way too big. So this is out. The last possibility is 7 and 8. Now, you cannot put a 7 here, but you could put it here and an 8 here. So this has to work. If it doesn't, it's a prime polynomial. Let's get rid of this. And let's think about if this would work. So this times this would be 49x, and this times this would be 8x. Okay, now we see that we have 49x and 8x. I'm trying to get to negative 41x. So again, you just have to play with your signs. And we know this guy right here is negative. So the larger in terms of absolute value needs to be negative. So this needs to be negative and this needs to be positive. So I want to make this negative and this positive. So I get negative 49x plus 8x to get that negative 41x in the middle. Coming back here, so we want the quantity 7x plus 8 times the quantity x minus 7. So this guy right there. All right, let's take a look at question 3. Again, we want to factor each. So we have negative 32x squared minus 140xy, then minus 48y squared. All right, let's grab this. Okay, for this one, I'm going to use the AC method, and I'm going to start by pulling out everything is divisible by 2, and it looks like everything is also divisible by 4. So I'm actually going to pull out a negative 4. I think that's going to make it easier. And that's going to give me 8x squared, and then plus 35xy, and then plus 12y squared. Okay, so from here, again, I'm going to use the AC method because 8 is not prime. So going through the possibilities, you have to think about things like 8 and 1 or 2 and 4. So it just expands the amount of things you have to check. So it's probably easier just to use the AC method here. So 8 times 12, which would be my AC, is going to be 96. And then my B is going to be 35. So I need two integers such that the sum is 35 and the product is 96. So again, you got to start working through the factors of 96. You've got 1 and 96. No. You've got 2 and 48. No. You've got 3 and 32. Yes. So those are the two integers you want. So let's take this real quick, and we're going to use that to rewrite that middle term. So you have negative 4 times the quantity, 8x squared. I'm just going to expand this. So plus 32xy, and then plus 3xy, and then plus 12y squared. So again, all I did was I took those two integers, the 32 and the 3 that we just found, and I used it to rewrite this middle term. 32xy plus 3xy gives me the 35xy back when I combine like terms. We just write it in this manner so that we can use factoring by grouping. So we have negative 4 times the quantity. And what I'm going to have from this first group, I could pull out an 8x. Inside, I'm going to have x plus 4y. Then plus. From the second group, I can pull out a 3y. And inside, I'm going to have x plus 4y. So you can see that you have this common binomial factor of x plus 4y. We're going to pull that out in front of some parentheses. So let me copy this negative 4. Don't forget about that. Then you're going to have this x plus 4y. And then inside the parentheses here, you have what's left. So you have the 8x, so the 8x plus the 3y, so the 3y. So this would be our answer. So I'm looking for this guy right here, which is negative 4 times the quantity x plus 4y times the quantity 8x plus 3y. All right, let's take a look at our quiz. For the first question, we're asked to factor each. And what we're given is 12x squared minus 60x and then plus 75. We want to see if we can first pull something out. So I noticed that 12, 60, forget about the sign, and 75, each of those, they're going to be divisible by 3. So let's pull that out. I would have 4x squared, and then minus, this would be 20x, and then plus, this would be 25. Now, if you're working this problem and you're not in a special section, you always want to think about a trinomial and think about, was the first guy a perfect square, and is the second guy a perfect square? Well, yeah, I can write 4x squared as 2x being squared like this. The 2 would be squared and the x would be squared, so you'd have 4x squared. And then I'm going to go minus 2 times this first guy here, which is 2x, and then times this last guy, which if I wrote that as a perfect square, it's going to be 5 being squared. So let's put 5 here, and then plus this last guy, which is 5 being squared. So once you see that you can break it down into this way, again, you can just use your formula. So we know we're just going to say this is 3 times. We're going to have the first guy that's squared, so it's this 2x in this case. This sign always comes, so this is minus. And then we're going to take this last guy that's being squared, so the 5, and then this guy is going to be quantity squared. Okay, so this is our answer here. So we want 3 times the quantity 2x minus 5 being squared. So this guy right here. All right, let's look at the second question. Again, we're asked to factor each. So we have this 4x squared minus 9. So I think about this as the difference of squares, because 4x squared can be written as 2x being squared like this, and then minus 9 can be written as 3 being squared like this. So to factor this, take the first guy being squared, so the 2x, and then plus the last guy being squared, the 3. And then you're going to take these same guys here, but you're just going to change the sign. So it's 2x and then minus 3 here. Again, if you went through and reversed this and used FOIL, well, then you know the middle 2 are going to drop out. And so you're left with the first guy squared, so this is 4x squared, minus the last guy squared, so this is minus 9. So this is what we want right here, this quantity 2x plus 3 times the quantity 2x minus 3. All right, let's look at question 3. Again, we're asked to factor each. So here we have x cubed plus 64. So for this one, I'm going to write 64 as 4 cubed. And you see we have the sum of cubes here. So let me actually write the formula out for this one. This one is one that you really need to memorize. So let's just do this as x cubed plus y cubed. I'll give you the formula, and then we can just match things up. So this is x plus y. So remember, this sign right here matches this sign right here. And so it's the first guy that's cubed. So in this case, x is being cubed, so x goes there. And it's the last guy being cubed. So in this case, y is being cubed, so y goes there. Then the second set of parentheses, you're going to have your first guy that's cubed, now it's squared, so x squared. This sign right here is going to flip. So if it's a plus, it turns into a minus. And you're going to multiply these two guys together. So x times y. So these two guys that are being cubed, so x, y. And then the last guy is always plus. And you're going to take this guy, which is being cubed, and you're going to square it. Okay, so that's all it is. And so from here, let me slide this down. We're just going to copy this pattern. Again, this is just pure memorization. So I'm just going to take the first guy that's cubed, and I'm going to write that in. So in this case, it's x. then plus. The last guy that's cubed, in this case, let me make this 4 more clear. This is a 4. So we're going to put a 4 here. In this case, it's y, but in this case, it's 4. Okay. Then over here, we're going to have this first guy that was cubed. That's going to be squared. Then my sign, here it's a plus. So here it's going to be a minus. And then I'm going to multiply these two guys that were cubed together. So x times 4, which is 4x. And then this sign is plus. And then basically you take this last guy that's being cubed and you square it. So 4 squared is 16. So what I'm looking for is the quantity x plus 4 times the quantity x squared minus 4x plus 16. So I want this guy right there. All right, let's take a look at our quiz. For the first question, we're asked to solve each equation by factoring. So what we have is x squared is equal to negative 32 and then plus 12x. Okay, so the first thing you want to do is put this in standard form. So I'm just going to add 32 to both sides of the equation, and I'm going to subtract 12x away from both sides of the equation. So let me put x squared. Again, I'm subtracting 12x away from both sides, and then I'm adding 32 to both sides. And again, if I did that, on the right-hand side, I would now have 0. So it's important to write that. So from here, I would factor the left-hand side. So let me put this as an x here and an x here, just so I have more room. And then I'm thinking about two integers whose sum is negative 12 and whose product is positive 32. So I'm going to think about 8 and 4. But what I'd want here is a negative 8 and a negative 4, because again, I need a negative times a negative to give me a positive, and a negative plus a negative gives me a negative. So this is what I'm looking for. And from here, I'm going to take each factor with a variable and set it equal to 0, and I'm going to solve the resulting equation. So I'm going to take x minus 8, set that equal to 0, and then I'm going to set x minus 4 equal to 0. So basically, I would add 8 to both sides over here. This would cancel. You get x is equal to 8. So that's one solution. And then over here, I'm going to add 4 to both sides of the equation. This cancels. So you get x is equal to 4. So that's another solution. So there's a lot of ways to notate this. You can put x equals 8, and then or you could use that keyword, x equals 4. Or mostly people will just put x equals 4, 8. I think we'll just stick with this. So coming up here, we have x equals 8, 4. You could put 4, 8. The order doesn't really matter. Okay, let's look at question 2. So again, we want to solve each equation by factoring. So we're given x squared minus 10x. This is set equal to negative 16. So what I'm going to do here is just add 16 to both sides. So I'd have x squared minus 10x and then plus 16. This would be equal to 0. Again, if I added 16 and negative 16, I would get 0. So you need to make sure you write that. So on the left-hand side, I'm just going to factor this guy. And so this would be x and this would be x. Give me two integers whose sum is negative 10 and whose product is 16. Well, now I'm thinking about 8 and 2. But again, I want a negative 8 and a negative 2, because a negative plus a negative is a negative. The negative times the negative is a positive. So again, I'm just going to set each one of these guys equal to 0 and solve. Again, mostly you can look at this and just eyeball it and see the solution is going to be 2 and 8. But let's just do it all the way for completeness. So x minus 8 equals 0, and then or x minus 2 equals 0. So add 8 to both sides over here, add 2 to both sides over here. You get x is equal to 8. Then or you get x is equal to 2. So again, you could write this x equals 2, 8 like this. So again, x equals 2, 8. Okay, let's look at question 3. Again, we want to solve each equation by factoring. So negative 12 plus 29x is equal to negative 5x squared minus 6. Okay, so what I'm going to do here is let's pick a side. I'm just going to move everything to the left. So let's add 5x squared to both sides. So this would be 5x squared. I'm going to have my plus 29x. I'm going to add 6 to both sides. So basically on the right-hand side, this is 0. If I do negative 12 plus 6, that's going to be negative 6. So let's go ahead and put this, and you can tighten this down a little bit if you want. Again, if you need to pause the video and go through that more slowly, that's really up to you. But I think we got it from here. This is just something we need to factor. And I'm going to use reverse FOIL. So I'm going to use reverse FOIL here because this 5 here is a prime number. So I know that this would be 5x and this would be x. And then I think about the factors of 6. Well, I just have 1 and 6 or 2 and 3. So if I put a 6 here and a 1 here, would that work? My outer would be 30 and my inner would be 1. So if I play with the signs, I would want this to be positive and this to be negative. So that this is 30x minus x, which gives me the 29x. Okay, so let's set this up as 5x minus 1 equals 0. Then or we're going to go x plus 6 equals 0. This one's easy to solve. Let's subtract 6 away from each side. We get x equals negative 6. For this one, we have to do a little bit more work. Add 1 to each side. This cancels. You get 5x is equal to 1. Divide both sides by 5. You're going to get x is equal to 1/5. So again, you could put x is equal to 1/5 or, I'll put the or here, x is equal to -6. And then you could also write this. Again, you could just say x is equal to -6 comma 1/5. So let's come up here. So x is equal to 1/5 comma -6. All right, let's take a look at our quiz. We're told for question 1 to state the restricted values for each and also to simplify each. So recall, if you work with a rational expression, you always want to find your restricted values first, and then you want to simplify. Those restricted values will always carry over to any simplified rational expression. So let's say we have something like 6 over this 9x plus 9. So the idea to find the restricted values, you want to take your denominator and set it equal to 0 and solve the resulting equation. Remember, we're concerned with division by 0. So if I say 9x plus 9 equals 0, if I solve this real quick, let me slide down, I'll come back up. So this guy right here, I would subtract 9 away from each side of the equation. Let's cancel this. We're going to have 9x is equal to -9. Let's divide both sides of the equation by 9. And let's cancel this with this and get x is equal to -1. Let me erase this. And let's think about what x equals -1 means. It means that if I plug in a -1 here for x, then my denominator is going to be 0, right? 9 times -1 is -9, and -9 plus 9 is 0. 6 over 0 is undefined. So that means we need to restrict this value of -1 from the domain. So there's a lot of ways to show this. I'm just going to use some set builder notation. So I'm just going to say the set of all x such that x does not equal -1. Again, there's a lot of ways to write this. We're just listing this in our answer just by saying it's -1, but you could use this, you could write it out, you could put a comma and then x is not equal to -1. Again, whatever you want to do. So for the simplified version, all you need to do is factor the numerator and denominator completely. So in other words, for 6, I could just write that as, let's say 3 times 2. And then for this, 9x plus 9, let's go ahead and factor out a 9. So that would be 9 times the quantity x plus 1. And then from 9, I'm going to break that down into 3 times 3. And then what I'm going to do from here is cancel this with this, right? One common factor of 3 is canceled. And what you're left with, we can just erase this and leave this in line. We'll say that this is 2 over 3 times the quantity x plus 1. Of course, you could distribute the 3 in if you want, but most teachers prefer it to look this way in factored form. And so this would be my answer right here. The restricted value is that x cannot be -1, and the simplified version is 2 over 3 times the quantity x plus 1. So this is what we want right here. Okay, let's look at the second question. Again, we're asked to state the restricted values for each. We're also asked to simplify each. And it looks like we have 10x squared minus 30x. This is going to be over. We have 25x squared minus 5x. So for the restricted values, again, I'm just going to take my denominator, which is 25x squared minus 5x. I'm going to set it equal to 0, and I'm going to solve the resulting equation. Now, this is something we can solve using factoring. Let me slide down here real quick. You can see that you could factor out a 5x. So you would have 5x multiplied by the quantity. This would be 5x minus 1 like this, and this equals 0. So all we're going to do is set each factor here equal to 0 and solve. We already know how to do that. So in other words, 5x equals 0 or 5x minus 1 equals 0. Just going to solve these really simple equations real quick. Divide both sides here by 5. This cancels. You get x equals 0, right? 0 divided by 5 is 0. Then or, if I add 1 to both sides of the equation here, this cancels. You're going to have 5x is equal to 1. Divide both sides of the equation by 5. This cancels. You get x is equal to 1/5. So these are the two values that you cannot plug in for x in that rational expression because the denominator will be 0 and division by 0 is undefined. So we need to restrict these two. So let's say the set of all x such that x does not equal 0 or 1/5. Again, lots of ways to write this. It's really up to you. So I'm just going to put a comma and list this off to the side. And what I'm going to do now is just factor this numerator and denominator completely, and then I'll cancel any common factors. So we already know that this would factor into 5x times the quantity 5x minus 1. So let's just replace this and drag this up here like this. And then from here in the numerator, it looks like I can factor out a 10x. So this would be 10x times the quantity x minus 3 like this. So let's get rid of this and put up here 10x times the quantity x minus 3 like that. Get rid of this. And then again, you could further break this down. You could make this a 5 and then this a 2, so 2 times 5. And then of course I can cancel a common factor of 5 and a common factor of x. So what I'm left with here is 2 multiplied by the quantity x minus 3 over just this 5x minus 1 like this. Now I want to call your attention to something, and this causes a lot of confusion, so I want to make sure it's crystal clear. These restrictions here carry over to this simplified rational expression because in the original rational expression, we could not plug in a 0 for x. Even though in the simplified version, it doesn't really result in a denominator of 0. It has to be carried over because it was restricted in the original rational expression. Okay, let's look through our choices here. It looks like we're going to want this one. The restricted values, we're going to have 0 and 1/5. And then for the simplified version, we have 2 times the quantity x minus 3. And then over, we have this 5x minus 1. So we want this answer right here. Okay, let's look at question number 3. So it looks like we want to state the restricted values for each, and also to simplify each, we're going to have 2x plus 6 over. We're going to have 21x cubed, then plus 33x squared, then minus 90x. Okay, so from the denominator, we have this 21x cubed plus 33x squared minus 90x. I'm going to set that equal to 0 and solve. This is something where you're going to be able to factor it because I haven't taught you how to do it otherwise. So if I look at 21, 33, and 90, I know I can pull out a 3. And I also know I can pull out an x. So let's do that, and we'd have 7x squared. And then we would have plus 11x. And then we would have minus 30 like this. So let's set this equal to 0. We need to factor this guy. So let me put this down here as 3x here. And then I'm going to set this up like this. And I'm going to use reverse FOIL here because I have a prime number here in the leading position. Again, if you want to pause the video and use the AC method, that's really up to you. I know a lot of students like that better. So I'm going to put a 7x here and an x here. Okay, so I just have to think about the factors of this 30 guy. Forget about the signs, just think about 30, such that I'm going to get this correct middle term here of 11x. So 30, you could use 1 and 30, but there's no way that's going to work. It's just too far away. You could do 2 and 15. A 15 here is too big. A 15 here and a 2 here, well, you would end up with 14x and 15x. That's not going to work. So let's work our way up to 3 and 10. So you could put a 10 here, but that's too big, or a 10 here and a 3 here. Looks like we found something that would work. So this times this would be 21x, and this times this would be 10x. Okay, well, what I want to do is keep this one as positive, so I'm going to put this as a plus here. And I want this one to be negative, so I'm going to put a minus here, right? 21x minus 10x is going to give me that plus 11x there in the middle. So this is what I'm looking for here. And now it's pretty easy. I'm just going to set each factor equal to 0 and solve the resulting equation. So we're going to have 3x equals 0, or you can have 7x minus 10 equals 0, or you can have x plus 3 equals 0. But basically, I'm just going to divide both sides of the equation by 3. This cancels. You get x equals 0. Then over here, let's add 10 to both sides of the equation. This cancels. You get 7x is equal to 10. Divide both sides of the equation by 7, and you get x is equal to 10 sevenths. So let me actually just drag this down here so it's in line. So x equals 0, or x equals 10 sevenths. And then over here, let's subtract 3 away from each side of the equation. That cancels. Let me put or x equals negative 3. So these values here, 0, 10 sevenths, or negative 3, those guys will all make the denominator 0. And so again, you can't divide by 0. And so those values have to be restricted from the domain. So let's do it like this. I'm just going to say the set of all x such that x does not equal, let's put negative 3, and then 0, and then 10 sevenths. And again, you can put this in any order. I'm just going in the order of the number line, but you could rearrange that however you want. Okay, so I'm actually going to replace this denominator with this guy right here and drag this up there. And I obviously need to make this a lot bigger. So I'll actually just erase this all together, make a really big fraction bar there. This is going to be my domain. I'm going to just leave this like this and maybe put a comma here. And for 2x plus 6, I know I can factor a 2 out and put 2 times the quantity x plus 3. So the idea here is that I can cancel this common factor of x plus 3. You have it here and you have it here. So I'm going to cancel that out. So that's going to be gone. And so the simplified version here, let me just erase this from here. It's 2 over, you have 3x times the quantity 7x minus 10. And again, you still have to restrict this negative 3 from the domain. Although it doesn't do anything in the simplified version to violate the rules, you have to restrict it because it was a restricted value in the original rational expression, so that always carries over. All right, so looking through our choices here, we see that we have restricted values of 0, 10/7, and -3, and then a simplified version of 2 over 3x times the quantity 7x minus 10. So this is the answer we're looking for right there. All right, let's take a look at our quiz. For the first question, we're asked to find each product. And what we have here is 13x squared over 4x to the 5th power. We're multiplying this by, we have 16x over 6x. So just like if we were multiplying two fractions together, we want to simplify each fraction completely, and then we want to see if we can cross cancel anything before we multiply. So basically I can cancel this out and put this as a 3 down here, and then nothing else I can really do there. From this one, I can cancel this x with this x, and then 16 and 6, they're both divisible by 2. Divide this by 2, you get 8. Divide 6 by 2, you get 3. So now that I've done that, can we cross cancel anything? Well, yeah, we can. If I look between 8 and 4, I can divide 8 by 4 and get 2. So this would be 2, and this would be canceled. So basically now I just multiply what I have left. For the numerators, I have 13 here and 2 here. 13 times 2 is 26. Nothing else up there. Then down here, I have x cubed. And let me make this better. I think that's not legible. So this is x cubed times, and this is a 3. So to make that more clear. So x cubed times 3 would be 3x cubed. Now, nothing else I can do because there's no common factors other than 1 between the numerator and denominator. So we just basically have 26 over 3x cubed. So this answer right here. Okay, let's look at the second question. So we're asked to find each quotient. And we're going to have 5 over, looks like x squared, plus 10x plus 25. And let me make that a little bit better. This is divided by, we have 1 over x plus 5. All right, so the idea here with the division problem, we're going to write this as this first guy, so 5 over, might as well factor this now, because we're going to need to do it in a minute. So basically, this is an x and this is an x. Two integers that sum to 10 and give me a product of 25. Well, it's going to be 5 and 5, so this is a perfect square trinomial. So you could put plus 5 and then plus 5. You could put x plus 5 quantity squared, but I think that's probably not what we want to do here because it seems like we're going to cancel something here. So let's just leave it like this. So because this is a division problem, you want to write this as multiplication by the reciprocal. So this guy from the denominator comes to the numerator. This guy from the numerator goes in the denominator. Of course, if you write something over 1, you could just leave it off if you want, but I'm just going to put it there for completeness. And basically, I'm just going to cancel this with this. So now this is a big fat 1. And what I'm left with is just 5 over x plus 5. So that's my answer. So this guy right here, 5 over x plus 5. Okay, let's look at the third question. And this one seems like it's a lot involved. So we have 24x cubed plus 40x squared, and that's all for there. Then over, we have 8x cubed minus 80x squared. Then we're multiplying by, looks like we have 7x squared minus 24x plus 9. This will be over 21x squared plus 26x minus 15. Okay, so the idea here is you just want to factor everything. I think that's the trickiest part of this. From the top guy here, you know you could pull out an x squared. And then number-wise, I think I can pull out an 8, right? Because 24 divided by 8 is 3. 40 divided by 8 is 5. Nothing else you could really pull out there. So let's say, again, this would be 3x, and then plus this would be 5. Okay, down here, I know I could pull out an 8x squared. So 8x squared. And then we're going to have what? We're going to have x, and then minus, this is going to be 10. Okay, so times, over here, this is going to factor into the product of two binomials. So again, because this guy here is prime, this 7, I'm just going to use a reverse FOIL. If you need to pause the video again and use the AC method, feel free to do that. So I'm going to put a 7x here and an x here. 9 can only come, I know that there's positives and negatives involved, but 9 can only come in terms of positive factors from 1 times 9 or 3 times 3. So again, I always do positives and then I work out the signs later. If I put a 9 here, that's way too big. If I put a 3 here, then this is going to be 21x. And then if I put a 3 here, this is going to be 3x. It looks like if I did 21x plus 3x, that's going to give me 24x. I want a negative 24x, so I want this to be negative and this to be negative. So that way it works out because your outer and your inner would give me the negative 24x. And the last, negative 3 times negative 3 is positive 9. So we're good to go there. All right, now for this one, let me write this out here. I think we need to take some time on this. So 21x squared plus 26x minus 15. Now, you could use the AC method on this. There's nothing you could pull out. I think the numbers are just too big. I'm going to just use reverse FOIL here. I think that would probably be easier for me. Now for 21, it could be 1 and 21, but that's unlikely to work. So I would just skip that and say it's probably going to be 7 and 3. So I'm going to put 7x and 3x here. And then when you think about 15, again, forget about the fact that it's negative. It has so few factors that I think reverse FOIL is the best game here because you only have 1 and 15 or 5 and 3. So if I put a 5 here and a 3 here, this is going to be 35 and this is going to be 9. Now 35 minus 9 is 26. So I need to make sure this is negative and this is positive. So let's get rid of this and get rid of this. That way the outer is 35x, the inner is minus 9x, and then those combine to give me the plus 26x. And then the negative 3 times the positive 5 gives me the negative 15. So this is what we're looking for here. Okay, so now that we have everything factored, it's just a matter of going through and canceling things. So this will cancel with this. 8x squared over 8x squared is 1. That's gone. Then you're going to have this canceling with this. So the quantity 7x minus 3, that's gone. And then it looks like this would cancel with this. So you have that quantity 3x plus 5, so that's gone. So what's left? You basically just have this x minus 3 over x minus 10. So coming back up here, I want this x minus 3 over this x minus 10. All right, let's take a look at our quiz. For the first question, we're asked to find the LCD, which stands for least common denominator, for each group of rational expressions. So we'll have 2 over 35 and then x cubed. And then we're going to have 2 over, we have 49 and then x to the 5th power. All right, so the process for this is fairly straightforward. Let me make this 3 a little bit better. I'm going to work with the number part and the variable part separately. So recall that you need to find the LCM or least common multiple of these denominators to find the LCD or least common denominator. So I'm just going to say, what is the LCM of 35x cubed and 49x to the 5th power? Again, what you're going to do to find this is just factor each denominator. Forget about the variable parts. I'm just going to factor 35. This is 7 times 5. I'm going to factor 49. This is 7 squared. Okay, so when you build your LCM, basically for the number parts, you're going to think about each prime factor raised to its highest exponential power among these factorizations, or you could say the largest number of repeats among the prime factorizations. Okay, so here I have 7, but I just have 7 to the 1st power, and here I have 7 squared. So go with the highest power on 7, and it's a 2, so I just want 7 squared or 49. The common mistake is to put 3 copies of 7 in when you do this. Some people put 7 cubed in there. That's not what you want to do. Always go with the highest number of repeats or the highest exponential power on that prime factor. Okay, then we have 5 here, and this doesn't look so good, so let's rewrite that. You're just going to put that in there. So what is 49 times 5? Well, if you punch that into your calculator, you're going to get 245. So let's write that as the number part. Okay, so the variable part is really easy. You have an x cubed here and an x to the 5th power here. So in each case you have this x, you just go with the highest exponential power, and that's going to be the 5. So it's just x to the 5th power there. So the least common multiple for these two denominators, the 35x cubed and the 49x to the 5th power, is 245x to the 5th power. And so this is our LCD, or least common denominator. So let's go back up, and we want this answer right here, this 245x to the 5th power. All right, let's look at the second question. Again, we're asked to find the LCD, or least common denominator, for each group of rational expressions. And we have 7 over, this will be 5x minus 10. And then here we have 11 over, we have 6x minus 12. All right, so the basic idea here is the same, although the setup for this one is slightly more challenging. You're finding the LCM of these two denominators. And to do that, you would factor the denominators. So this would be 5 times the quantity x minus 2. And this right here would be 6 times the quantity x minus 2. So again, you think about this in the same way. If I wanted the least common multiple of these two denominators, then basically all I would do is I would say, okay, so each factor here, the 5 needs to go in, the 6 needs to go in, and then the x minus 2 needs to go in. So your LCD, you could write LCM if you want. I'm just going to put LCD here. So LCD is going to be the 5 goes in, the 6 goes in, and then this x minus 2 goes in. Again, because this is here and it's also here, it's a duplicate. So you always go with the highest power on that. It's just raised to the first power, or you can say you have one copy of it. So 5 times 6 is 30. Let's just replace that. And then times this quantity x minus 2. So going back up, I want this 30 times the quantity x minus 2. Okay, let's look at question 3. Again, we're asked to find the LCD, or least common denominator, for each group of rational expressions. So we have this 5 over x squared plus 8x plus 15. And then we have 3 over, we have x squared minus 3x minus 18. And then lastly, we have 2 over x squared minus x minus 30. Okay, so a lot of factoring that we need to do here. Let me try to squeeze this over here. I think I can make it fit. That way we can factor things in line. So this guy right here is pretty easy to factor. We want an x here and an x here. I need two integers whose sum is 8 and whose product is 15. That's pretty easy. That's going to be 5 and 3. Okay, so for this one, I want two integers, let me put a comma here, whose sum is going to be negative 3 and whose product is negative 18. So let me put an x here and an x here. Let's see, so a sum of negative 3 and a product of negative 18, I would want negative 6 and positive 3. So negative 6 and positive 3. And then lastly, I don't know if we can even fit this, so let me put it down here. So this one, we have two integers whose sum is negative 1 and whose product is negative 30. So that's negative 6 and positive 5. Okay, let me close this down a little bit. Now, just go through this, and again, you can scroll off this. We don't need this information on the top anymore. To find the least common multiple of these denominators, or again, to obtain the LCD, or least common denominator, let me just put LCD here. Let me take each factor here that occurs in the factorizations, again, raised to the highest power, or the largest number of repeats. So in this case, I have x plus 5, and I see it again here. But again, it only occurs once here and once here. So when I build this, I only want to put one copy in. Don't put two. So it's here and here, only occurs once in each. Then I have x plus 3 here and here, only occurs once in each, so just throw it in once. That's all you have to do. Then I have x minus 6 here and here. Again, just put it in once. So this right here would be your LCD. So coming back here, we want the quantity x plus 5 times the quantity x plus 3 times the quantity x minus 6. So it's in a different order, but again, that doesn't matter because it's multiplication. So this is what we want right here for our answer. All right, let's take a look at our quiz. For the first question, we're asked to perform each indicated operation. So it looks like we have v plus 2 over 2v plus 8. Then we're subtracting away. We have 4v over 3v. Okay, so the first thing I would do is try to simplify the fractions first before I get a common denominator. If you notice you have a v here and a v here, you can just get rid of that. You don't need it. This is basically 4/3 now. And then over here, I can factor this actually to 2 times the quantity v plus 4 like this. Let's get rid of this, and let's put this like this. Okay, I'm actually going to delete this v from here and here. And so how can I get a common denominator? Well, again, we just talked about how to find the LCD. Basically, in this case, these denominators don't have anything in common, so it's just the product of the denominators. Let me actually slide this down. So what I'm going to do over here is multiply this by 3 over 3. And over here, I'm going to multiply this by 2 times the quantity v plus 4 over 2 times the quantity v plus 4. So all I really need to do is think about the numerators. So remember, put parentheses here so you don't make a silly mistake. This is going to be 3 times the quantity v plus 2. And then we are subtracting away this whole thing. So I'm going to use brackets. You can use parentheses, whatever you want to do. But just make sure you enclose this inside of brackets or parentheses so that you don't make a sign mistake. You just subtract away the whole thing. Okay, so this is 4 times 2. I'm just going to write that as 8. Then times the quantity v plus 4 like this. Close down the brackets. Okay, then this is over. I'm just going to write this as one common denominator. You have 3 times 2, which is 6, times the quantity v plus 4. Okay, so let's see where this leads us to. Essentially on the left, 3 times v is 3v, and then plus 3 times 2 is 6. And then let me distribute this first, and then I'm going to subtract everything away. So you'd have 8v there, and then plus 32. And then again, I have this minus out in front of these brackets because I'm subtracting everything away. So this becomes a minus, and this becomes a minus. And now I can just put this over my common denominator of 6 times the quantity v plus 4. And to finish things up, I could just combine like terms. So 3v minus 8v would be negative 5v. And then 6 minus 32 would be negative 26. This is over 6 times the quantity v plus 4. I can't really factor this or do anything else. I could pull out a -1 if I wanted to, but really this is as good as I can do. So I'm looking for this answer right here, -5v minus 26. This will be over 6 times the quantity v plus 4. So this is what I want right here. All right, let's look at the second question. We're asked to perform each indicated operation. Looks like we have 8v over. We have 7v plus 8. We are adding to this. It looks like v minus 5. And then this is over. We have v plus 8. For the LCD, 7v plus 8 is not going to factor, and v plus 8 is not going to factor. So again, it's just the product of the two denominators. So I'd multiply here by 7v plus 8, and then over 7v plus 8. Let me actually slide this down so I can fit it all in one line. And then over here, I'm going to multiply by v plus 8 over v plus 8. Now, because you are multiplying quantities here, you want to wrap things in parentheses so you don't make sign mistakes. So I'm just going to wrap these guys. This one doesn't need to be wrapped, but you're going to wrap this guy and this guy and this guy and this guy. Okay, so it's very important to do that. All right, so down here, I'm going to have 8v times the quantity v plus 8. And I think this is kind of looking like a u, so let me make sure I make that clear. And then plus, you're going to have this quantity v minus 5 times the quantity 7v plus 8. So we'll have to FOIL that out. This will be over the common denominator, which is the quantity v plus 8 times the quantity 7v plus 8. I would leave this guy right here in factored form and just work on the numerator. So 8v times v is 8v squared. Then plus 8v times 8 is 64v. Then plus, we're going to have to use FOIL here. So v times 7v is 7v squared. The outer v times 8 is plus 8v. And again, this looks like a u, so let me make this into a v. Let me slide this down a little bit. The inside, -5 times 7v, would be -35v. And then the last, -5 times 8, would be -40. This is all over this quantity v plus 8 times the quantity 7v plus 8. Okay, so combining like terms in the numerator, you see that you have 8 plus 7. Both of those are going to be v squared. I know this kind of looks like a u. Let me try to make this better so that nobody's confused. But you basically have 8v squared plus 7v squared. That's 15v squared. So let's put 15v squared. Then you have 64v plus 8v, then minus 35v. 64 plus 8 is 72. Subtract away 35, you're going to get 37. So this is plus 37v. And then lastly, you're going to have minus 40. So this will be over. You have the quantity v plus 8 times the quantity 7v plus 8. Now here's where things get pretty tedious because you are expected to try to factor this and cancel any common factors. I'm just going to tell you in advance that you will not be able to factor this guy. It's going to be prime. So we're looking for this answer right here. The 15v squared plus 37v minus 40. This is over the quantity v plus 8 times the quantity 7v plus 8 like this. So that's our answer. Okay, let's look at question 3. So again, we're asked to perform each indicated operation. So we're going to have x minus 3 over, we have 2x plus 4, then plus, we have x minus 8. This is over, we have x plus 3. And I could factor this into 2 times the quantity x plus 2. So 2 times the quantity x plus 2. But again, the denominators do not have anything in common. So for the LCD, it's just going to be the product of the two denominators. So I'm going to multiply this by this x plus 3 over x plus 3 like this. Let me wrap this. Let me wrap this and wrap this. This will get multiplied by 2 times the quantity x plus 2, and then 2 times the quantity x plus 2. Okay, so let's set this equal to, we have to do FOIL here, and then this right here, we know we're multiplying conjugates. So basically, the first guy squared, so x squared, then minus the last guy squared, so 9. We know the middle two terms would drop out there. Then plus, I have this 2 that's going to multiply the result of this. So I'm going to put the result of foiling this in some parentheses. So x times x is x squared. The outer would be x times 2, that's plus 2x. The inner would be negative 8 times x, that's minus 8x. You can combine that and say that's negative 6x. And then the last, negative 8 times positive 2 would be negative 16. So you would basically distribute the 2 inside to each term. So this would be 2x squared minus 12x, and then minus 32. So let's go ahead and do that like that. Let me slide that down and make that a little bit better. And then you could combine like terms here. So 2x squared plus x squared would be 3x squared. So let's actually get rid of that and put this as a 3. And let me make that 3 more legible. And then for negative 12x, there's nothing combined with that. If you do negative 9 minus 32, that's going to be negative 41. So let's write this as minus 41 like this. Let's scooch this down here like this. It'll be over. My denominator here is going to be 2 times the quantity x plus 2 times the quantity x plus 3. So again, you need to try to factor this. I'll let you pause the video and do it on your own. I'm just going to tell you in advance it's going to be a prime polynomial. So there's nothing else you can do to factor this. So this is as simple as we can make it. So I'm looking for this guy right here, this 3x squared minus 12x minus 41 over 2 times the quantity x plus 3 times the quantity x plus 2. All right, let's take a look at our quiz. So for the first question, we're asked to simplify each. Looks like we're going to have 9 over u squared. And then we are subtracting away 1 over u. So this is going to be over. Let's say we have 9 over u being squared. So in my personal opinion, the fastest way to solve this is to find the least common denominator of all the denominators. So we have u squared, we have u, and we have u squared. So the LCD there is just going to be u squared. So I'm going to multiply the numerator of the complex fraction by u squared and the denominator of the complex fraction by u squared. So again, this has to be distributed to each term here. So what that's going to give me is, let me write this out the long way so nobody gets lost. So 9 over u squared times u squared, then minus 1 over u times u squared. So let's go through and simplify this. This would cancel with this, and this, one of these would cancel with this. So essentially my numerator here, I'm just going to have to go back and forth. This is not all going to fit on the screen. My numerator here is going to be 9, and then minus, basically this would be u. Okay, this will be over, and we'll put this over here, and let me put equals here, and let me slide back up. So now this u squared is going to multiply by this. So down here, let me put 9 over u squared, then times u squared like this. And let me slide this off the screen so I can move some things down, so we get a little bit of room. I'm going to get this out of here, and let me get rid of this and make this better. Let me make this u squared here better. And so now I can just cancel this with this. And so this denominator here would just be 9. So basically, after all that work, let me make this fraction bar a little bit better. We get 9 minus u over 9. So coming back up here, I want 9 minus u over 9. That guy right there. Okay, let's look at question 2. So we're going to have to take our time and write this out. Let's see. We have x squared over y, and then minus 5 over x minus 1, and then over. Looks like we have y over x minus 1, and then minus x over x minus 1. Okay, so the LCD, you have this denominator, and this denominator. Those are all x minus 1. And then you have a y. So basically it's y times the quantity x minus 1. So I'm just going to multiply the numerator and denominator by that LCD. So just like this. And I'm just going to tell you in advance, it's going to be really hard to fit this on the screen. So we're just going to have to do some of this mentally. And you can pause the video as much as you need to and just write things out. But essentially, this guy right here is going to multiply by this and then by this. So if this gets multiplied by this, the y's are going to cancel. And you're going to have x squared times the quantity x minus 1. And then minus. If this is multiplied by this, the x minus 1's are going to cancel. And you basically just have 5 times y. So then this is over. In my denominator, if this gets multiplied by this, the x minus 1 is going to cancel. Y times y is y squared. Then minus this times this, the x minus 1's are going to cancel. You'll have x, y. Okay, let me slide down here a little bit. And let's think about, could you factor anything out before you start? Well, I could factor out a y from this denominator here, but it's not really going to do me that much good. But let's just do it anyway. So y times the quantity y minus x like this. And let's bring this out like this and drag this up. Again, it's not going to do anything because you don't have a common factor up here to cancel it with. But up here in the numerator, I'll just simplify and say x squared times x is x cubed, and then minus x squared times 1 is x squared, and then minus 5y, and this will be over. Y times the quantity y minus x, and looking back through the answers, looks like I picked it the other way. So you have x cubed minus x squared minus 5y, and this would be over y squared, again, y times y is y squared, minus yx or xy, however you want to read that. So this is the answer we want right there. Okay, let's look at question 3. So again, we're asked to simplify each. We have a squared over, we have a plus 2, and then this is going to be over. Looks like we have a plus 2 over 9, and then plus a plus 2 over 3. Okay, looking at the denominators here, you have a plus 2, you have 9, and you have 3. Now, 9 is 3 times 3. So really, I just go with 9 times the quantity a plus 2. So I put equals here, and really what I should have done is put times. I'm going to go 9 times the quantity a plus 2 over 9 times the quantity a plus 2 like this. And now let me put my equals. And essentially, if this gets multiplied by this, the a plus 2's are going to cancel. And you're going to have 9 times a squared. Then this will be over. Down here, the 9 will cancel with the 9. And you have the quantity a plus 2 being squared. Then plus here, 9 divided by 3 is 3. So 3 times the quantity a plus 2 squared. Okay, so can we do anything to simplify this? I could factor out the a plus 2 quantity squared. So what I could do is write 9a squared like this. And then over, I would have a plus 2 quantity squared. If I'm pulling that out from here and here, what's left? Where you're going to have 1 plus 3, which is basically just going to be 4. So let's put a 4 out in front. And again, there's nothing really that you can do there to make that any simpler. I don't remember how I answered this, but this might be expanded. So let's take a look at it. So we're looking for 9a squared. And then in the denominator, it looks like this is expanded. So you have 4a squared plus 16a plus 16. So if we took this guy and we said 4 times, again, this would be a squared plus 2 times a times 2, so 4a. Then plus your 2 squared is 4. So 4a, let me erase this and put 4a squared, and then plus 16a, and then plus 16 like this. That's basically what you have here. It's just the non-factored version. So 9a squared over 4a squared plus 16a plus 16. This is what we want right there. Okay, let's look at our quiz. For the first question here, we're asked to solve each equation. We have 1 over x, then plus we have 1 over x squared. This is set equal to, we have 6x minus 6. I'm going to write 6 times the quantity x minus 1. And then this is over x squared. Okay, so to clear all the denominators, you would multiply everything by x squared. And so let me do this so that nobody gets lost. So this is multiplied by x squared, and let me slide this down. And this is multiplied by x squared, and this is multiplied by x squared. Let me make this multiplication symbol a little bit better. And so this is going to cancel, and this is going to cancel, and this would cancel with this. So essentially what I have is x times 1, which is just x, and then plus, this was canceled away, so it's just 1. And I'll say this is equal to, here I'm going to need to distribute this, so this will be 6x minus 6. All right, so let's subtract 1 away from each side of the equation. That's gone. Let's subtract 6x away from both sides of the equation. That's gone. Let me slide down here and see what we have. So it looks like we'll have negative 5x is equal to negative 6 minus 1 would be negative 7. Let's divide both sides of the equation by negative 5. This cancels. We get x is equal to 7 fifths. So I'm looking for x equals 7 fifths. All right, let's look at question 2. Again, we're asked to solve each equation, and we have 5a minus 25. This is over 4a. This equals 3 halves plus a plus 3 over a. Okay, so looking at the denominators, you have 4a, you have 2, and you have a. So we know that 4 is 2 times 2, so basically 2 squared. So we would use 4 times a as the LCD. So I'm going to multiply everything by 4a. Again, let me just slide this down a little bit. And let me put this equals over here. Multiply this by 4a. Multiply this by 4a. Okay, so we know that this will cancel with this. We know that this 4 will cancel with this 2 and give me a 2. And then this a will cancel with this a. So what does that leave me with? On the left-hand side, I have 5a minus 25. This is equal to, on the right-hand side, we have 2a times 3, which is going to be 6a. And then plus, you have 4 times the quantity. So this is really important. This is multiplied by the quantity. So this would be 4 times the quantity a plus 3. So make sure you wrap that in parentheses so you don't make a silly mistake. 5a minus 25 is equal to, this is 6a plus, this will be 4a plus 12. And let's see what we have here. So 6a plus 4a is 10a, and then plus 12 like that. Okay, let me subtract 10a away from each side of this equation. So this is going to cancel. Let's add 25 to both sides of the equation. So this is going to cancel. 5a minus 10a is negative 5a. This equals 12 plus 25 is 37. Let's divide both sides of the equation by negative 5. And let me make this 5 better. So this cancels. You get a is equal to negative 37 fifths. So we want a equals negative 37 fifths. All right, let's look at question 3. Again, we're asked to solve each equation. So we have x plus 1 over 4 is equal to, we have this 3x minus 9 over 4x plus 28. And then plus, we have x plus 7 over 4. Okay, so looking at this, my denominator here of 4x plus 28, I'm going to factor that into 4 times the quantity x plus 7. So 4 times the quantity x plus 7. All right, so I'm going to multiply everything by 4 times the quantity x plus 7. That would be the LCD. And I think we probably can't fit this, so I'm just going to do this mentally with you. So this guy right here times 4 times the quantity x plus 7, the 4's would cancel, and you would have x plus 1, that quantity times the quantity x plus 7. Okay, then this equals, here it would cancel, so you just have the 3x minus 9, and then plus, here the 4's would cancel, and so you'd have x plus 7 quantity squared. Okay, so from here, let's see what we have. I'm going to just use FOIL over here, see what we can do. So x times x is x squared. The outer would be plus 7x. The inner would be plus x, so that's 8x. So let's go ahead and put plus 8x. And then plus 1 times 7 is 7. So this equals 3x minus 9, and then plus. And over here, I can use my formula for this. So this is x squared, then plus 2 times x times 7, so 14x. And then plus 7 squared is 49. Okay, so if I have the same thing on each side of an equation, I can get rid of it. You have an x squared here and an x squared here. Again, if you subtracted x squared away from each side, it would disappear. So then negative 9 plus 49 would be positive 40. I'm just going to erase this and put a 40 here. And I can actually just erase this now. I think you have that, so let's get rid of that. And then what else do I have? 3x plus 14x, let's put that as 17x. So this is 17x plus 40 over here on the right, and 8x plus 7 over there on the left. Okay, so let's subtract 17x away from each side of the equation. This right here is going to give me negative 9x. This is going to cancel. Let's subtract 7 away from each side of the equation. That's going to cancel. This equals basically 33 over here. Let me slide down and see what we have. Let's divide both sides of the equation by negative 9. So in the end, this cancels. And what we're going to have is x is equal to, we know this is negative, 33, let's write that as 3 times 11. 9, let's write as 3 times 3. This would cancel. So this is negative 11 thirds. So x equals negative 11 thirds. So this one right here, x equals negative 11 thirds. All right, let's take a look at our quiz. For the first question, we're asked to solve each word problem. And what we're given here is a little work rate problem, or some people call this a rate of work problem. So working alone, it takes Stephen 11 hours to mow the local soccer field. Then we're told that Jacob can mow the same field in only 6 hours. How long would it take if they work together? So for this type of problem, you really don't need a table or anything complicated like that. I would just think about how much does, let's say Stephen, for example, how much of that job does he do in 1 unit of time? In this case, we're working with hours. So in 1 hour, how much does Stephen accomplish? Well, since it takes him 11 hours, in 1 hour, he's done 1 over 11, that amount of that job. Okay, so you can put Stephen here. Let's put Stephen here. So this is clear, and this is for 1 hour. So Stephen, 1 hour. Then what you want to do is add that to the contribution of this other guy, which is Jacob. How much does he do in an hour? Well, it takes him 6 hours to do the whole thing. So in an hour, he's done 1 over 6. So let's put this as Jacob. And again, this is 1 hour. And let me make this a little bit better. Okay, so why did I put an addition sign here? Well, I want to add these two amounts together to figure out, well, if they're combining their efforts here, how much do they do in 1 hour or 1 unit of time together? So what I would do is get a common denominator going. So let's multiply this by 6 over 6. Let's multiply this by 11 over 11. And essentially what I would have is 6 plus 11 over 66, or 17 over 66. Let me erase everything and just put that we have 17 over 66. So we know this is the combined amount of work from Jacob and Stephen in 1 hour, again, when they're working together. So let's multiply this by x for the number of hours it takes to complete one job. And let's just set that equal to 1. And again, once you do enough of these problems, you don't really even need a variable. You're just going to take the reciprocal of this number here, and you're going to get your answer. So most of you already know this is the answer, but let's just go all the way for the sake of completeness. Let's multiply this by 66 over 17, multiply this by 66 over 17, and then this is going to cancel, and you get x is equal to 66 over 17. So this is the number of hours it would take to mow the local soccer field if Jacob and Stephen work together. Okay, let's look at question 2. So we're asked to solve each word problem. And again, another rate of work problem or work rate problem, however you want to say that. So working alone, it takes Clyde 20 hours to paint the outside of a building. And then Sam can perform the same job in 5 hours, while Stephen can complete the job in only 4. how long would it take to finish the job if they all work together? So just like the last problem, again, what is 1 unit of time? In this case, it's hours, so it's 1 hour. If you had minutes, it would be 1 minute. If you had days, it'd be 1 day, so on and so forth. So how much does each person do in that 1 unit of time? Add those amounts together, and then basically you just take the reciprocal of that number. Okay, that's all you really need to do. Well, in this case, Clyde is 20 hours to paint the outside of the building. So let's put 1 over 20. Again, this is 1 unit of time. How much does he do? Then plus for Sam, it's going to be 5 hours. So 1 over 5. Then plus for Steven, it's 4 hours. So let's put 1 over 4. So we're going to sum these amounts here. And basically the LCD would be 20. So let me actually slide this down just a little bit. So I'm going to leave this one alone because the denominator is already 20. I'm going to multiply this by 4 over 4 and this by 5 over 5. And we'll have 1 over 20 plus 4 over 20 plus 5 over 20. And all this is going to give me is 1 plus 4 is 5, 5 plus 5 is 10. So this is 10 over 20, which is basically a half. So if they all work together, in an hour they've done half of the job. So obviously it's going to be 2 hours to complete the whole thing. So let's just erase everything. And again, if you wanted to do this in a more complete way, you could say 1/2 times x. Again, x being the number of hours if they all work together to complete the job. Set this equal to 1 for 1 completed job. And again, just multiply both sides of the equation by 2. This would cancel. You get x is equal to 2, right? So 2 hours, this is our answer. All right, let's look at question 3. So another word problem here, and this one's a motion word problem. So solve each word problem. We have that a plane can travel 2,600 miles with the wind in the same amount of time that it can go 2,200 miles against the wind. If the wind speed is 50 miles per hour, what is the speed of the plane in still air? So let's let x be equal to exactly what we want. So the speed, I'm just going to put in still air. So in still air. And if you wanted to write something out that's longer, so the speed of the plane in still air in miles per hour, again, you can do that for your notes if you want. It's up to you. So I'm going to make a little table. You don't need this, but I think it helps to organize the information if you have a difficult problem like this. So remember, we're using the distance formula where distance is equal to rate of speed times time traveled. So let's just make a little table using this, and I'll just draw this the best way that I can. So let's put this over here, put this over here, and this over here. So the two scenarios, we have with the wind, so we have with the wind, and we have against the wind. So those are the two scenarios there. So we know that x is the speed of the plane in still air. We know the wind speed is 50 miles per hour. So if I'm going with the wind, I want to add 50 to my speed of the plane in still air. And if I'm going against the wind, I want to subtract 50 away from it. So basically, this would be x plus 50 for the rate, and this would be x minus 50 for the rate. Okay, so that's done. Now the distance, we're told that with the wind, it's 2,600 miles. So let's just put 2,600 in here. And then against the wind, let me make this 6 better. And then against the wind, we're told that it's 2,200 miles. So 2,200, just throw that in there. And then how do we get a time? What we're told in the problem is that it's the same amount of time, but that doesn't really help us here when we're trying to fill in the table. So you have to solve the distance formula for t. So in other words, d is equal to r times t, divide both sides by r. So you can get t by itself, and t is equal to d over r. So in other words, we can get t by dividing the distance by the rate. So 2,600 divided by x plus 50. Let me make this a little bit wider here. So that would be my distance here. Let me wrap this in parentheses so it's clear. And let me extend this over here. Okay, so this one would be 2,200 divided by now x minus 50, like this. Okay, so we know that 2 times, again, are going to be equal because it says the same amount of time. So that's how we get our equation. So very straightforward. So we're just going to take this 2,600 over here over x plus 50. I'm going to set this equal to the 2,200 over x minus 50. I'm just going to cross multiply. So this guy times this guy, you'd have 2,200 times the quantity x plus 50. And this equals, you'd have 2,600 times the quantity x minus 50. All right, now I know most of you are working with a calculator, but one thing you could do, you notice you have these 2 zeros here and these 2 zeros here. I could divide both sides of the equation by 100 and basically just knock these zeros off in each position just to work with smaller numbers. Again, I know we're using calculators, but it still makes it a little bit easier to work with. So I'm going to do 22 times x, that's 22x. And then plus 22 times 50. Well, 22 times 5 is 110. So 110, and then put a 0 at the end, so it's 1100. This equals, we'd have 26 times x, that's 26x, and then minus, you have 26 times 50, so 26 times 5 would be 130, and then put a 0 at the end, so you get 1300. So what I'll do from here is subtract 1100 away from each side of my equation, that's gone, and then let's subtract 26x away from each side of the equation, so that's gone. And what we'll have here, on the left, 22x minus 26x is negative 4x. This equals, on the right, negative 1300 minus 1100 is going to be negative 2400. And let's divide both sides of the equation by negative 4 just to finish things up. So this cancels. You get x is equal to, if I do negative over negative, it's positive. 2400 divided by 4 is going to give me 600. So 600 miles per hour is going to be the speed of the plane in still air. If you're going with the wind, it's going to be 650 miles per hour. If you're going against the wind, it's going to be 550 miles per hour. So let's erase everything. Okay, so we got that x was 600 miles per hour. So this is what we want right here. All right, let's take a look at our quiz. So for question 1, we're asked to solve each direct variation problem. We're told if y varies directly with x and y equals 12 when x equals 2, find y when x equals 13. So the first thing is to set up the y equals kx that we talked about in the lesson. And then basically you want to plug in what you're given. So it says y equals 12, so just plug in a 12 there, like this. When x equals 2, so when x equals 2, so let's put a 2k like this. And then basically just divide both sides of the equation by 2, and you're going to find that k here is equal to 6. All right, so if we know k is 6, you're just going to plug in now and say y is equal to, I'm going to put 6 in the place of k, times x, I'm going to put 13. That's really all you're doing. So 6 times 13 is going to give me an answer here of 78. So this is what we want. All right, let's take a look at question 2. We're asked to solve each direct variation problem. So now if y varies directly with x squared and y equals 48 when x equals 4, find y when x equals 7. So now you want to write y equals k x squared like this. And to make it quicker, let's divide both sides of the equation by x squared. So k basically equals y over x squared. So let's plug in here. We're told that y is 48, so let's plug in a 48 there, when x is 4. So I'm plugging in a 4 there, and 4 squared is 16. So 48 divided by 16 is 3, so we know k is 3. So now just plug back in. So y is equal to, you have 3 times x squared. So x is 7 being squared. So 7 squared is 49, so let's put equals here. We have 3 times 49, and this is going to be equal to 147. So this is what I'm looking for right there. Okay, let's look at question 3. So again, we want to solve each direct variation problem. So now we have if y varies directly with x cubed and y equals 40 when x equals 2, find y when x equals 5. So again, let me write this out. So y equals, now it's x cubed, so k x cubed. Again, you can divide both sides by x cubed. So k is equal to, let's say, y over x cubed, and just plug in. So we're told y equals 40, so just put a 40 in here, when x equals 2. So again, you're cubing 2. 2 cubed is going to be 8, and basically 40 divided by 8 is going to be 5. So the value for k that we're working with here is going to be 5. Let me do this in a different color. And then you're just going to plug in for x. So x here is going to be 5. And basically you have 5 to the 4th power here, which is 625, right? So this is 5 to the 4th power, which is 625. So it's going to be this answer right here. All right, let's take a look at our quiz. For the first question, we're asked to solve each inverse variation problem. And we're told if y varies inversely with x and y equals 2 when x equals 5, we want to find y when x equals 20. So hopefully you find these problems to be extremely easy. All you really want to do is write your little formula. So y equals, in this case, you'd have k over x. And you could solve this for k. You could multiply both sides by x. And you could say that k is equal to y times x or x times y, however you want to write that. So the initial setup, and this probably doesn't look so much like a k, so let me try to make that better. The initial setup is given to us. We say y equals 2. So just erase this and put in a 2. You're just plugging in. And it says when x equals 5. So just plug in a 5 there. And this allows me to get the value for k. So 2 times 5 is 10. So k basically equals 10 here. So what you want to do is plug a 10 into this formula here. And then from there, you're just going to plug in what else is given. So it says to find y when x equals 20. So just replace x with 20. And we know that 10 over 20 is 1/2. So y would be 1/2 there. So this is the answer we want. Okay, let's look at question 2. Again, it says solve each inverse variation problem. Another easy one. So if y varies inversely with x squared and y equals 1/3 when x equals 3, find y when x equals 9. So when you get into these problems where you have inverse variation as a power, you need to be more careful. So I'm just going to write this formula. So y equals k over, in this case, it's x squared. And again, you could write this as k is equal to x squared times y. So the initial information given is that y is equal to 1/3. So let's go 1/3 there when x is equal to 3. So be careful here because 3 needs to be squared. So let's put this 3 like this. And we'll put k is equal to 3 squared is 9. And then 9 times 1/3. Well, we know we can cancel one factor of 3 here with this 3 here. And this would be 3 here. So k basically is equal to 3. Okay, get rid of this. We know k is 3. And just plug into this formula here. So put a 3 there. And then it says find y when x equals 9. So just plug in a 9 there. And 9 squared would be 81. So this is just us simplifying a fraction. Each is divisible by 3. This would basically be 1 over 27. So I want this answer right here. Okay, let's look at question 3. So this is a little word problem, and it's not too difficult. So we have the amount of light measured in foot candles varies inversely with the square of the distance from the source. If the amount of light produced 25 feet from a light source is 2 foot candles, find the light produced 5 feet away from that light source. So let's just go through here. I'm just going to use L for the light, which is measured in foot candles. This varies inversely, and I'm going to put my K up here, with the square of the distance from the source. So for distance, let's put D, and this is going to be squared. All right, so it tells us in the initial setup, if the amount of light produced 25 feet away, so the distance is 25. So let me put L is equal to K over 25, and that's going to have to be squared. We'll do that in a moment. It says from a light source is 2 foot candles. So this is going to be a 2 here. Now let's stop for a minute and find the value of K. So we know 25 squared is the same thing as 5 to the 4th power. So we know this is 625. So let's put 625, multiply both sides by 625, and you're going to get that K is equal to 625 times 2 would be 1,250. Okay, so I know that. Let's get rid of this, and let's put 1,250 right there. Now it just tells us to find the light produced 5 feet away from that light source. So I'm just going to plug in a 5 here, and 5 squared is obviously 25. And you can punch this into your calculator. 1,250 divided by 25 is going to give you 50. Okay, so we want this answer right here, which says 50 foot candles. All right, let's take a look at our quiz. So we're asked to evaluate, and what we have here is the square root of 100. And to be more specific, it's the principal, or you could say the positive square root of 100. So what we're asking for here is what positive number, when multiplied by itself, gives me the radicand of 100. Most of you know it's going to be 10 because 10 times 10 is 100. And so we would just list that as our answer. If you didn't know that off the top of your head, you could factor 100 and get the answer anyway. And so we just want to select 10 here as the answer because, again, 10 squared is 100. So the square root of 100 is 10. Okay, let's look at the second question. We're asked to evaluate. And now we have the negative square root of 361. And what we're asking for here, remember, this is a different type of notation. We're asking for what negative number, when multiplied by itself, is going to give me 361. And in this case, it's going to be negative 19. So if I did negative 19, both the negative and the 19, and I squared that, I would get 361. So this is what I'm looking for here, this negative 19. Okay, let's look at question 3. So we're asked to evaluate, and here we have the cube root of 343. So in this case, I'm asking for what number, when multiplied by itself 3 times, because my index is 3, is going to give me this radicand of 343. And in this case, again, if you don't know this, you just have to factor it. It's going to be 7, right? 7 to the 3rd power, or 7 cubed, gives me 343. So this is the answer I'm looking for. All right, let's take a look at our quiz. For the first question, we're asked to use the distance formula to find the distance between the two given points. So the first thing is you would take these points. So I have 0, 7, and then I have 3, 3. You would label one as x sub 1, y sub 1. Let's just pick this one, x sub 1, y sub 1. Again, it doesn't matter which one gets labeled as which. So the other one will need to be x sub 2, y sub 2. So in other words, I could have labeled this one as x sub 2, y sub 2, and this one as x sub 1, y sub 1. You'll get the same answer. So what I'm going to do is use my distance formula. So the distance between the 2 points is equal to the square root of, you have this x sub 2 minus x sub 1 quantity squared, then plus your y sub 2 minus y sub 1, again, quantity squared. So I'm just going to plug into the formula. So x sub 2 here is 3, and x sub 1 here is 0. So 3 minus 0 is just 3, and 3 squared would be 9. So let's put that in there. And then y sub 2 is going to be 3. So let's put that in there. And then y sub 1 is going to be 7. So 3 minus 7 is negative 4, and negative 4 being squared is 16. So you get 9 plus 16 underneath the square root symbol. 9 plus 16 is 25. So you want the principal square root of 25, which is going to give you positive 5. So the distance between these 2 points is going to be 5 right there. That's your answer. Okay, let's look at the second question. Again, we want to use the distance formula to find the distance between the 2 given points. And what we have here is negative 6 comma 12. And then we also have this negative 18 comma 17. Okay, so let me label this as x sub 1, and then this will be y sub 1, and this can be x sub 2, and this will be y sub 2. Okay, so just plug into the formula. So the distance between the 2 points is equal to the square root of, you have x sub 2, which is negative 18, minus x sub 1, which is negative 6. So be careful here. Minus a negative is plus a positive. So I'm going to put negative 18 plus 6. And this is going to be squared. Then plus your y sub 2, which is 17, minus your y sub 1, which is 12, quantity squared. Okay, so negative 18 plus 6 is going to give me a negative 12. And negative 12, if I was to square that, I would get 144. So this is 144. And then 17 minus 12 is 5. 5 squared is obviously 25. So let's put this as 25. If I add 144 plus 25, that's 169. And then the square root, or at least the principal square root of 169, is going to be 13. So the distance between these two is going to be 13. Let me make this 3 a little bit better. So I want this answer right here. Okay, let's look at question 3. So again, we want to use the distance formula to find the distance between the 2 given points. Okay, so we have this negative 2 comma 9, and then we have this negative 1 comma 11. Again, I'm just going to switch it up in terms of the labeling. Let's say this is x sub 2 and then y sub 2, and this is x sub 1 and this is y sub 1. And again, you can do this. You can switch the labeling around. You'll get the exact same answer. So we're going to have d, the distance between the 2, is equal to the square root of. So let's start with x sub 2 minus x sub 1. So this will be negative 2. Again, if you have minus a negative, you have to be very careful. Minus a negative is plus a positive. So this is plus 1, quantity squared. And then plus, you have this y sub 2, which is going to be 9, minus y sub 1, which is 11, quantity squared. Okay, so negative 2 plus 1 is going to give me negative 1. And if I square negative 1, I get positive 1. So this is just 1 here. Then 9 minus 11 is going to be negative 2. So this is negative 2. And if this is squared, this gives me 4. So here I have 1 plus 4, that's 5. And basically, the distance between these 2 points is the square root of 5. This is an irrational number, so I really can't simplify this any further. So I'm just going to select this answer here, which is the square root of 5. All right, let's take a look at our quiz. So for the first question, we're asked to simplify. And we have the square root of 5 multiplied by the square root of 20. So the idea here is to first break these guys up. So in other words, what I want to do, the square root of 5, I really can't do anything with that at this current moment in time. But the square root of 20, you could factor 20 into 4 times 5, or you could do 2 times 2 times 5 if you wanted to. So let's put this as equal to, I'm going to keep the square root of 5, and then I'm going to write this as the square root of 5, and then times the square root of 4. Now 4 is a perfect square, right? It's 2 times 2. So really I can just replace this with a 2. Let me put that out in front. And then the square root of 5 times the square root of 5 is 5. So 2 times 5 is just 10. So the answer here is 10. Come back up here. This is what we want. Okay, let's look at the next one. So for question 2, we're asked to simplify. And it looks like we have 2 times the square root of 8. And this is over the square root of 9. All right, let's put this here. So we have 2 times, I'm going to break the square root of 8 up into the square root of 4. And then times the square root of 2. And this is over. We know the square root of 9 is just 3. Okay, so for the square root of 4, I'm going to replace that with 2. So you would have 2 times the square root of 2 over 3. And this will just end up being 4 times the square root of 2 over 3. I can't make the square root of 2 any simpler, so this is going to be my answer. So I want this one right here, 4 times square root of 2 over 3. Okay, let's look at question 3. So again, we're asked to simplify. looks like we have negative 5. This is multiplied by the square root of 7x squared. Then times, we have 4 times the square root of, looks like 2x cubed. Okay, so the idea here is just to do the same thing, but now you have variables involved. So here's where you really have to lean on your product rule for exponents, but going in reverse. So let's start with these numbers. You have negative 5 times 4. Let's just put negative 20 here so we don't have to deal with that. I'm going to break this guy up. 7 is a prime number. You're not going to be able to factor that. So let's put times the square root of 7 and then times the square root of x squared. We already know that the square root of x squared will be x. We'll replace that in a moment. Then times, I already dealt with this 4. So 2, again, is a prime number. So let's put the square root of 2 like this. Can't do anything with that. And then times, you have the square root of x cubed. Now, again, you want to factor this. I know when it's a variable, it's more difficult to think about. The index here, although it's not shown, is a 2. So you need to make this match this so that you can simplify. So what you're going to do is use your product rule for exponents in reverse. So I'm going to write this as x squared times x. You could put to the first power if you need that for clarity. Again, x would stay the same. 2 plus 1 would get you back to 3. So you're just rewriting this. And then what I would do here is break this up further and put this as the square root of x squared times the square root of x. Okay. In this guy right here, we have negative 20, and then times the square root of 7 times the square root of 2 would be the square root of 14, and then times the square root of x squared is x, and then times the square root of x squared is x, and then times you have the square root of x. I'm just going to write this as negative 20 right here. Then times you have x times x, which is just x squared. Then times the square root of the things that didn't simplify. So you have 14 times x, so 14x like this. So that would be my answer. So it looks like we want this one, negative 20x squared, then times your square root of 14x. So that's our answer. All right, let's look at our quiz. For the first question, we're asked to perform each indicated operation. So we'll have negative 2 times our square root of 5, and then minus 3 times the square root of 5. So these two guys are like radicals. You have the same index. In each case, you have a square root, and you have the same radicand. In each case, the radicand is a 5. So when this happens, all you have to do is keep that guy the same. So in other words, I'm going to keep the square root of 5 there, and then I'm just going to perform the operations with the numbers here. So the negative 2 minus 3, that's just going to give me negative 5. So this gives me negative 5 times the square root of 5. So I want this guy right here. Okay, let's look at question number 2. Again, we're asked to perform each indicated operation. So we have 4 times the square root of 8, and then plus 5 times the square root of 8 like this. So again, you have like radicals here. You have square root of 8 and square root of 8. So I'm just going to write the square root of 8 here. And then I'm going to go 4 plus 5, which is going to give me 9. But this is not actually simplified. And the reason it isn't is because the square root of 8 can be further broken down. So let's write this as 9 times, 8 is 4 times 2. So let's put the square root of 4 and then times the square root of 2 like this. We know that the square root of 4 is 2. So this is 9 times 2 times square root of 2. And then we'll finish this up by saying 9 times 2 is 18 and then times the square root of 2. So it looks like I want this answer right here, 18 times the square root of 2. All right, let's look at question 3. We're asked to perform each indicated operation. So we're going to have 2 times the square root of 18 and then minus 3 times the square root of 18, and then minus 2 times the square root of 2. All right, so you do have like radicals here and here, but not here. So before you go through and make this determination, you want to simplify things, but to make it a little bit quicker, what I would actually do here, and you don't have to do it this way, you can do it a longer way, I would actually combine these two first. So you know that the square root of 18 would stay the same. And I would do 2 minus 3, which is negative 1. So you could put negative 1 there or just put a negative in front of this square root symbol. It's really up to you. So then minus 2 times square root of 2. So don't report this as your answer. You want to take the time to try to simplify this because in most cases, they're going to give you problems where when you break them down further, you can actually add or subtract. So this guy right here is going to be 9 times 2. And I know 9 is a perfect square. So let me write this as, I'm going to put negative 1 times the square root of 9 times the square root of 2, and then minus 2 times the square root of 2. Let's put equals here. I know this right here is 3. So basically now I have negative 3, and then times the square root of 2, minus 2 times the square root of 2. And again, now I have like radicals. So you can see that we started with something that didn't look like it was going to be like radicals. We simplified, and now we have like radicals. So you always want to make sure you take that step because most of the time, they're going to give you problems that work out this way. Okay, so keep the square root of 2 the same, and then just work with these numbers here. So negative 3 minus 2 is going to be negative 5. And I probably should have given myself more room there. So negative 5 times square root of 2 is our answer. So coming back up here, I want negative 5 times the square root of 2. All right, let's take a look at our quiz. For the first question, we're asked to simplify each. And what we're given is the square root of 4. This is over 5 times the square root of 5. The first thing I would do is replace the square root of 4 with 2. And then to simplify further, remember, you don't want a radical in the denominator. So to get rid of this square root of 5 from the denominator, I'm going to multiply the numerator and denominator by the square root of 5. So this gives me 2 times the square root of 5 in the numerator. In the denominator, square root of 5 times square root of 5 is 5. So basically you would have 5 times 5, which is just 25. So let's replace that. And so the simplified version here would be 2 times square root of 5 over 25. So we want this answer right here. All right, let's look at question 2. So again, we want to simplify each, and we're given negative 3 over 3 times the square root of 2. So obviously you have a common factor of 3 between numerator and denominator. To make this simple, let's just erase it from here and here and put a negative 1 there, just to make it nice and clean. And then from here, we still have a radical in the denominator. So let's multiply the numerator and denominator of this fraction by the square root of 2. And that's going to give me negative square root of 2. You can put negative 1 times square root of 2 if you feel more comfortable with that. And then over square root of 2 times square root of 2 is 2. So what I want is this answer right here, the negative of the square root of 2 over 2. All right, let's look at question 3. So we're asked to simplify each. And so what we have is 5 times the cube root of 2. And this is over 3 times the cube root of 4. So it's not as straightforward as in the other examples because we have a cube root here. So you can't just multiply the numerator and denominator by the cube root of 4. That's not going to work. What you need to do is think about 4. And I would factor it and say, well, 4 is 2 times 2. So what do I need to multiply this by to get a perfect cube? Well, I need another factor of 2, right? So 2 times 2 times 2, or 8, would be a perfect cube, right? It's 2 to the third power. So what I can do here is multiply the numerator and denominator by the cube root of 2. And what that's going to do, in the numerator, you would have 5 times the cube root of 2 times 2 would give me 4. In the denominator, you would have 3 times the cube root of 4 times the cube root of 2 would be the cube root of 8. And we know the cube root of 8 is 2, so you can replace this with a 2, and 3 times 2 is simply going to give you 6. So I'm looking for this answer right here, which is 5 times the cube root of 4 over 6. This is what we want. All right, let's take a look at our quiz. For the first question, we're asked to simplify. Looks like we have the square root of 15, and this is multiplied by the quantity 3 plus the square root of 3. All you really need to do here is use your distributive property. So square root of 15 times 3 is just 3 times the square root of 15. And then plus square root of 15 times square root of 3. Well, I'm going to do this as the square root of 3 times the square root of 3 times the square root of 5. I just broke the square root of 15 up into the square root of 3 times square root of 5. And so square root of 3 times square root of 3 is 3. So let's put this right here as 3 times the square root of 5 like this. And so basically you have your answer. You want 3 times the square root of 15 plus 3 times the square root of 5. So this guy right there. Okay, let's look at the second question. So we're asked to simplify. And it looks like we have the negative of the square root of 6 plus 5. And then we'll have 4 times the square root of 6 and then plus 5. So let's use FOIL here. I'm going to put this as a negative 1 to make it a little bit easier. So negative 1 times 4 will be negative 4. Square root of 6 times square root of 6 is 6. So this is basically negative 24. Now the outer, you have negative 1 times 5, that's minus 5, and then times your square root of 6. Your inside, you have 5 times 4, that's 20, and then times square root of 6. At this point, you can combine these guys because you have like radicals. So negative 5 plus 20 is positive 15. So let's put plus 15 here and get rid of this. And then lastly, we have 5 times 5, which is going to be 25. And then as a final step, you have 25 plus negative 24. That's going to be positive 1. So let's write this as 1 plus 15 times the square root of 6. So we want this answer right here. All right, let's look at question 3. We're asked to simplify. So we have 5 over, we have negative 5 minus the square root of 5x. So the idea here, you have a two-term denominator. You can't just multiply the numerator and denominator by the square root of 5x. You need to use the conjugate of this guy. So I'm going to multiply the numerator and denominator by negative 5. Instead of this being a minus, it's going to be a plus. And then the square root of 5x. So negative 5 plus the square root of 5x. And so in the numerator, 5 times negative 5 is negative 25. And then plus, you'll just have 5 times the square root of 5x. Then over here, in the denominator, you're going to use, let me wrap this in parentheses here so this is more clean, and I can actually do this up here. But in the denominator, the middle terms, if you were to do FOIL here, they're going to drop out, right, because you have conjugates. So square the first guy. Negative 5 being squared is 25. And then subtract away, square the last guy. The square root of 5x times the square root of 5x, or the square root of 5x being squared. Let me actually show this. The square root of 5x like this being squared is just going to give you 5x. So this is 5x. Now, don't stop and report your answer because you can see that you could pull out a 5 from here, 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 and here. So we want to do that. Let's just take that step here. And I'm going to pull a 5 out. That will give me negative 5 plus square root of 5x. And then over, if I pulled a 5 out from there, that would give me 5 minus x like this. And then I'm going to cancel a common factor of 5 between numerator and denominator. So this is going to give me negative 5 plus the square root of 5x. This is over 5 minus x. So this is what we're looking for right here. We want negative 5 plus the square root of 5x, and then over 5 minus x. All right, let's take a look at the quiz. For the first question, we're asked to solve each equation. And what we have here is the square root of 3x is set equal to 3. All right, so the idea here is to isolate this square root on one side of the equation. That's done for us already in this problem. And then we're just going to square both sides to clear that radical. So on the left-hand side, this basically will cancel with this, and I have 3x. And this will be equal to 3 squared will be 9. Let's solve this equation by dividing both sides of the equation by 3, and we get x is equal to 3. Now let me actually erase this. Remember, we always need to check any proposed solution. I'm going to plug in a 3 here. So I'm just going to plug that in right here. And basically what you'd have here is the principal square root of 9 is equal to 3. And that is a true statement. You get 3 equals 3. So we'll check that off and say x equals 3 is the correct solution here. So we'll come back and say x equals 3 is what we want. Okay, let's look at the second question. So now we have 8 is equal to the square root of 12x plus 4. Okay, so the first thing I'm going to do is just square both sides. Again, this is already isolated for me. So if I square 8, I get 64. And this is equal to, if I square the square root of 12x plus 4, I just get 12x plus 4. And then I'm just going to solve this like I normally would. So I'm just going to subtract 4 away from each side of the equation. And so this will actually cancel over here. I'm going to flip this around. I like my variable on the left. This is unnecessary, but this is just how I like it. I'm going to put 12x is equal to 64 minus 4 is going to give me 60. I'm going to divide both sides of the equation by 12 and find that x is equal to 5. Again, you always want to check any proposed solutions. So we're saying x equals 5, and we'll plug that in there. And you can eyeball this and see it's going to work. 12 times 5 is 60. 60 plus 4 is going to be 64. And the principal square root of 64 is 8. Just for completeness, let's go ahead and do this. We'll say the principal square root. Again, 12 times 5 is 60. 60 plus 4 is 64. So we get 8 is equal to 8 here. So this does check out. So x equals 5 is our solution. So coming back up, this is the one we want. X equals 5. Okay, let's take a look at question number 3. So we're asked to solve each equation. We have the square root of 2x minus 3. This is that equal to the square root of x plus 1. Okay, what I'm going to do here, since I have a radical isolated on each side, I'm just going to immediately square both sides. Let me actually show that here so that nobody is confused. And so we see that in each case, this cancels with this, right? So here and here, and maybe make that a little bit better. And then just coming down here, I'm going to be left with the radicand. So 2x minus 3 is equal to the radicand over here, so x plus 1. I'm actually going to undo this because we're going to need to check it. So rather than writing it again, let's just erase this here. So we're going to come back to this once we have our solution. I'm just going to go ahead and subtract x away from each side of the equation. That'll cancel. Let's add 3 to both sides of the equation. That will cancel. So 2x minus x would be x, and this equals 1 plus 3, which is 4. So x equals 4 is my proposed solution. So let me write that off to the side. I'll just put x equals 4 here, plug that in here, and plug that in here. you would get the square root of 2 times 4 is 8. 8 minus 3 is 5, so square root of 5 is equal to, here 4 plus 1 is 5, so square root of 5. So principal square root of 5 is equal to the principal square root of 5. So yes, x equals 4 is the correct solution. So come back here and we'll circle x equals 4. All right, let's look at our quiz. So we're asked to write each expression in radical form. And what I'm given here is 6x, and this is raised to the 3/2 power. So what I'm going to do here is just first set up a little radical. So let's set that up. And then we know the denominator here is the index for the radical. So in this case, it's a 2. If you have a square root or an index of 2, you generally don't write it. It's understood. So then you're going to take this 3, and there's a lot of different ways to write this. So basically this 6x here is raised to the 3rd power. You could write 6 raised to the 3rd power times x raised to the 3rd power. You could keep it like this. Or a lot of times people will write it like this, which is how the answer is formatted. So basically you have the square root of 6x being cubed. So this is the square root of 6x being cubed like this. So that's what we want. All right, now let's look at question 2. We're asked to simplify. So we're going to have 8x to the 6th power. And this is going to be raised to the 4/3 power. And what I would do here is first write this in radical form. So I would take this part right here, this 8x to the 6th power, and I would put it as the cube root of that guy, because again, the denominator here is 3. And then I would wrap this in parentheses and say it's raised to the 4th power. So this is how I would personally do it. This is going to give you something smaller to work with before you raise it to the 4th power. So thinking about 8, I know it's a perfect cube. So let me rewrite this. And so we'll say this is the cube root of 8, and then times the cube root of x to the 6th power. And let's go ahead and wrap this in parentheses and put this to the 4th power. And we already know that we can replace this with a 2. So let's write this as 2, and then basically times, how can we simplify this? We've talked about this before. If this guy right here, this exponent, is divisible by this index, you can just divide. So 6 divided by 3 would be 2. So basically you would simplify that and say that this is just x squared. So then wrap this and put this to the 4th power. And so now we would just say, okay, well, 2 is raised to the 4th power. So you put 2 to the 4th power, or 16. And then x squared is raised to the 4th power. So x stays the same. Multiply exponents. 2 times 4 is going to give me 8. So I come up with 16x to the 8th power. And so this is what we want right here, 16x to the 8th power. Okay, let's look at question number 3. Here we're asked to simplify, and we have 64x cubed. And this is raised to the power of negative 4/3. So the first thing I'm going to do, again, is write this in radical form. So let's put this as 64x cubed. And then I'm going to say the cube root of that, because again, this denominator is 3. And then I'm going to raise everything to the power of negative 4. All right, so let's deal with the inside of this real quick. I think this is pretty easy. Most of you know that 64 is a perfect cube. It's 4 times 4 times 4. So you could really erase this and just put 4 cubed like this, or even better, you could put 4 times x being cubed like this, and then you can see this index would cancel with this exponent. And essentially what you have here is 4x being raised to the power of negative 4. And all this is I'm just going to drag this across the fraction bar and change the sign of the exponent. So in other words, this would be 4x raised to the 4th power like this. And then what we do to finish this up and say this is 1 over 4 to the 4th power times x to the 4th power. And 4 to the 4th power is going to be 256. So we'll put 1 over 256 x to the 4th power. So coming back up here, I want 1 over 256 x to the 4th power. That's going to be my answer. All right, let's take a look at our quiz. So for the first question, we're asked to solve each equation using the square root property. So what we're given is x squared, then minus 2 is set equal to negative 2. So the idea here is I want to get x squared on one side of the equation by itself. So what I'm going to do is I'm going to add 2 to both sides of the equation. This will cancel away. So you'll have x squared is equal to negative 2 plus 2 is 0. And so essentially you can just use your property and say, well, if x squared equals 0, then x equals basically 0, right? You can't have the two solutions here because 0 is not positive or negative, so it's not going to work out that way. So we'll just say x is equal to 0 here. So let's come back up and say x is equal to 0. All right, let's look at question 2. So now we have negative 5, x squared is equal to negative 80. All right, so first let's get x squared by itself. To do that, I have negative 5 that's multiplying x squared. So I'm going to divide both sides of the equation by negative 5. And so what's going to happen is this is going to cancel. you're going to have x squared is equal to negative 80 divided by negative 5 is going to be positive 16. So from here, I'm going to say x is equal to, again, the principal square root of 16, then or x is equal to the negative square root of 16. So these two right here would be our solutions. So we get x is equal to square root of 16 is 4. And then the negative square root of 16 is negative 4. And again, a lot of people write this as x equals plus or minus 4. It's really up to you. Let's go back up. So we want x equals negative 4 and then positive 4. Those are our two solutions. Okay, let's look at question 3. So again, we want to solve each equation using the square root property. So we're going to have 3x squared plus 3 is equal to 156. All right, so the goal is to isolate x squared to start. And let's get this first term here, 3x squared, to be isolated on the left. So let me subtract 3 away from each side of the equation. This will cancel. You'll have 3x squared is equal to 156 minus 3 is going to be 153. Then if I want x squared by itself, I'm going to divide both sides of the equation by 3. And so this is going to give me x squared is equal to, let me show this is canceling. 153 divided by 3 is going to be 51. So again, we know that if x squared equals 51, then x is equal to, let's just go ahead and shorten this and put plus or minus the square root of 51. Now 51 is 17 times 3, so you're not going to be able to simplify that any further. So you get x equals square root of 51 and then x equals the negative square root of 51. So coming back, x equals the square root of 51 and then x equals the negative square root of 51. So we want that answer right there. All right, let's take a look at our quiz. So we're told to solve each equation by completing the square. And we're given x squared, then minus 14x, then plus 40. And this is set equal to 0. All right, so completing the square, I know a lot of you don't like this method. It's just something you have to do a lot of practice with. The first thing I'm going to do is I'm going to move this 40 to the right-hand side so that I can have all my variable terms on one side and a constant on the other. So to do that, I'm just going to subtract 40 away from each side of the equation. This is going to cancel here. So what we're going to have is x squared, then minus 14x is equal to negative 40. Now, if I'm completing the square, I always want to make sure that the coefficient on the squared variable is a 1. In this case, that's already done for us, so we don't really need to do anything else there. We can move into our procedure where basically we look at this coefficient here, which is negative 14. Remember, it's the coefficient for the variable raised to the first power. And we're going to cut it in half, or in other words, multiply it by half, and then square that. That's going to get added to both sides of the equation. So let me actually rewrite this over here. I'm going to put x squared, then minus 14x. And then what we'll have is plus, I'm going to go 1/2 times this negative 14. So negative 14. And then once I'm done with this, I'm going to square it. Okay, and I'm going to add this to both sides. So I'm going to do it over here. Let me simplify this first. Negative 14 divided by 2 is negative 7. So this is negative 7. And then if I square that, it's going to be positive 49. So let me put plus 49 over here. And again, to make that legal, let me put the negative 40 and then plus 49 over here. So again, I added the same thing to both sides of the equation, so I didn't do anything illegal. So now what I'm going to do, on the left side, I have created a perfect square trinomial. And so I can factor this into a binomial squared. So this is x minus 7 quantity squared. On the right-hand side, I'm just going to simplify. Negative 40 plus 49 is simply 9. And then from here, I can just use my square root property to solve the equation. So what I'm going to do is I'm going to take the square root of this side, and then let me scooch this down a little bit. I'll need to go plus or minus the square root of this side. And so what's going to happen is this will cancel with this, and I have the x minus 7 here will be equal to plus or minus the square root of 9. So let's go plus or minus 3. All right, so we have two equations to solve here. So basically you want to do x minus 7 is equal to 3, and then or x minus 7 is equal to negative 3. So we need to solve both of those. Again, very easy equations to solve. Let's add 7 to both sides of the equation here. This would be x is equal to 10. And then over here, let's add 7 to both sides of the equation. This will cancel. This will be x is equal to negative 3 plus 7 is going to be positive 4. So basically, my solutions here would be x is equal to 4, then or 10. So coming back up here, I want x equals 10 and then 4. Okay, let's look at the second question. Again, we're asked to solve each equation by completing the square. So now we're given x squared and then plus 14x and then minus 15. We're going to set this equal to 0. Okay, so again, what I'm going to do is I'm going to add 15 to both sides of the equation just to kick things off. So now I have all my variable terms on one side. So I have the x squared and then plus the 14x. And then I'm just going to leave a space here, and we'll say this is equal to 0 plus 15 is just 15. Okay. So what goes here, again, you're going to cut this in half and square it. So basically 14 times a half is 7. 7 squared is 49. So we have 49 once again, just like we had in the last example. And so what we're going to do here is factor this now into x plus 7 quantity squared. And this will be equal to, what is 15 plus 49? Well, that's going to give me positive 64. Okay, so again, we can solve this using the square root property. So I'm going to take the square root of this side, and then let me slide this down so it will fit. Then plus or minus the square root of this side. So this will cancel, and you'll basically have x plus 7 is equal to plus or minus the square root of 64 is 8. So again, you just have two equations that you need to solve here. So x plus 7 is equal to 8. Then the other one, we're going to have x plus 7 is equal to negative 8. Again, very easy to solve these equations. On the left, let's subtract 7 away from each side. This becomes x is equal to 1. And then on the right, let's subtract 7 away from each side. And this becomes x is equal to negative 15. So the solutions here, we have x is equal to 1 or negative 15. So coming back up here, we want this one, x equals 1 or x equals negative 15. Okay, let's look at question number 3. Again, we're asked to solve each equation by completing the square. So now we have 6x squared minus 48. This is set equal to negative 12x. All right, so I want all my variable terms on one side and I want my constant to be on the other. So what I'm going to do is add 12x to both sides of the equation. Let me actually slide this down a little bit, because what I'm going to do here is add 48 to both sides of the equation. So let's show this as canceling, and this is canceling. So on the left-hand side now, I have 6x squared, then plus 12x, and this equals positive 48. Now again, this is something that you can't forget to do. A lot of times students get easier problems, and then they forget to do it when they get a harder problem. Remember, this guy right here, this leading coefficient, or this coefficient for x squared, has to be 1, okay? So if it's not 1, you have to divide every term in that equation by that coefficient so that you can create a 1 there, okay? So what I'm going to do here is I'm going to divide this by 6, I'm going to divide this by 6, and I'm going to divide this by 6. So this cancels, it becomes 1. So now you have 1x squared, or just x squared. Then plus 12 over 6 is 2, so I have 2x. And this equals 48 divided by 6 is going to be 8. Okay, so from here, what I'm going to do, again, is take 1/2 of this. Half of 2 is 1, and then I'm going to square it. So cut it in half, then square it. So I'm going to have x squared plus 2x plus, again, half of 2 is 1, 1 squared is 1. This equals 8 plus 1. So I added 1 to this side and 1 to this side. So I'm just going to say this is going to factor into x plus 1 quantity squared. And this will be equal to 8 plus 1 is going to give me 9. Okay, so from here, again, I can just solve this using the square root property. Let me move this down, and let me move this over a little bit so that we can fit everything on the screen. And so what I'm going to do here is take the square root of this side and then go plus or minus the square root of this side. So this will cancel. You'll get x plus 1 is equal to, the square root of 9 is 3, so let's go plus or minus 3 over here. So again, just two simple equations to solve. X plus 1 is equal to 3, then or x plus 1 is equal to negative 3. Let's subtract 1 away from each side of the equation. And so let's cancel this and say x is equal to 2. Then or let's subtract 1 away from each side of the equation. Cancel that. X is equal to negative 3 minus 1 is going to be negative 4. So you get x equals 2 or x equals negative 4. Let's write this as x equals 2 comma negative 4. Coming back up here, so I want this one, x equals 2 or x equals negative 4. All right, let's take a look at our quiz here. So for the first question, we're asked to solve each equation using the quadratic formula. So let's write out our problem. So we have 5x squared minus 9x plus 8 equals 4. And so for the quadratic formula, remember you want to first write this in standard form. So let's subtract 4 away from each side of the equation. Let's get rid of this and put this as a 0. 8 minus 4 would be 4. And then you want to identify the a, or the coefficient for x squared, the b, which in this case is negative 9. Make sure you take the sign with it. That's the coefficient for x to the first power. And then the c, which is your constant. In this case, that's 4. Okay, so you're going to plug into the formula. So x equals, you're going to have the negative of b plus or minus the square root of b squared minus 4ac, and then this whole thing is over 2a. So we're just going to plug into the formula. So for b, I'm plugging in a negative 9. This negative out here stays out there. You plug in a negative 9, now you have the opposite of negative 9, and so essentially that becomes positive 9. So this is positive 9 here. That's a very common mistake to just put negative 9 there and not flip the sign. So you got to be careful. Then here, b is squared. So I'm going to have negative 9 being squared, that's 81. Then 4 times a is 5. And then times c is 4. Let's just do 5 times 4, that's 20, so that we can go a little bit faster. And then down here for a, this is going to be 5. So I already know this is 10, so let's replace this. 4 times 20 is 80. And so 81 minus 80 is 1. Square root of 1 is 1. So basically what I get is x equals 9 plus 1 over 10, which would be 10 over 10 or 1. And then I get x equals 9 minus 1 over 10, which is 8 over 10, which would be 4/5. So basically, let me do this a little bit slower so that nobody's lost. Basically, you would have x is equal to 9 plus 1 over 10, which is 10 over 10 or 1. Okay, so that's the first solution. Then the second solution, I'll just put or here. We're going to have x is equal to, you're going to have 9, now the minus 1 over 10. Let me slide down here. And basically what you're going to get here is 8 over 10. Again, 8 is divisible by 2, so that would be 4. 10 is divisible by 2, so that would be 5. So this is 4/5. So x is either 1 or 4/5. So coming back up here, we want x equals 1 or 4/5. All right, let's look at the second question. Again, we're asked to solve each equation using the quadratic formula. So we have negative 7 minus 7x. This is set equal to negative x squared and then minus 9x. Okay, so what I would do here is add x squared to both sides. So let's just write x squared here, and I'm going to cancel this. And then I'm going to add 9x to both sides. So let's put this over here. Remember, if everything cancels away here and you're doing addition and subtraction, it's a 0 over here. So make sure you write that. So over here, we're going to have negative 7x plus 9x. That's going to be positive 2x. Don't forget about this negative 7. And this equals, again, if everything canceled over here and you're using addition and subtraction, make sure to put a 0. This trips up a lot of students because sometimes they cancel things and forget it and they don't have an equation anymore and they're wondering what to do. So from here, remember, you just want to identify the coefficient for x squared is 1. So let's put that as a. This is b. And then this is c, right? So b is the coefficient for x to the first power, and c is going to be your constant. And always make sure to take the sign into account when you do this. So what I want to do is plug into that formula. So x equals, again, you have the negative of b plus or minus the square root of, you have b squared minus 4ac all over 2a. So for a, you're going to plug that in here. It's going to be 1, so you can just leave it. Here, you just erase it because, again, 1 times anything is itself, so just erase it. For c, it's going to be negative 7. So let's plug that in here. Let's plug that in here. We'll do the calculation in a second. And for b, it's positive 2. So 2 squared, let's just do that real quick. That's going to be 4. And this would be negative 2 right here. And so negative 4 times negative 7 is positive 28. So this is plus 28 like this. And 4 plus 28 is going to be 32. Now 32 is not a perfect square. So what you'd want to do is simplify this and say that this is 16 times 2 inside of here. Square root of 16 is 4. So what you're going to do is say 4 times the square root of 2 here. So this is 4 times the square root of 2. So that is taken care of there. Now you can make this a little bit better because what you'll notice is this is divisible by 2, so is this, and so is this. So what you'd want to do here is factor that out, that 2. So I'm going to say this is 2 times, inside of here I'd have negative 1, then plus or minus 2 times the square root of 2, and this will be over 2. And again, all I'm going to do is cancel this common factor of 2 with the numerator and denominator. And so this is going to give me that x is equal to negative 1 plus or minus 2 times the square root of 2. So this is what I'm looking for. So it looks like this answer here, x equals negative 1 plus or minus 2 times square root of 2. So this is what we want. All right, let's look at question 3. Again, we're asked to solve each equation using the quadratic formula. So we have negative x squared and then minus 4. This is equal to negative 4x squared and then minus 8x and then plus 7. All right, so again, I want to get this into standard form. So let me add 4x squared to both sides of this equation. That's gone. And so negative x squared plus 4x squared is 3x squared. And then let me add 8x to both sides of the equation. So plus 8x, that cancels. Let's put plus 8x here. And let me subtract 7 away from each side of the equation. Let me slide this down here so this all fits. I'm going to subtract 7 away from there. This is going to cancel. Remember, I'm going to put a 0 here because everything has canceled away. So over here, negative 4 minus 7 is going to be minus 11, and this equals 0. So just writing this in standard form, again, that's always your first step. Then you can get your values for a, b, and c. So this is a, the coefficient of x squared. This is b, the coefficient for x to the first power. And this is c, your constant. Again, always make sure to take the signs with you. Our quadratic formula is x equals, you have the negative of b, plus or minus the square root of b squared minus 4ac all over 2a. So a in this case is 3. So let me go through here. Everywhere I have an a. Let me plug in a 3. And I already know this is going to be 6, so let's just replace it. And then up here, let's put a 3 here. And c is negative 11, so let's put a negative 11 there. Make that a little bit bigger. And b is 8. 8 squared is 64, so let's write that in. And this would be negative 8 there. All right, so let's see where this goes. Negative 4 times 3 is going to be negative 12. And negative 12 times negative 11 is going to be positive 132. So this would be 64 and then plus 132. So this is going to give me 196. And if you punch up square root of 196 into your calculator, you're going to get 14. So let's erase this and put 14 here. And so before you do anything, you could make this a little simpler. Maybe it's a waste of time, maybe not, but you notice that everything here is divisible by 2. So let's just do this for the sake of completeness. I'm going to factor out a 2, and I'm going to say this is negative 4, plus or minus, we'll have the 7 here. This is over 2 times 3. And I realize you're using a calculator, so this is probably unnecessary, but I'm just going to cancel this away anyway. And so what we'll say is that x is equal to negative 4, and then plus or minus 7 over 3. So let's get our two solutions. We'll say x is equal to negative 4 plus 7 is going to be positive 3. So positive 3 over 3. Let me make this 3 better. This would be 1. So x equals 1 is one of the solutions. And then the other solution is that x is equal to, you have negative 4 minus 7, which is negative 11 over 3. And maybe I'll put the negative out in front like this. So I'm looking for x equals 1 or x equals negative 11 thirds. So I want this answer right here, where x is 1 or negative 11 thirds.